Hello, 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 hello. Good morning, everyone. How are we this good, fine morning? We're good? Amazing. If you can hear my voice, but you are not sitting in a chair watching the talks, then you are not in the right place currently. If you are sitting and watching the talks and you're seeing my face, then you are in the right place. So welcome. Good job, everyone. So hi, my name is Yanni. You met me yesterday. I know I'm hard to recognize. I'm not wearing a hat today, but I'm still the same guy. Don't worry, nothing has changed. We also have Nathaniel, who is sitting out there in the back watching the talks, and we'll be seeing him later today. So we are your hosts today here at App.js, and hello to people at home as well. I'm just going to keep talking for a couple of minutes while waiting for people to stream in. So yeah, what should we talk about? Did you say goats? Good, because for a moment I thought just ghosts, and I was like, I do have a good ghost story, but I don't know if it's appropriate for this venue. I also have very little to say about goats. I learned yesterday in the talk that the word for goats in French is chèvre, which makes sense, but I always thought it was just a goat cheese, but it's fromage de chèvre. So this is why we come to conferences, people. We learn about so much. We learn about JavaScript and French. So I do recommend coming to these events. They are educational bounties. All right, so we have a couple of bits of housekeeping. Number one, if you weren't here yesterday or you weren't paying attention, which I wouldn't blame you for, you may not know about the App.js app. But please do get the App.js app, and in that you have a little QR code scanner, and if you go and you visit all the sponsor booths, if you catch them all, you can go to the Software Mansion booth over there and get some sweet Software Mansion merch. It's actually really high quality stuff. I don't know why the rest of the world doesn't do it, but Poland always delivers when it comes to the merch. Are you hearing my voice? I'm hearing a lot of chatter in the background. So please do make your way to the main stage. And if you are not at the main stage yet and you can hear my voice, then you probably see the banners over there asking you to keep your voice down. So basically, because today we've been blessed with great weather, we have the entire outdoors in our disposal. So if you do want to continue having conversations, please let's have those outside while the talks are going, so we can keep this main stage distraction-free for everyone. Okay, and now that I've done the school marmy scolding, I think we're pretty ready to start today's program. So it is my pleasure to soon invite to the stage Rafael. Rafael Mendiola is he's been a staple of the React Native community. I think I first met him at Chain React 2016 or something like that, 2017, which I now realize that makes me very old. But Rafael has been in this space for a very long time. And today he's talking about something new, something very current. So today we're going to learn how to use AI coding tools in large-scale projects. Because we've all seen the tweets about vibe coding, one-shotting a crappy app. But let me tell you, when you do that in a real code base, it does not work out well. I tried it, and well, let's just say that I made a mess. And hopefully with Rafael's instruction, we can all avoid making those messes in the future. So without further ado, let me invite to the stage Rafael Mendiola.
Thank you so much. Hi, everyone. Let's test my mic. Can you clap once if you can hear me? Clap twice if you can hear me. All right, keep clapping if you think that Poland is the best place in the world for React Native development. Dzień dobry. Thank you so much for Software Mansion for allowing me this opportunity to talk with you. I'm Rafael Mendiola. I've been working with React Native since 2017 or so. And I've had the fortune to get a lot of experience as an independent contractor, a consultant, and as an engineer at startups, scale-ups, and enterprises. I'm kind of a product engineer. I have a passion for making really, really good user experiences, and I really love the intersection of code and design. I'm currently a staff software engineer at Hinge Health, and I'm part of a pretty large React Native team. So this is my information. If you like cool stickers, see me after the talk and I'll give you one. So we're all here because we love React Native, but let's take a step back and acknowledge the moment that we're in. Over the last couple of years, we've seen the advent of tools like ChatGPT, Cloud, GitHub Copilot, Cursor, and more. And these tools are not just speeding up coding, but they're changing how we plan, how we collaborate, and how we manage complexity. So in this talk, we're going to go over this, and we're going to talk about what differentiates large React Native teams from smaller ones. I want to show you some emergent AI workflows that aren't just about coding. And I want to offer some practical advice on how to navigate and thrive during this period. But I want to start first by telling you a story. I want to tell you about 1979. In 1979, accounting was a manual, repetitive, and painstaking task. Everything was done on paper, sometimes taped together to form mega sheets. If you made a mistake on row 12, you didn't just fix one number, you had to recalculate every row below that. That meant recalculating rows 13 through 40 by hand. Try to imagine that. This was a really slow, fragile, and painful process. Around the same time, the Apple II was becoming popular, but this was in classrooms and amongst computer nerds. It could play some really cool games, but in the corporate office, it was kind of a joke. Nobody was buying a personal computer to do serious business work. Meanwhile, in a Harvard classroom, a former MIT computer science nerd was getting frustrated. Every time the professor changed a number on the board, he and his classmates had to recalculate everything by hand. It really sucked. So he thought there had to be a better way. Something interactive, something automatic. And because he studied computer science at MIT, he just built it. And this tool became VisiCalc, the first electronic spreadsheet, a $100 program that only ran on the Apple II. It looked like a blank grid. But if you typed in numbers and formulas, it would instantly recalculate the entire sheet when you changed a single value. And anybody who worked with numbers saw the potential instantly. This was a superpower. All of a sudden, people who had never touched a computer before were suddenly buying Apple products, Apple computers, just to run this one program. And in 1980, Apple sold nearly twice as many Apple IIs as the year before. Number crunchers loved it because there was no programming involved. You didn't have to be a computer nerd. You just needed to know your numbers and what you wanted to do with them. And this tool enabled the exploration of new workflows. You could build financial models, adjust assumptions, and ask, what if? And get an answer instantly, right on your desk. This was the kind of accounting work that used to take 20 hours, and now it took 20 minutes. And over time, the skill set shifted, and the expectations changed. Professionals began to split their careers into two eras, before spreadsheets and after. Does this sound familiar? So we're going through a similar shift. But for us, it's not just about writing code faster, because AI is embedding itself across the entire development cycle, and new kinds of engineering workflows are emerging. By the way, these people are all AI generated. You can't really see their hands, but I promise you they still have their 6 fingers. No AI models were harmed in the making of these slides. So this talk is titled At Scale. What does that mean? Well, React Native teams tend to be small due to the high operational efficiency that it gives us. That's why I love React Native, because you can have one team, one code base, and if you're using a product like Expo, you can ship your product to iOS, Android, and web at the same time. So culturally, React Native teams tend to maintain this kind of like startup-style scrappiness. But when those teams succeed and the company starts scaling, then you start getting more formal product development processes. And in a larger organization, that looks like this pipeline. And you'll often have multiple teams doing their own pipeline in parallel. So we start with the PRD, which is the product requirements document, which defines the what, the why behind the feature, and aligns the stakeholders and developers around the user needs and the business goals. Then we go through design. We will write a technical spec. We'll break that work down into tasks. Then we'll implement the code. Then we'll go through the code review, and there's usually some CI step that automates some quality checks. And then when we're getting ready for release, we go through a QA process, and then we release the app to our users in a stage rollout. So new workflows using AI are emerging at every step. So for example, PMs can use AI to generate the first drafts of their PRDs. There are even products now that are offering to write you PRDs for you. There's tools like Figma that are rolling out new AI generation features that help designers create their designs faster. And in CI, and you've probably seen this with GitHub Copilot, we can add AI to help us analyze code in ways that go beyond the basic linting. We can now generate reports that give us detailed analysis and better suggestions for code improvements. So we don't have time to go deep into all of those stages. Each one could be its own talk. So I want to talk about some workflows in the stages that are most relevant to us as developers, which are writing technical docs, breaking work down into tasks, implementing code, and reviewing PRs. But we really need to start with code. So something to highlight is that we are all in different stages of discovering workflows with AI. I've been working with AI on my personal projects, and I work at a company that is an early adopter of AI tools. Some of you, however, are working at companies that still haven't made a decision on whether they should allow AI tooling. And depending on experience, you might be using one of these current workflows right now. So you might be using ChatGPT to ask questions and copy and paste code into your project. You could be using GitHub Copilot to perform autocomplete. Maybe you've adopted a smarter editor like Cursor to write into your code base and do bigger refactors. Maybe you already figured out that you can use Cursor to gather insights about your code base. Maybe you already integrated your Cursor workflow with tools like GH and the Atlassian MCP to automate common tasks. And to be honest, there is so much more. I think I was talking with Gabby Mancha yesterday. He's probably out there somewhere. And holy crap, there's just so much other stuff that I don't even know about that I need to learn about. So the most popular workflow right now is vibe coding. Vibe coding is when you pop open your AI assistant, type a vague prompt, and you just repeat the process with make it work. And you don't really have to read the code that's being created. You're just vibing. If you're starting on a new project, this is a really nice experience because you get a really nice productivity boost. And if you know what you're doing, you're not going to get stuck. However, in a large production code base, in a company that has a lot of users, multiple teams, shared code, and critical business metrics to maintain, that's not a responsible way to work. And that should be your first clue that AI is not going to replace developers, because the job isn't just typing code. It's understanding impact, coordinating across teams, and making sure that your decisions lead to a high-quality product. So I want to show you a workflow where you can take advantage of AI-assisted coding while still being diligent with your work. Using a plan.md file is one of those emerging workflows that a lot of people have been discovering independently. It arises from the need to retain context between chat sessions. If you do a lot of AI coding, you'll know that every once in a while you need to fire the AI assistant because it went crazy. So this file is a way to retain state, and it's essentially a scratchpad for your thoughts. But it's also a place where you can collaborate with your AI assistant to really flesh out your ideas and do diligent work. Once you've come up with a good plan, you can ask your AI assistant to create well-defined tasks to implement it, and then execute it step by step. So I'm going to show you this with an example from the Expo repo. This is a code fix that just got merged. And I want to give a huge shout out to Lukasz Kosmati for letting me use this as an example and collaborating with me on this part of the presentation. Poland really has the best developers. So this PR fixes a silent type conversion error that was leading to a null pointer exception later on in the code. When we send data from JavaScript to the native layer, it's possible to send a data structure like an array that contains a null value. But since the native side is typed, if we convert that into a list that doesn't allow nullable values, that's going to cause a null pointer exception later on. So the PR that we're looking at is going to detect the cases when this is happening and fire an early exception instead of just silently letting it crash later. So here I've written a prompt that states the problem and asked the agent, in this case Cursor, to start collaborating with me on a solution in a plan.md file. So the specifics of the code are not really important here. I just want to show you what I'm doing with Cursor here. So as you can see here, Cursor will start building a plan.md file with its understanding of the problem and will try to come up with a solution. It really doesn't matter here if it gets it right the first time. The point is that we're going to keep iterating on this file until we have a solution that makes sense. And you'll see that there's a file being written right there. So here, I'm just going to keep chatting with Cursor, and it's going to refine my plan. So I'm giving it some feedback on the plan that I originally got. And you'll see that it will edit it. So there you go. And then once you have a plan that makes sense, you can ask Cursor to break it out into tasks that can be automated by an agent. So here I'm giving Cursor a prompt to give me a list of clearly defined steps that can be completed. And you'll see that here, Cursor will add the list of tasks at the end of the file. And then once you're happy with the breakout of tasks, you can actually tell the agent to start implementing this step by step. This is going to give you better results than just chatting directly with Cursor and expecting it to do things correctly on the first try. And this is one of the common frustration points that people first experience. So I'm not going to show you how this actually gets implemented because I want to talk about how this workflow scales to help you write technical documentation. If you're a tech lead, you probably spent a lot of time writing technical proposals, epics, and breaking those down into tickets. So you can scale this plan.md workflow for larger projects because it's essentially the same thing. The key insight here is that you can use Cursor or an AI agent for a lot more than just writing code. You can use it for technical writing. As you break out the work into Jira ticket descriptions, you can tell Cursor to follow a specific Jira template. And this will stop the complaints from your team about badly written tickets. If you want to take this even further, you can even automate the creation of the tickets in Jira itself by hooking up Cursor with the MCP server that Atlassian recently made available. So I'm not going to dive deep into that, but I just want you to know that automating this is possible. Now, let me show you a workflow for reviewing PRs. So let's go back to Lucas's PR and show you how to review it with Cursor. So I mentioned MCP, and everybody's interested right now in using MCP servers to connect agents to external services. But you can actually get a lot done with command line tools. For example, the GH command is GitHub CLI tool that lets you perform common operations in GitHub. And right here, these are two commands that let me view the PR information for the current branch, and I can get the PR diff for the current branch. And I personally like using GH PR diff rather than using Git, because this will actually give you the diff of the PR all the time. So the prompt that I'm adding here is I'm going to tell Cursor Agent to review this PR for me by pulling the data using GH PR view to get the PR information, and then use GH PR diff to get the diff. We're going to write an analysis and check if what is written in the diff matches the intent of the PR description. And I'm also asking it to give a TLDR of the changes of each file. So we're asking it to write it to a Scratch file called prreview.md. And after that's done, one of the things that we can do is just similar with the plan.md workflow, is that we can ask it to write me a list of things that I can check just by code inspection to verify that the PR is correct. So we're going to write this PR analysis, and then we're going to write a list of things that we need to check. And then you can get Cursor to actually do the check for you. So here we already have the basic PR review document, and we're asking it to create us a list of things to check. And then it's going to apply that. And then you can go ahead and ask Cursor, hey, can you please perform these checks for me? So this is not a way for you to be lazy. This is a way for you to be diligent. You still need to do the PR review yourself. And because you're working with a Scratch file, essentially, you can keep having conversations with Cursor and ask specific questions about the code that you're looking at. And this is really useful when you're looking at some complicated code. By the end of your PR review, you'll have a really nice document that explains the technical details of what's going on. So let's start wrapping this up. I know that I just threw a lot of information at you. There's a lot of really quick videos happening. I want to let you know that I put up a blog post about this, and you can check it out at my site, raf.dev. And it's a blog post about the workflows that I just showed you. So interesting stuff, new workflows. Let's talk about navigating this AI shift. We're all navigating this in our own ways. And I think it's reasonable to feel uncertainty. Some of us are early adopters, and some of us are a little bit more cautious. I work at a company that is an early adopter of AI, and some other companies out there still haven't really made that decision. So we're kind of all over the place. Some of you have had a bad experience trying out AI, and you haven't actually tried again. And I want to encourage you to keep trying. If you found AI tooling difficult to use in the past, I want to offer you an analogy. Imagine somebody gave you a Lamborghini, and you get into the car, start it, and you immediately crash it into a wall. That's not the Lamborghini's fault. It's just a machine. You have to learn how to drive it. So I encourage you to keep trying. So the big question that a lot of people have is, are software development jobs going to go away? And I can tell you from my experience, they're not. What's happening is that the scope of the work is going to shift towards higher order tasks and more sophistication. And this can free up developers to dive into more complex problems or expand into other areas like product and design. If you think about it, accounting jobs didn't go away in the 80s. Lower clerk level positions were eliminated over time, but the demand grew for higher skilled accountants who could leverage the new tools. And at first, you didn't need to learn how to code to be able to run sophisticated financial analysis with spreadsheets. But nowadays, financial professionals write code into the spreadsheets all the time. I think the real question for me right now is, are engineering jobs going to get lame? And the answer for me is maybe, actually. It really depends on the engineering leadership of your company. If you're an engineering leader in the room right now, you should really think about how you want to take your team through this transition. This is a quote from a recent New York Times article where some industry developers were saying that their work is becoming more routine, less thoughtful, and faster paced. And this is one way that things could go, sure. If you want to have a good guide on how to navigate this transition, I would suggest that you read some books about the early computing history. So you can read up about what happened when spreadsheets came out and how were those professionals affected. And as you get deeper into the earlier computer history, you'll start noticing that everything that is about to happen has already happened before. And that will give you more confidence. By the way, I made this into a sticker, so if you see me after this, I can give you one. So here's my advice. I think the current industry vibe ignores a very important point, and that is, as engineers, you are now incredibly, ridiculously empowered. So today, pay attention to the talks for the rest of the day and get inspired. There's a lot of really, really cool stuff happening. You should dust off your side projects and get them done, because you can do whatever you want now. You can work on whatever you want and get it done quickly. By the way, this presentation is just a few React components, some CSS, cobbled together with Vibe coding. So you can make some really interesting, wonderful things. And going forward, what's going to differentiate you is your insight, your creativity, your taste, your ability to communicate, and your ability to persuade others. So think about it. We all just got Lambos. Learn how to drive them and go have fun. Thank you so much.
My God, what a man. One more round of applause for Rafael Mendiola. I think this talk, similarly to Jay Meister's talk yesterday, really just made me sort of, think about the sort of like the eternal value of the basics. How in some ways, with all the kind of like new tooling, whether it's in the runtimes and frameworks or in the sort of coding tools is coming available, it only really makes us more powerful when we use it, like applying the sort of like the knowledge and the ingrained knowledge that we have about the processes of like what actually makes computer programs work. I think this talk and Jay's yesterday like really drove home the point for me, which is that I don't know, like the values, the skills that I as a developer have are now just more powerful than ever. So I feel very uplifted by this. Now I don't have any housekeeping to do, but if you walked in since the morning, I am still Yanni and I'm still not wearing a hat, but the hat may come back later, so don't worry. There's all kinds of exciting stage crafts happening. Now, I think we're about ready to start introducing our next speaker. Our next speaker comes from South Korea. He works at one of the largest fintech companies there, and they're basically introducing React Native into their sort of native super app, one micro app at a time. And if you've ever tried to do Brownfield React Native development, which I have, we all know the challenges involved in this picture. And here to tell us about it, I totally thought I was going to be ready. Okay, here we go. Here to tell us about it, all the way from South Korea, Sojin Park.
Hello, good morning. How many of you have tried integrating React Native into an existing app? Yeah, quite a few. OK. So this is what we usually call Brownfield, so adding React Native into an existing native app. And at TOS, we were integrating React Native into our existing app with around 20 million monthly active users and hundreds of developers. And by the end of this talk, you will know the key challenges and solutions that worked for us at scale. So what do we mean by scale? Here's what we are dealing with at TOS. So we're deploying over 40 times daily with around more than 100 microservices with bundle sizes as low as 200 kilobytes, which loads in less than a second and builds in under 10 seconds. Well, this was not that easy to get here, and we faced plenty of challenges along the way. But I'll share why we needed these capabilities and what obstacles we hit and the solutions that actually worked for us. And I'll show you some examples of how it performs in production. I'm Sojin Park and head of front-end engineering at TOS, managing around 100 front-end developers. And feel free to connect with me on GitHub. My handle is here. And now let me explain why we needed Brownfield React Native at scale. Well, let me start by explaining why we needed Brownfield React Native at this scale. And TOS is Korea's leading financial super app. So we handle money transfers, investing, payments, asset management, like everything finance related. So when someone wants to send money to their friends, they just simply use our app to send money. And on top of that, like, we provide a lot of services. So around half of all Koreans rely on our app for their most of their financial needs. So with this massive scale and complexity, like, we faced unique challenges. Like, as a super app, we operate hundreds of different financial services, like each with different teams and different timelines and technical requirements. And some services were built natively, and others used web views, and we needed to add React Native into this mix. So coordinating development across all these technologies at scale became our biggest challenge. Now, integrating React Native into native apps basically isn't inherently that difficult. You just define a React Native view, like connect it into an activity or a view controller and just load a JavaScript bundle. So it's basically simple. But the real problem emerges at scale. So traditional React Native puts all the services and screens into one giant bundle. So I'll call it a monolithic bundle. And when we develop with a monolithic bundle, many of you have probably see this every day. Metro trying to start a dev server. So for our monolithic build, like, even if we had like only tens of services, the dev server startup took around like 30 or 40 seconds, and production builds were like it took like 2 or 5 minutes. And like, when you're deploying 40 or more times daily, this was a big burden for us. And on top of that, our single bundle was around 5 megabytes, and loading that big bundle on a low-end Android device took significant time, which led to like frustrated users at loading screens. And with everything in one bundle, we faced an all-or-nothing deployment scenario. That is, one bug in any service meant like either rolling back the entire app or letting users suffer through those errors. So the straightforward solution would be that let's split these bundles into like smaller and standalone bundles. So this might make sense. But for us, simply splitting the bundles was not enough. Each bundle still included like React and React Native and native modules, like resulting in like more than 3 megabytes per service. So when we try to include like hundreds of microservices into one app, like, we are looking at 300 or more megabytes of app sizes, which was not practical. So to eliminate code duplication, we split each standalone bundles into two parts. So the first bundle is called the shared bundle, which contains core libraries like React, React Native, and native modules that all the services use. And the service bundle contains only the specific code for each individual service. And this way, instead of every service carrying its own copy of React and React Native, they share one common bundle while keeping their unique logic separate. So basically, here's how it works. The shared bundle defines a special require function in the global namespace. And when you write some import statements like import React from React in a service bundle, then our bundler transforms it into a call to that special require function. So in Metro, this is just a resolver configuration change. When building service bundles, we just check the module name and redirect some shared library imports to our global require function. So at runtime, you first load the shared bundle, and then load the service bundle using React Native, some native API, like enqueue application script, or load script from file for each OS. And we could get the immediate results that service bundles size were really, it dropped to around like less than 1 megabyte from like 3 or more megabytes each. And build times were improved for us, because like less code meant faster processing. And developer experience was enhanced with quicker dev server startup. So instead of bundling everything repeatedly, like each service has now only handled its specific code. And for users, just-in-time loading dramatically improved our initial experience, because instead of loading all services upfront, we only loaded what the users actually needed to see the first screen. And stability got a major boost through independent deployments, because instead of one service breaking the entire app, we could now isolate and roll back problematic services while keeping everything else running smoothly. So in short, we achieved a good developer experience because smaller apps meant faster builds, and better performance because we loaded some screens just in time as the user actually uses that screen, and enhanced stability because independent deployments. But this was great, but we weren't satisfied yet. We needed something better and greater. Even with bundle splitting, as mentioned before, we had some more problems. The first was developer experience issues. That is, even after splitting the bundles, for us, build times were still over 90 seconds for large services. Well, that might be short, but we needed much for faster builds. And sometimes we always try to use the reset cache option because of the inconsistent build of Metro. And after inspecting the service bundles, what the Metro built, we found out that there might be some problems in the user experience because Metro didn't have tree shaking. That meant that around like in one service bundle, 66% of unused code was in our service bundle. And from our experiment, here are some figures. So bundle size directly impacted our initial loading experience. Like, for example, we found out that if the JavaScript bundle is around 4 megabytes, like it took like around 3 seconds loading on low-end Android phones. But if we reduce that size into like a megabyte, then the loading time was reduced to around 0.8 seconds. And since we are a Brownfield app, React Native's views were created on demand, so when users actually navigated to them. So this means that initial loading time is really critical for us, and users expect instant transitions or not white loading screens between features. So bundle size wasn't just a nice to have, but it was a critical for our user experience. So we decided to try transitioning from Metro to a bundler called ESBuild for 3 reasons. So first, in order to make the build time shorter, we had some experiences that since ESBuild was written in Go with concurrency in mind, the build times would be much better. And since it's very consistent and doesn't make heavy use of the cache, like there were no more cache resets. And also ESBuild supports tree shaking out of the box, so it really helps us eliminate unused code dramatically. The migration itself was kind of hard, but it was basically simply moving the Metro's configurations about React Native to ESBuild. So for example, it required configuring ESBuild to handle React Native special syntax, like React Native uses flow, or like Reanimated use special functions called worklets. And we could make we had to transpile these into code that ESBuild can understand. So we could make this happen by configuring loaders. And we also needed to handle React Native's, platform-specific file extensions like .ios.js or .android.js. And this was solved by configuring ESBuild's module resolution to recognize and prioritize these platform-specific files. And after using ESBuild for our production builds, we really saw solid improvement because for really small services, build times came down to like under 10 seconds. And smaller services, building time was around like 2 seconds. As you can see in this example, I run this like a week ago. And bundle sizes were like cut in half through these the tree shaking alone. And on top of that, with additional optimizations, we were able to achieve like bundles around like 200 kilobytes. So service bundles now load at 200 kilobytes, like delivering the sub-second loading experience our users deserve. So let me summarize what ESBuild delivered for us. So it meant great DX for us, so fast builds under 10 seconds, and great UX for users because dead code elimination enabled tree shaking. And it also helped us stability because instead of using reset cache every time, like it provided consistent build. So let me give you a quick summary of today's talk. So today, to solve the monolithic bundle problem, we tried to split the bundles into independent pieces. In the middle, we needed some model called the two-bundle model. And this gave us faster build times and better performance and independent deployments for stability. But Metro wasn't enough for great UX and DX, so we transitioned to ESBuild, and this gave us builds under 10 seconds, and sub-second loading, and 200 kilobytes bundles. And, well, I think recognizing these challenges are universal when integrating React Native into an existing native app. So we open sourced our entire solution as called a framework called Granite. We are calling it an enterprise-grade React Native framework. So Granite provides everything we discussed before. So from the bundle splitting architecture and optimization from ESBuild, and also since our architecture is kind of different from the traditional React Native infrastructure, we need a new infrastructure for OTA updates. And So we try to make Granite as easy as possible. So starting with our framework is easy. Just run npx create Granite app latest to scaffold a new project with all the tooling configured. And run the npm run dev, and you'll get the familiar developer experience you've been used to. And also, building the service bundles is straightforward. Just run npm run build, and it completes in seconds. And this is a screenshot that I took yesterday, and the resulting like Hermes bytecode bundle is around like 120 kilobytes, and which is really small. And in order to serve these service bundles, we need OTA over the air, so we need a special infrastructure. We also provide infrastructure for these OTA updates that you can host on AWS. So we use Pulumi for infrastructure as code. So you just need to provide your AWS credentials, and the entire infrastructure gets provisioned automatically. So if you want to try this yourself, like everything we build, we are trying to make it open source. So you can find Granite on GitHub at TOS Granite. It includes all the bundle splitting, ES-build integration, and infrastructure components we discussed today. And if you're interested in seeing what else we're working on, feel free to follow us on X at TOSFE. Thank you.
Sorry, Keith. All right. Thank you, Sojin. One more round of applause for Sojin Park. That is the energy that we are talking about. Thank you very much for participating in this game and not making it too hard for me. All right, so we are going to start setting up our next speaker. I feel like this is a good sort of like a back-to-back track of two talks, because I remember, when I was a day-to-day React Native developer, there were really like the two things that brought a little sort of, I don't know, fear in my heart and in my guts. One of them Sojin just talked about, which is so the integration into Brownfield native apps. As a JavaScript developer, I didn't really feel at the time equipped to sort of integrate into complex ecosystems of both iOS and Android. And now we're going to have Keith Kurak from Expo talking about building out sort of like the UI layer and integrating deeply with native modules. So I'm hoping that many of you are, well, not hoping, but I'm assuming that many of you are from the same bucket of people as I'm. You came to React Native because you love JavaScript development, that you love React. And I'm hoping that this 1-2 punch of talks will leave you more prepared to sort of tackle the native integration side as well. Are there people here who came from a native background, like iOS, Android developers? All right. How do you feel about React Native? Is this something that you were forced to do at work? Or are you excited to do it? Excited? Yeah, there was one guy that was just like, I was like. But they paid me to come here, and pierogi is good, so what do I care? I get paid all the same. But no, welcome to our big, beautiful tent. We are very happy to have all of you, and thank you for contributing to this ecosystem and this community. Thank you. And now one of the great contributors to this ecosystem community, Keith Kurak.
Hi, I'm Keith, and I do dev success at Expo. So I wanted to talk today about the evolution towards providing access to more native UI and capabilities in React Native ecosystem, and Expo's role in that. I wasn't really sure what to call this. For a long time, the working title was like, here's some cool new stuff in SDK 53, I guess. But what it means for us is that in React Native, we can build the best native applications, period. And we can build them quickly. But I think I'm preaching to the choir here. At the same time, even if you've agreed with this last year or the year before that, every year, all the time, it's felt more and more true in different ways. Just as we've been at App.js and seen the more cool new native things that we can do on stage every year. I guess what feels special about right now is that it's not just that we can build the best native experiences in React Native, but increasingly we will. What used to seem niche and specialized will become the default for more people. If you've typically steered clear of native code and capabilities in the past, I think you'll be thinking more about it this year. Not with like dread or trepidation, but like anticipation. You'll be looking forward to it. And not just for us here at App.js, but in the future, new developers to React Native and non-developers will kind of just fall into it by accident when they're building the next generation of apps with AI. So more new native cool stuff to make the best apps fast for everyone all the time. But first, I would like to discuss pits, craters, chasms, depressions, holes. I'll start close to home with a large sinkhole that appeared on one of the busiest intersections of my town. It was caused by a water main break, which made a little underground river that ate away the soil and the stone underneath until there was nothing left for the asphalt to sit on. Motorists, pedestrians, city planners, they hate this. But developers actually kind of like this. I don't mean that we call out to the earth to please swallow me whole while a Gradle is sinking. I just can't take it any longer. No, there's just one hole we want to fall into, the pit of success. It's really nice to just focus on the features that make your app special and feel confident that the tools you're using will just kind of default you into all those other things that are important without trials and tribulations and wailing and gnashing of teeth, like good performance or a clean, professional, intuitive user interface. The pit of success should be like your typical sinkhole from my home in the United States Midwest, big and deep and appearing suddenly right in the middle of the most traveled thoroughfare. If it can't swallow an 18-wheeler whole, we're just not interested. It's actually, the more surprising, it's the better, at least for development. It's just a great feeling when you're working on your app and you're just working, and suddenly what appears on the screen is like exactly what you wanted. You couldn't believe it was done already, and it wasn't nearly as hard as you thought it would be. I think vibe coding shines a bright light on this, where the pits of success are and aren't, challenging assumptions about what's easy and hard. Non-developers now have access to bots with all the world's documentation and public code samples and all that stuff, but the jury's out on their aesthetics. Given a normal set of prompts, like make this or that feature, how does the tooling help the AI code something that's not just passively functional, but with a great native look and feel? Experienced developers know a bunch of little things to get the most out of their tools and find the pits of success more often than the new dev. We can't just forget all that, but vibe coding forces you to verbalize all those little things, or else the AI just might not do them. Saying this stuff out loud can be a little uncomfortable, and it becomes more obvious why these things don't just happen in every app all the time. To this end, I recently tried to sit in that discomfort, pretending to be a new developer, hoping to vibe code my way into the pit of success. I threw my requirements down the well and watched eagerly to see them rise from the chasm as a good-looking and feeling native mobile front end, embracing the default look and feel of the platform. OK, so let's play new developer. I don't want to make any assumptions. I want to momentarily forget everything I know. It's not that much, so it won't be that hard. So no React Native, never heard of it. How did I get started mobile? Well, I had an iPhone at the time, and I was like, damn it, I want to put an app on my phone. So I just assumed that you had to use Apple's tools. So OK, I'll go right there. I'll open up a new project in Xcode, boot up Cursor alongside, and ask it to start building this little fitness app UI. There were things that were kind of tricky, like data binding from a bottom sheet to the main screen. Like Cursor was not happy. I had to go Google it, and it took a while. But I think I pretty much 3-prompted the entire UI. I was just like, I want these fields with those controls, and it picked them straight from the standard Swift UI toolkit. You want a list with drag and drop sorting and cool delete animations? That's just the list. There's not a lot of fine-tuning or pixel-perfect positioning here. The level of detail was like, make this button big and blue. So I'd rate this pit of success as very capable of swallowing a car whole. Much like the sinkhole that swallowed 8 whole Chevrolet Corvettes in a house in a museum in Bowling Green, Kentucky in 2014. This region of the United States is notable for its karst topography, where subterranean limestone is gradually eroded by running groundwater. It's kind of like nature's water main break. This geological phenomena can bring occasional destruction, but just as often great beauty, and is also responsible for the breathtaking caverns in nearby Mammoth Cave National Park. OK, back to coding. I'm not exactly sure when I first thought about cross-platform development. I think it was about the time where I dropped my iPhone into a lake and had to switch to Android. But eventually, my new developer persona wants their app to run on everyone's phones. React Native means I can do that in one code base with real native UI components. I wave my AI wand, and it works. I'm pretty happy with this. Shipping fast on 2 platforms with one code base is just good for the soul. But there was tricky parts. I burned a lot of prompts trying to get vaguely in the neighborhood of the look and feel of V1 on the iPhone. I'm OK with a little more styling, but I couldn't take for granted anymore that the list will have the same swipe or edit or drag and sort behaviors. I was kind of like on my own for that. At the same time, a lot of the other developer experience was great. It's just very intuitive to do a lot of things in React. So React Native certainly has this native UX pit of success, as it can technically do anything that we did in the first example. But it can sometimes be hard to find. Much like the famous blue hole just off of Lake Erie's Sandusky Bay. Formed and fed by an underground stream, its clear azure water is a consistent 9 degrees Celsius year-round, and it doesn't rise or fall with floods or droughts. It's like magic. It's just down the road from the world's tallest roller coaster, so you think that a lot of people would see it, and perhaps even a few would fall in. Alas, your best view of this sinkhole is probably from this old-timey postcard. It's been private property of the exclusive Castalia Trout Fishing Club for the last 30 years. What we need is the Swift UI pit of success combined with the rest of the React Native developer experience. So has anybody tried Expo UI yet? Awesome, awesome. Is anybody going to just stop paying attention, open up their laptop, and try it right now? It's OK. I won't judge. To reliably make it possible for anyone to make a UI like you would get out of the box in Xcode, we need not just the building blocks we've always had in React Native Core. We need the higher order primitives that you regularly interact with when building a Swift UI interface. Expo UI aims to provide the direct access to these right in your JSX. This is not a UI library. This is simply access to a standard platform design language right alongside the rest of your cross-platform React Native code. Now we can build a UI just like we built for iOS only, but right in a platform-specific file. We get a component layout whose defaults look good. Very little styling is needed. We get sophisticated default behaviors out of the box. We can save our animations for doing other cool stuff besides trying to approximate what a Swift UI list might do. And I can do this right in React syntax, my happy place. It's long been possible to build native modules encapsulating these components, and many libraries have already incorporated them. But with Expo UI, in a single package, you get a one-to-one mapping to all those higher order native components you might need. A Swift UI developer could pick things right up without missing a beat for the most part. So what sinkhole shall I compare this to? I'll go with Lake Eola. In 1873, who you might call the original Florida man, Jacob Summerlin, purchased 200 acres for cattle ranching in the center of the state. There was an otherwise unremarkable sinkhole at the edge of the property, but it connected to an underground aquifer, and then because it's like Florida and it storms all the time, it flooded and it became this beautiful lake. The land was then donated to the city of Orlando, and now you can't miss it on your way to Disney World. Moving beyond my hastily made workup app, the Vancouver Hot Chocolate Festival app by Andrew Karn recently caught our eye as a relatively simple yet non-trivial use of the standard platform UI that would make a good test case to rebuild an Expo UI. So Kudo-chan did it. And all the controls there, even some that, that we've had before, like Expo Maps. It's pretty cool. I recommend you check it out. You can check it out with the PR with that link, or you could just go to the Expo GitHub and just search hot cocoa. There's not that many PRs that involve hot cocoa in the Expo repo. A wide variety of Swift UI controls are represented already, including date picker, color picker, segmented controls, list, bottom sheet, switch text input, and more. We're also starting to fill these in for Jetpack Compose, so developers can do the same thing for Android. You can use certain components individually and alongside the rest of your React Native code. Or you can use the same controls and more structural components like H and V stacks to compose entire Swift UI interfaces inside of a host control via the Swift UI primitives export. The library is expanding all the time, in part because it's not often that complicated to bring on new controls individually with the Expo Modules API. Expose some props, map those external props to their Jetpack Compose or Swift UI equivalents, and you're off to the races. Expo UI is experimental in SDK 53. We encourage folks to give it a try and report any issues they find in this early phase. While the basic idea of using Jetpack Compose and Swift UI controls in React Native sounds intuitive, and it's pretty straightforward to wrap individual controls. There's a lot to it under the hood. We expect changes to the API as we determine the best ways to interact with these higher order controls, which have not been used much in the React Native ecosystem. So really look forward to you trying it out and giving us your input. A lot of that complication comes not just in how you use these components individually, but in nesting them, treating Jetpack Compose and SwiftUI components as arbitrary children inside of React Native views, and vice versa. You could say that we're crossing the streams, and that carries some risk and needs some work. But I can't think of a better group to harness the great power of Jetpack Compose and SwiftUI and React Native than the folks we have working on it right now. Besides the Expo and Software Mansion folks working on the Expo SDK, the effort to bring modern UI components in the React Native is a community effort, particularly with foundations in Andrew Levy's SwiftUI React Native library and Tomasz Cepeda's work to bring SwiftUI and Jetpack Compose to the Expo modules API. Using Expo UI isn't for every app or every screen in every app, but I think we're on the cusp of a new era where the calculus of when and where and how often to break out into platform-specific code is going to change significantly for more developers. Previously, breaking out into a single platform-specific file was pretty rare for me, and I don't think I'm in the minority. With the emergent capability to break out into these native platform design languages, just like I'm writing any other React Native screen, has me thinking that I will start doing this in more of my apps in the future. Tomorrow, maintaining separate screens for Android, iOS, and web might be just as efficient for developers as it would be to have a single view that was served for all of them. And then within each of those files, the flexibility is unprecedented. It's kind of like, wait, what is that? OK. This is a bit of a strained analogy, but let me introduce you to a different type of pit of success, of the culinary variety. So there's this restaurant near me. The only thing they sell is hot dogs and tater tots. And they give you this note card, and there's like 86 different toppings on it. And you get a little golf pencil, and you can check any one you want. You can put like fried egg, kimchi, breakfast cereal, peanut butter, mac and cheese, you name it. And no matter what you put, what you check on there, when it comes back from the kitchen, it will taste amazing. I have tried so many times to sabotage my hot dog, and I have failed every time. So I think that's kind of where this is going, is you can have like, SwiftUI and Jetpack Compose views via Expo UI. You can have those alongside your standard React Native views. You can have those alongside web components via Expo DOM components. You can put them inside of each other. And like, you just do the things that are intuitive and lay them out as you expect it to, and it works. And even if not all of that is enough for you, you could even break out using the Expo Modules API and write Swift and Kotlin directly and use those SwiftUI and Jetpack Compose views like right inside native code. And so I think that's what it'll look like. So speaking of the Expo Modules API, this low boilerplate, powerful toolkit for interfacing with native code has contributed to a blossoming of new and improved native modules in the Expo SDK and all over the community. A better framework for native modules makes it faster to ship new modules and improve them. For instance, shared objects in the Expo Modules API means that we can keep references to native object state in your JavaScript, reducing round trips to disk, a real-world performance benefit that users can actually feel in apps with long lists of images or videos. Like, there's no penalty for using native code, or your own custom native code. In recent SDKs, we've released several new Expo Modules API-based packages and rewritten others, including image, audio, video, maps, SQLite, and file system. Besides all the cool stuff it brings to the Expo SDK, one of my favorite things about the Modules API is it also is very accessible to just drop some native code directly into your project if you need to write a little bit. You can run this npx create expo module with the local flag, and it adds a folder right in the root of your project where you can just throw in some extra Kotlin and Swift code. No need to organize them in a separate package or monorepo. Whatever code you drop into your local modules folder just gets linked automatically when pre-build is run. But back to the Expo SDK, one welcome addition in SDK 53 is the Expo Background Task Library, built around the new Android Work Manager and iOS BG Task Scheduler APIs. It's a new, clean interface that should make it straightforward to set up and maintain periodic background tasks, as it would be as if you were implementing them in the native IDE. Probably even easier. It's been a while since I've tried to do anything like this in Xcode, but I'm guessing it would involve me making several trips to this website. You could use it for refreshing data in the background. This could be particularly potent combination with the increasing number of local-first solutions that are compatible with Expo via Expo SQLite. Sync with the server in the background, and the user can work unencumbered with the latest data later, even if they're offline and haven't opened the app in a while. And then when they're back online, their updates will sync back to the server without them having to do anything else. It's also compatible with the Expo Updates API. You can now update your app's JavaScript over the air with EAS Update, and users can receive and apply that update before they even open the app. Widening the pit of success in React Native isn't just about making modern native UI components more accessible, but it's about putting all capabilities built into the mobile operating systems at your fingertips, so you'll want to use them all the time. I tended to avoid background tasks in the past. They just seemed kind of, hard to work around, opaque. My users tolerated loading everything when the app started. At least they didn't complain to me, or I didn't listen to them. I don't think I was the only one. But apps that already have their latest code and data loaded, when you open them, really smart. The best apps, the apps that are the most trusted and indispensable parts of your users' daily lives, they're working when they're not. They're always ready when you are. I forgot to mention that Expo UI has some nice native spinners and progress bars, but you might not need them much in this new native pit of success. Tools that inside and out reliably lead developers towards defaults that look and feel great. To what crevasse in the terra firma shall I compare these two? I'm going to go with the largest sinkhole in the world at over 600 meters across and deep, the Zhaozhai Heavenly Pit. A pit that's so successful that it's home to about 1,300 animal species, including the rare clouded leopard and Chinese giant salamander. A pit that you couldn't miss, and you might not want to leave once you fall in. In conclusion, Expo is excavating. The whole React Native ecosystem is digging deep. We're moving Earth by the truckload and opening up wider pits of success for us all to fall into. Whether you're checking out Expo UI, the new Expo background tasks, building your own Expo module, or using any one of the amazing community packages that bring enhanced native functionality to React Native, more so than ever, React Native is the best place to be building beautiful, performant, smart, capable apps fast. Thank you very much.
Thank you, Keith. All right. It's been a great morning. Now let's go enjoy some coffee. The weather here in Krakow is great, so we're serving the coffee today outside. While you're there, do go visit our sponsors, especially Sentry and CodeMagic. They're doing raffles for great prizes here on the stage at 4:30. So if you sign up now on this break or lunch, you may win some prizes. If you are at home, don't go anywhere. We have the live studio interview starting right back here, so they'll be on the stream, and they'll be also cast here on the main stage. Enjoy your coffee break, and we'll see you back here in a bit.
Hello, everyone. Welcome to the second day of App.js. What a wonderful talks we had already. But here we are right now in live studio. We are your hosts. I am Wojtek. This is my brother Mariusz. But it's not about us. It's about our wonderful guests here. And right now we have a pleasure to be here with Ivo Plaza. Welcome.
Thank you. Thank you so much. Yeah, I'm really happy to be here.
Yeah, so maybe...
Yeah, well, let's start from the facts. So here with us is Ivo, that is the lead engineer of the Type GPU library. Well, when we talk about the Type GPU, let's start with a question. Let's say I'm a developer and I want to add a 3D model of a horse into my app. What should I do?
Right, very on brand for software management, right? To add a horse to an app. Yeah, so right now, thanks to the work by William Candilan and Krzysztof Piaskowy, we can use WebGPU on React Native. And FreeJS is actually using WebGPU underneath. So that means that we can run FreeJS on React Native just as well. And I think, yeah, right now, FreeJS is the best way to add 3D models to your app. Because that's the use case that it solves, right? FreeJS was built for 3D graphics on the web, and since we have the same technology on React Native as well, we can just use that, and yeah, it works just fine.
So why should we use Type GPU? What would be the use case, or what are the limitations of FreeJS that are not solved there?
Yeah, great question. So a lot of businesses see Type GPU, see FreeJS, and you know it's a pretty long-running project, right? Right, it's been running for a lot of years, and it solves a lot of very difficult problems and challenges, but it's pretty big. Like its bundle size is pretty large. And it has a lot of assumptions that make it hard to optimize. So a lot of businesses opt in to build their own abstraction on top of things like WebGL and WebGPU, just to get that performance speed up or to just build something very specific to their business. And yeah, like there's not really much help in between FreeJS and WebGPU. Like when you want to do something custom, to opt out of FreeJS, you just go straight down. You go straight down to WebGPU, and that's like the lowest level on the web that you can get to. And WebGPU was really built for frameworks. It was built as a new backend for frameworks, and it's really powerful. And the API is great, but it's very low level. If you want to communicate with the GPU, you send a string of instructions, and if you want to send over data, you do it in binary, and you're responsible for serializing and deserializing that data. So what Type GPU is something between 3JS and WebGPU. So it's something that library maintainers can use to build their own abstractions on top of WebGPU without the need to re-implement everything and build their own serializers, deserializers. So I like to think that Type GPU is to WebGPU what TypeScript is to JavaScript. So it not only like adds types to WebGPU, but it also it's meant to improve the APIs that we build on top of WebGPU. Yeah.
But you're still creating JavaScript library, and that is some different technology that the people that writing shaders are used to. Do you have some friction around that?
Yeah. So we were doing a couple of like campaigns of marketing for Type GPU. We wanted to like see if people are interested in the library. And our newest frontier for Type GPU is allowing users to write shaders in TypeScript. Like Krzysztof Piaskowy showed in his presentation, I recommend you watch that. Yeah, like it's awesome for web developers to be able to do that, to just use their existing knowledge of the language and just write a program that runs on a different hardware, right? Different type of hardware. But we tried to like probe existing graphics programmers, what they think about it. So we posted a Reddit post on the graphics programming subreddit, and we were like, oh, what do you think? Like, what do you think about writing shaders in JavaScript? And most of the people there are like avid C, C++ programmers, Rust programmers. They really care about like low-level stuff. So yeah, them just seeing a shader that has to be performant. That's why you like use shaders to do stuff. Written in a dynamic language with no types, it's like, what are you doing? What are you trying to do here? But I feel like after we explained that it's mostly to unify the web platform and to allow web developers to get into the space of graphics programming, which is usually really intimidating for people. And rightfully so, right? Like you have to learn a new language, basically. You have to know how things are laid out in memory. So it can be very intimidating. And I feel like after we explain that, people get on board a lot more from that space of just low-level graphics programmers.
So basically, instead of writing a huge string, right now we have great typed way to do that easier. So if I wanted to become a graphic developer, what should I do? What would be the steps to become the developer that works with Type GPU?
Oh, great question. Yeah, so right now we're building Type GPU more for existing web GPU developers. So now our main frontier is just helping existing web GPU developers, but in the future we really want to lessen that learning curve for your new developers coming into the space of graphics programming. But for now, I really recommend people just go on ShaderToy. It's a really great website that showcases a lot of cool effects you can do on the GPU. And just look for like examples that are simple, that are trying to do simple things. Look at the code, try to understand it. I can really recommend Inigo Quiles. I feel like that's a name that's really like, that's just like, you hear about him everywhere in the graphics world. He's awesome. He does a lot of shader programming, and he's the creator of ShaderToy. So yeah, I guess that connects. And yeah. It is a different paradigm, right? You have to think about the program in a little bit of a different way. But to me, a good way to think about it is that for a graphics shader, some program that you just want to write that runs on a GPU, we usually think about it. Okay, I want to add a horse model, right, to the scene and just render a horse model, give it a light somewhere and something like that. But we have to think about it on a lower level. So a horse, it's just a bunch of triangles, right? It's just like a triangle here, a triangle there, a mesh of triangles. And what WebGPU is just a machine to draw those triangles. So what we tell WebGPU is, okay, I want to draw 1,000 triangles. And WebGPU is like, okay, awesome. So now you, as the developer, tell me for triangle 0 or for a vertex 0, what's its position? And it's your responsibility to provide that information. So it's a lot low level, but it opens up so many things you can do. So like, where does that information come from? It can come from, like, you can load it from the network. You can generate that position information dynamically. So I feel like when we think about it that way, it's like WebGPU asks us where the position of those vertices are, and then for each pixel, it asks us, okay, I want to draw this pixel, what's its color? And you have to just provide that. Yeah, it opens up the possibilities for a lot of effects that you can do in your existing React Native apps. You can basically just take a screenshot of your app, and smudge it around a bit. Like that's what you can do. We do that in the App.js Conference app. You can check it out. Yeah, it's a process, but it's really worth it. It like opens up a new tool set that you can use pretty much anywhere.
So you can manipulate actually every single pixel you can see.
Yes. Yeah, because it's kind of counterintuitive. Because usually when we think about programming on a CPU, and we see like a for loop that goes over like the whole screen, right? If you want to change every pixel of an image, we do a for loop on the x-axis, we do a for loop on the y-axis, and we do some transformation over the pixel, right? So the way we think about it is, okay, it goes sequentially over every row and every column. But what the GPU actually does is that little transformation on the pixel, it does all of those at the same time. So just this small transformation that you wrote, even like a large one, it does all of that pretty much simultaneously. So if you ever have a piece of code that goes over something like an array on the x-axis, on the y-axis, you can do that really fast on a GPU.
That sounds pretty awesome. So where can we play with it?
So we have the typegpu.com website. You can go there. You can look at our live examples. And actually, you can, like every example, we have a button Edit on StackBlitz, and it just creates a new project from that template example, and you can manipulate it from there. So if you see an example that you like, you can just click the Edit on StackBlitz button. It creates a new StackBlitz project, and you can play around with it, share it with others, download it onto your local computer, like create a Git repository from it, tell an AI to change it. And yeah, it's for us, it's been really fun to play around and create these examples. And we've seen people from the outside, like outside contributors, create their own examples. And we have a way to very easily create controls that control what you're saying. So you can create sliders or color pickers that change the way that the shader behaves. So yeah, that's what I would recommend. And if you want to learn more than just those examples, then yeah, Shader Toy is a really nice resource.
Right. So I have an example that you really need, and I seen on the web. What chances are that it's gonna look and work great on Android and iOS devices using React Native?
Right. So right now, React Native Web GPU is in technical preview. So that's based a little bit because it's still early days for React Native Web GPU, but it's also because it's early days for Web GPU by itself. So Web GPU is a new standard, and it's like the spec of it is fairly written out, but implementations of it are still ongoing. So the folks at Chrome are making their own implementation, which is called Dawn, which is the engine that powers React Native Web GPU. But there's also WGPU by the Firefox team, and that powers the experience in Firefox. And yeah, those implementations are still a work in progress. So there are some edge cases where if you use React Native Web GPU on some devices, it's not 100% compatible, but it's a web standard, right? So like, it's inevitable that it's going to be supported by pretty much every browser out there. And with support, with it being like the new backend for Skia and React Native Skia, I think it has a very secure future for itself. So if you start now, and if you start playing around with it now, you're going to be on a good path to have these tools at your disposal when it becomes stable, right? When it comes out of technical preview.
Okay, Ivo. So it was great talking to you. We've learned quite a lot. We've heard quite a lot of GPU here. So well, thank you for the conversation. And to the folks watching the conference, have great talks and have fun during the next section.
Yeah, I hope to catch everybody at the conference and talk to you. If you want to talk GPUs and graphics, catch me at the conference. Okay, awesome. Thank you.
Thank you.
Discover AnimateReactNative.com, your go-to platform for premium, customizable, and ready-to-use React Native animations. There are over 120 different animations that are going to save you time, enhance your app, and, in my opinion, is the perfect collection if you'd like to learn more about React Native animations. Get 60% off by using App.js Conf. Visit AnimateReactNative.com.
11 Labs conversational AI is evolving. We've been optimizing some brand new features to create the most sophisticated voice agents in the world. First up, we've developed a state-of-the-art turn-taking model to help agents perfectly understand when to interrupt.
Thank you. And what's your order number, please?
Oh, let me just double check. 947835.
Perfect. Your delivery is on its way.
And secondly, we've integrated language detection for seamless multilingual discussions.
Hi, welcome to our design studio.
すみません。日本語で話してもいいですか？
もちろんです。日本語に切り替えましょう。
And we've built the world's first integrated RAG for voice agents to retrieve from your knowledge base at minimum latency with maximum privacy.
Your next patient is Mr. Frank Reynolds with ataxia.
Oh, it's been a while since I've worked with ataxia. Could you remind me of the guidelines, please?
Sure. I analyzed all the best practices and found this.
And lastly, why limit your creativity when you can switch between multiple characters in a single agent?
Okay, guys, let's head east towards downtown.
I'm not sure about that, boss. Hey, don't be scared, man. Let's just go.
This is just the start of a new era of communication and understanding, all with full HIPAA compliance, third-party integration, enterprise-grade security, optional EU data residency, and industry-leading reliability across all agents. The potential of conversational AI has never been greater. The time to build is now.
Good code is good, we don't touch that. But for everything else, there's Sentry. Whether you're a mobile, back-end, front-end, or any end developer, we'll show you the environment, device, OS, even the commit that introduced an error, down to the broken line of code. Yet the woes of a developer go far beyond when code is broken, it's also when code is slow. Detect endpoints, slow spans, and operations consuming the most time across your stack and keep everyone feeling not bad.
everybody, and welcome back. Hopefully you enjoyed your break, you've gotten extra caffeinated, and you are ready to start the day. We are going to go into another set of talks, but before I do that, I just want to shout out to the people in the back. Hopefully you're having a good time, but if you want to chat, just step outside so that we here in the auditorium can hear the speakers. All right. One thing I do love about coming to conferences like this is not just hearing from other people who are building on top of these technologies, but hearing from the people who are building the libraries, the frameworks that we're all using. And especially when we get folks from, for example, Expo and Meta come in and talking to us about the platforms that we stake our careers on top of. So I'm really excited to hear this next talk coming from Alex. Alex works at Meta and is working on the React team and working on React Native. And I am really excited for him to talk to us about the journey towards a stable JavaScript API. Can we all give a massive round of applause as he comes to take the stage? Thank you, Alex.
Hey. All right, hi everyone. Are we ready to go? So hello, I'm Alex, and I'm part of the React team at Meta. Specifically, I work on developer experience, along with a great team working on core parts of React Native, such as React Native DevTools and Metro. And I've also been involved with our JavaScript tooling and React Native releases. This is my second time at App.js, and I was on the stage 2 years ago, soon after joining the team. I'm incredibly excited to be back, and it's been such a journey since then. It's a massive privilege to be part of this community, and I always can't wait to share what we've been working on. Today's talk is a deep dive. It's a deep dive into a problem we've wanted to tackle for a long time. We've been looking at the problem of how do we get to a React Native with fewer breaking changes? And how do we make this predictable for maintainers and developers? This year, these are questions we've started to incrementally tackle in an effort we're calling Stable API. Stable API is a series of changes we want to make to improve React Native stability in future versions. As you've seen during day one of this conference, so many incredible companies depend on React Native to achieve incredible things. However, our framework isn't as stable in terms of developer experience as we want it to be. In particular, the experience of React Native upgrades. Stable API aims to address this by scoping down and formalizing our existing APIs and by improving related tooling. This will help give the ecosystem stronger guarantees around the core of React Native and will help us move faster and make fewer breaking changes while making upgrades easier. And I'm personally really glad that we're finally making moves on this effort. So here's an outline of what we'll discuss today. Why is the public API important, and what our goals are for the JavaScript API with this effort? We'll dive into key problem areas and what we've built. And then I'll be sharing new changes coming to the JavaScript API in React Native 80. React Native is a project with many software components written and distributed in several languages. Each of these interface with specific platforms via APIs accessed by apps, libraries, and frameworks. Stable API will be approaching each of these over time. Today, we're focusing on JavaScript, specifically our JavaScript Runtime API, the surface that most React Native developers are familiar with. After all, JavaScript is the primary language we're writing our apps in to create amazing cross-platform experiences. And I might be biased, but this is our most important API surface in terms of the number of references in every React Native app. A good API should define what is internal and what is externally available. It should be a boundary, thereby limiting the surface area that a consuming app or library can access, the public API. Without this encapsulation, the surface area of an API is too great and cannot be managed or enumerated. This is our problem space. And this problem space includes developer experience, specifically via types. What do users expect? Accurate type checking of their program and real-time code completion. Automatic imports of available APIs, and high-quality inline documentation. This is, of course, enabled by TypeScript. Great TypeScript types mean great developer experience. But crucially, TypeScript is vital for our goal. Missed that one. As it ensures system-to-system compatibility on a types level. It should make updates predictable, so long as the representation of our system is accurate. So, don't we have all these things currently? Unfortunately not, and we need to close the gap. One of our problems with the JavaScript API today is with encapsulation, which up until now has been more of a suggestion than a rule. This is a simplified view, and here's the reality. Looking at it in terms of modules. In addition to our index entry point, there are also 750 plus internal implementation files that are directly addressable by apps and libraries as deep imports. This is our first key problem. We can't have all these code paths be public. While there might be well-intentioned reasons to reach deep into the framework as a consumer, it makes the surface area of our API too massive. And it prevents us from being able to move or refactor internals without causing a breaking change. We should instead expose a more intentional API. The next problem is manually maintained TypeScript types. The API that you see when using React Native today doesn't directly represent the runtime code. Instead, these are hundreds of separate, hand-edited files. These are error-prone, with no validation, some approximations, and we're not always in sync, leading to drifting type structures and various inaccuracies. And this is what the whole ecosystem uses. This was not good. So we'd be getting at least one contribution a month, fixing types. And while we've been so grateful to the community for helping us maintain these, we need one source of truth. We could delete this. This gave us a couple of initial to-dos. Address poor encapsulation, and see if we could replace our manual TypeScript API. And we had our vision. Make breaking API changes predictable. To do this, we'd need to be able to enumerate and traverse the shape of the public API from a smaller set of entry points, and represent it in a format which we can diff between releases. And here, we took some inspiration from Android. And that's the concept of an API snapshot. A single file containing just the type signatures of the entire Java Kotlin API and no other noise. This is committed to our repo and must be kept up to date. Having an API snapshot means that when a change is made affecting the API, maintainers can see that change in the git diff, and we can decide whether the change is breaking. So we basically want something like this format for JavaScript, which didn't quite exist yet. So this gave us another high level to do. And we had to figure out what was important to work on first. In fact, initially, this snapshot goal was our first priority, as it's how we'd approached other languages. But we didn't want to think about it this way. We wanted to think about outcomes. One outcome being, with the public API snapshot, us as maintainers would be able to accurately understand breaking changes and therefore determine if releases are breaking. But the other outcome, if we got the entire way with a strongly defined stable API in TypeScript, would mean that developers across the ecosystem would have much stronger API guarantees between releases via TypeScript. Clearly, this second outcome was far more important for our users and for our partners, and could most likely make it easier to build a TypeScript-based API snapshot afterwards. So, JS Stable API is two high-level goals. One, to narrow down our API to a more strongly defined contract that our community, both apps and frameworks, can accurately depend on, fixing our encapsulation issue and replacing manual types. Secondly, to create a public API snapshot to understand breaking changes. To do this, we'd be creating our own tool chain towards both of these goals, and ultimately modernizing and aligning our codebase. But beginning in January, we absolutely had a lot of questions, a lot of work ahead of us, as yet unknown challenges, and the sensitivity of making changes that would widely impact the ecosystem. But the good news is we were ready to kick off this work, and we wanted to move reasonably fast. So we needed a team. We were really happy to have Software Mansion join us and put their incredible talent into realizing this effort. And we worked with Amazon as a key partner to consult with on the design of our changes. So let's dive into some of the work we took on. Overwhelmingly, we were focused on fixing all gaps necessary to generate a public API from one source of truth. And this work results in 2 significant user changes that we'll be introducing in React Native 80. The first thing to do was address encapsulation. And we started to do this as a deprecation of deep imports, sharing an RFC earlier this year. This change will reset the baseline for what parts of our code base are in React Native's public API. Functionally, we'll start introducing warnings on using deep imports from the React Native package. Using the root import will become the only way to access APIs, both for values and types. For many apps, this will be no change, as the root import pattern was already canonical and intuitive. However, some deep imports to our internals will be removed from the public API with this change. Again, initially as warnings. This is part of intentionally reducing the surface area of our API. And these changes will become enforced later this year. This now means that React Native's public API is explicitly defined based on our root exports. It's the same API you know and love, but is now enumerable and deterministic. And it's a simple and effective change to get to our well-defined API goal. Now, let's look at API translation, because having great React Native TypeScript types shouldn't be a catch-up game. This was the most ambitious part of our plan, which would require both new tooling and a review of our whole code base. As a quick aside, why is TypeScript a question for us at all in 2025? React Native is written in Flow. Given the rest of the world doesn't use Flow today, this is a problem, but we have genuine reasons. React Native is core infrastructure at Meta, and we test every merged change across our family of apps. At this scale and sensitivity, correctness matters. And the bottom line is that Flow offers us greater performance and greater strictness than TypeScript. Also, we can innovate with custom features for our product engineers, such as specific multi-platform support for React Native and React component syntax. So, changing the source code base to TypeScript is not an option. We need a way to convert Flow's source code for each of our input modules to generated TypeScript types. The good news is there's a tool that does the core of this, and it's something we'd already approached using in the past. It's relatively new and maintained by the Flow team as part of improving interop with TypeScript. Flow API Translator lets us convert Flow files into type definitions in either Flow or TypeScript. But we had challenges to overcome, both inside and outside of this tool. Namely, unsupported syntax in our codebase that we need to either convert or add translation for. Additional Flow and TypeScript differences, both in the language and for some of our typings for React. And, quite importantly, missing type coverage and different type shapes defined in our Flow source code. We worked pretty sequentially at each of our tooling blockers, beginning with modernizing parts of our codebase, including migrating modules to export syntax, which we shipped as a minor breaking change in React Native 79. We then made a suite of contributions directly to the Flow API translator stack, a total of 11 improvements which addressed our remaining syntax issues for TypeScript translation. Then, we added a number of our own code transforms to smooth over remaining codebase-specific issues, and to ensure we were providing as good or better type ergonomics for the end user. This as good or better types goal also shifted us to the codebase itself, where we carried out a types audit. This was to address how our dual codebases had drifted over time, looking at things like missing code comments, which were usually more complete in TypeScript. And more pressingly, different type names, unexported types where they made sense, and addressing where type definitions conflicted. We'd figure out the real source of truth and refine our Flow source code. And we generally aligned these in the direction of matching our existing TypeScript sources. We did this across each of 78 exported APIs, also aligning every reference in Meta's Flow product code in the process. This was a huge effort. So we ended up with a custom type generation pipeline. Taking our new single entry point, we traverse the codebase and reduce files to only their public types, and apply some of our transforms. This gives us a type-only codebase in Flow, which we can then feed through Flow API translator, and include the resulting TypeScript types in our main NPM package. So by the end of this, we'd essentially built a bespoke type bundler for React Native. And it really worked. Seen from another perspective, our type generation script takes over 900 input files for the main React Native package and outputs 225 output definitions in TypeScript. This is the result of locating all significant modules containing public types and translating their public exports. The result is a completely parsable TypeScript program from the index.d.ts file. And this accurately represents our public API going forward. Getting this pipeline right took an immense amount of work behind the scenes over several months, and involved making some small but necessary breaking changes focused around our internal files. So I really want to call out and say thanks to these incredible individuals at Software Mansion, who worked extremely hard to make these changes reality. Just an incredible amount of work and work to come. So we now had a generated TypeScript API that fully represents React Native's codebase. Next, briefly, we'll have a peek at the API snapshot we're working on for maintainers. So we actually shipped a scrappy V1 of this last year, where the approach was to simply glob every file in the codebase and print out their type signatures via jest. This approach was okay, but it meant it also caught many irrelevant changes and wasn't capturing the real public types accessible through our API. For our new snapshot, we wanted a better and more exact format, one that only includes types that form our public API, is as small as possible, and includes no irrelevant information in the diff, such as internal file names or type names that aren't ultimately exported. It turns out we get some of these properties from using our earlier pipeline. Now, it was a question of if we could take our types-only TypeScript codebase and reduce that into one artifact. We looked at an open source tool from Microsoft for our first prototype. It's called API Extractor, and it does pretty much what we want, producing a single bundled definition file from our API entry point. This is pretty great as an early result, but we think we can improve some things and are internally experimenting now. Here's one of these improvements. We're exploring local type inlining, which aims to reduce the number of type names in the snapshot and show changes in context for types that aren't exported and are non-recursive. In this example, we align the alert buttons type onto its one usage in the alert class. This deletes the original type, and we see a more complete representation in our alert function. If the style property was now deleted, the developer can see the true impact of their changes, affecting not only the named exported type, but also its usage elsewhere. And interestingly, this isn't making the snapshot bigger. Our prototype is around 10,000 lines right now, equivalent to our current Jest v1, and we'll be working to refine this. So, given our generated user types from the earlier pipeline, we now input into API Extractor. This bundles our type-only program from our main entry point. And then we reduce this file via a number of transforms into a more diffable format that is our API snapshot and will be committed to the repo. This is our full type generation pipeline. So this API snapshot is still under active development, but the results will start hitting the repos soon, and we're feeling really happy about reaching a strongly diffable output format that contains the whole API and is free of noise. We will be adding CI workflows around this snapshot to detect and automatically flag breaking changes to maintainers. This is really going to help us improve and refine our releases. And even maybe DocGen in future. So, what does this all actually mean for developers? I'm excited to share that you can begin benefiting from these improvements, starting from React Native 80. There are no hard changes at this point, but we're starting a deprecation cycle for the current JavaScript API and its types. The first change is our deep imports deprecation. As mentioned earlier, we're introducing new warnings via our ESLint preset and at runtime in development builds. These warnings will have opt-outs, but bear in mind we will be moving forward with these changes in a future release. So you should begin addressing any deep imports in your apps. And we're aware this means we may have work to do on our side as well. If you're using subpaths today for valid parts of the API that you think should be public, we have an open discussion thread on GitHub to get your feedback. If there's an API you need, we want to hear about it. For the second change, we thought about where do all of these incremental language improvements and type translation take us. In practice, these create a new API baseline for React Native. So we're launching something which packages everything together, and we're calling this the strict TypeScript API. It's our new, accurate, from-source TypeScript types, and models our new formalized public API, with our explicit API exports at root and our type refinements. This is the foundation for future, non-breaking React Native releases. And it will be opt-in from React Native 80. And this is how you opt in your project's tsconfig file. Under the hood, this routes the TypeScript server to our new generated types included with React Native. This is a separate directory of type sources based on all the work you've seen today. And it means that without this opt-in, the previous setup is left in place. So you can try it out and swap back anytime. Opting in brings some specific breaking differences. Firstly, the strict TypeScript API will no longer model deep imports. TypeScript will not know about private APIs or suggest their import paths. Secondly, it switches to our improved and revised type definitions, which may require some adjustments in app code. We'll be documenting exactly what these changes are on our website at launch. And again, it's the same React Native API you know and love, but with higher quality API guarantees. And you can choose to migrate when ready. We've been validating how the strict TypeScript API works with a number of popular ecosystem libraries, which are each able to be aligned with non-invasive changes, as well as validating against the base coverage of our existing type tests. So, how do we plan to migrate the community? We'll kick off with our deprecation and the opt-in strict API launch in React Native 80. This begins an API consultation period where we're open to feedback about promoting unexposed internal APIs to our new API, if they're justified. We want your feedback, which you can send via the open GitHub discussion. And we'll also be working directly with partners on this. From React Native 82, we aim to have a finalized JavaScript API for all apps and libraries. And if we need to, we'll extend this timeline. After this, deep imports will be removed for both JavaScript and TypeScript consumers via package.json exports. And we'll switch to the new API as default as a one-time breaking change. You can get ahead of this breaking change now by opting in from React Native 80 and future-proofing your app. We're planning to document these changes and our plans fully in an incoming dedicated blog post and in our docs. So that's the strict TypeScript API. It encodes everything we've seen today. It's a new JavaScript API baseline for React Native, providing better types DevX, and is a foundation for future non-breaking releases. We've moved from an unsafe, poorly defined public API to a place where the API is more exact for us and more exact for the ecosystem, and means we're on the path to one day making React Native's whole API stable. Thank you.
Let's give it up for Alex one more time. every company usually, every organization usually says, oh, we're listening to our users, we're doing what we can to make them happy. And it's always good when you hear someone come in and talking about their API or something, and people in the audience are genuinely clapping because they're making our lives easier. So thank you so much, Alex, and it's amazing to see the work that they're doing at Meta. Now, we're going to move on with another amazing speaker. This speaker, for some of you who've been to App.js or maybe watched App.js a few times, this speaker may look familiar because they were here last year and they're going to be joining us again. Delphine is working at Mistral. And one thing which I really enjoyed this morning was I actually happened to have breakfast with her. We were just talking about the kind of AI space and all of these different things and what it means for developers like ourselves. Now, I'm not going to take any of the punchlines away from her talk, but it made me think a lot about how so much technology that already exists and the frameworks and the things we're already using are going to be reinvigorated with new life and new use cases as we fit those in with some of these LLMs and AIs that we already have. Now, if you read her talk description, you probably have an idea of where this is going. But without further ado, can we all give a massive round of applause to Delphine? Thank you.
Thanks. Hello, everyone. Really happy to be here. Let me start this presentation with a quote. AI has changed the way I work from a famous anonymous programmer 2025. And I think many of us can relate in the room. Like we've seen Rafael's talk, we've seen Christophe's demonstration earlier. I relate a lot. AI has changed my work. No, it literally changed my work. I changed job to join an AI company. And not just any AI company, the European leader in large language model creation, Mistral AI. Woo! If you don't already know who Mistral AI is, they published their first models back in 2023, like literally published, they open sourced them. Then they started to sign partnerships with institutions and companies to bring AI to solve real-life business problems at scale, along continuing developing new models, of course. And then last year, in 2024, they launched their first B2C tool called Le Chat, which is a conversational tool on web to allow anyone to interact with Mistral models. Le Chat means the cat in French. So the new logo is like a cat's head with a little mustache like this. Le Chat grew and grew, like code generation, image analysis, document libraries. Only one thing was missing. An app. A beautiful app to actually put Mistral models into everyone's pocket. And this is when I joined them last year to build it with them and with React Native and Expo, obviously. We launched it in February 2025. And only 8 days after the first release in production, we had already reached more than 1 million downloads on iOS and Android. So this was great. This was like a great moment to live as a developer, and it's still a great joy and pride to work in this team and company. But maybe it's time to introduce myself a little more. My name is Delphine Bugner. I work in the engineering team of Mistral AI. You may have seen my drawings online. I like to do them for the React Native community. You may also have seen my yoga talk last year at App.js. And if you have seen this one, you know that what I love most of all is to look under the hood of the technologies I use and actually understand how they work. And today, the technology we're going to looking into is the streaming of text, because it's an essential building block of any generative AI application. Let me show you. When you prompt le chat with a very pertinent question, his answer does not appear into a single block of text after an eternal loader. It appears word by word on screen, exactly mirroring how generative AI work. Generative AI creates the answer token per token, so it's of crucial importance that we reflect these changes as soon as they arrive to the user to ensure stream experience. But it's not that obvious to do in React Native. And I learned that the hard way. When I first joined Mistral, they already had an internal version of the app. My first mission was to integrate it inside the monorepo and start to share some code with the web. The first time I tested my newly PNPM proto, roughly this happened. An eternal loader. Generative app, not generating anything. That was a really lonely moment. The answer of what was happening was actually written in my notebook when I first analyzed the code base when I arrived. A polyfill were used to stream. You probably all know what a polyfill is. It's when you replace a method that is available globally by your own custom implementation, maybe because you can't rely on the same primitives as what the global method used. You need to put them in your index.ts file, and I simply forgot to move this file when I moved everything inside the monorepo. In our case, this was a fetch function that was polyfilled. So as soon as I put it back in the index.ts file, streaming started to work again. But it was too late. I'm a stubborn person. I wanted to know more. Why was a polyfill needed to have streaming working in React Native? Why was it not included by default? And what is a stream request compared to a normal anyway? And what's the difference between web and mobile? This is what we are going to see now. This is a brief history of streaming. And when I mean history, I really mean going back to the very first time the concept was defined, because streaming is old. Mathematically, streaming just means an exchange of data between a source and a target that is continuous and potentially infinite, where you don't know in advance which size it will take. It's as old as the 50s in Fortran, where the source was a keyboard and the target was a monitor. The goal was just to display the characters the user was typing. Then in the 70s, Linux formalized the concept a little more with the notion of standard input, standard outputs, and a false signal. It was used to read files or write some stuff on the disk. And we need to wait over the wire with HTTP 1.1 and trunk transfer protocol. We could already stream HTML at the time. Then in 2006, the Opera Navigator developed the server-sent events API on top of trunk transfer protocol. That was easier to write. You can identify it with this text event stream header, and this is exactly what we use on the server at Mistral, like many other LLM applications. And then on the client, we use the fetch function that was introduced in 2015. Why 2015? It's also the year of the publication of ES5 that introduced the concept of promises, and fetch is based on the JavaScript promises. It replaces the old XML HTTP request API. Now that we have this overview, let's dive in the fetch function on the client and look at the request. We're all familiar with this API. You fetch an URL, you await until you get a response. But the second part, was always a little bit harder for me to understand. You also need to await to get the actual data by calling this .json or .text method. Why await? Again, I already awaited the line before. Could I just get like the response.body and get the data? And the answer is the response.body object is actually a very specific object called a readable stream. The .json method is just syntactic sugar on top of something more complex that involves streams all the time. It was streaming all along. Who knew this? And we're going to detail this immediately. When you prompt the server from your app, what you get through the Fetch API is the status of the response and the response body, the famous readable stream. You can then, it comes with a default reader that you can plug to it, and you can then await as many times as the server is going to send chunk of data asynchronously, n times. Therefore, the name of async iterables. The data that comes from the server is like integer arrays, like this. So you also need to plug a decoder in the output of your reader to actually transform this into human-readable characters, like this. And finally, refreshing your UI and display the text as soon as it's arrived to the user, word by word, or should I say, token per token. As soon as your server sends you a chunk with an undefined value, this is the EOF signal. It means the stream is over, completion is made, you can stop looping in your stream. It's the same if the user wants to stop it. If you attach what is called an abort controller to the request, it will send a signal to the server and also block the stream. So if we have a look at an example of all the chunks we received, if you forgot to plug your decoder, this is how it looks like. This is how it looks once you decoded them. You might notice like the recurring series of numbers is just the way that we just sign our text chunk at Mistral with a 0, but like tool calls chunks are indexed on number 5. If your server sends a single chunk of data, basically you will just loop with your reader around a list of one element and decode it for your user. And this is what the .json or .text method does. So it seems pretty simple. Therefore, what was wrong? Why nothing was appearing when I forgot to add the polyfill in React Native? Well, in React Native, with the default fetch function, there is no response.body field. There is no response.body, no readable stream, nothing. Why, React Native? Why? The cat is not happy. And we are going to look into it right now. You might have already heard this. React Native is native. Literally. You call JavaScript function, but under the hood somewhere, it has to be linked to native APIs. So if we take a look in the React Native core repository, like the fetch function, how is it defined? Is just exporting a single existing polyfill called the WhatWG fetch polyfill. WhatWG, quite hard to pronounce. It's just a reflection group, like the ECMAScript is for JavaScript, but that thinks about what standard put in the browsers, especially standards to ensure compatibility between old browsers and new browsers. They defined a polyfill, replacing the fetch function by the API that existed before. Remember the chronology we saw? This was, it replaces the fetch with the XHR equivalent, the API that existed before. Then the React Native team rewrote its own XHR version in JavaScript that is directly connected to the native, and this is a module called RCT networking in React Native that is itself connected to native API, finally, NS session in iOS, OK HTTP on Android. Phew, I'm stopped with the name dropping. So where in this flow, where did the response.body disappeared? Like, is it in the native side? Does native APIs do not support streaming? So I've been looking to the documentation, and they very do support streaming. It's even the same verbatim on Android. It's a response body. So they are not. No, the bottleneck comes much earlier in the flow. As soon as the WebRTC fetch polyfill, we already lose the response.body field. Remember what I said, WebWG ensure compatibilities between old and new browsers. Old browsers can't use readable stream anyway, so you don't need to provide one for them, therefore the absence of body. But what this polyfill provides is a direct replacement for the JSON and text methods not based on readable stream anymore, and this is why we can use them in React Native. Okay, but could we just jump over this XRChair polyfill blocker, like actually going to connect the JavaScript with the native without this polyfill? And this is what does the polyfill that we use, which is like the React Native community fetch polyfill. The first step to build this polyfill was actually this pull request on React Native 61 to enable external APIs to access the networking module of React Native. Obviously, they've done this because they were not happy with the way XRChair was doing streaming. Then it basically works with a system of events between the JavaScript and the native, rebuilding a readable stream on the JavaScript side based on the event emitted by the native module. So if we take the same scheme as earlier and rebuild it in React Native, this is how it looks like. We have the server emitting a chunk of data in binary. The native module emits an event, did receive network incremental data. The fetch polyfill acts like a proxy, catch it. It has rebuilt a stream on its own, and it enqueues the data in this new stream and exposes it to the front part of the fetch. And then we can continue the flow that we had seen earlier. Pretty straightforward to understand. But when I looked into what was into the native module, to look at the events that were sent to the JavaScript, this is what I saw. I don't know if you see very well, but we don't send binary data. We send a string. The text was decoded by the native module and converted to a single string, accumulated all the chunks that were sent by the server. So if we want to be accurate in our scheme, RCT networking decodes the text, sends a full string concatenating all the binary chunks, and then the fetch polyfill re-encode them to mimic the actual behavior of the fetch function on browsers and send it, and we redecode it later. So this is bad. The cat is still not really happy about this. And to understand why it was done like this, we just need to remember that the networking module of React Native was fully designed to work with React Native XRChair. The way of concatenating chunks into a single string is the way of doing streaming with XRChair. It's called the response text API, and it's not really performant. And if you're asking why React Native was built on top of XRChair and not fetch, and beautiful APIs. Remember again the chronology we saw earlier. React Native was open source for the first time in 2015, the very same year as the fetch was created. So obviously React Native had to be built on something older, and the standard at the time was XHR. But we really do want to do streaming in a more performant way. So is there a possibility that we could read directly into the native API? We saw it supports streaming. Someone has done it. This is the good news. Someone has done it. It was already mentioned earlier today on this very stage, but I don't think he's here. This is Kiryl of Expo. Woo! Really, he's done an amazing job. This summer, he just decided to publish 2 pull requests together, one for iOS, one for Android, rebuilding the fetch function from scratch, directly connected to the native API, and published it under the name of Expo Fetch. And yeah, I've checked. So it's based on the WinterCG standard. WinterCG, the concurrent reflection group that does not care about interoperability between browsers, but rather interoperability of JavaScript between all platforms, especially for mobile. So it's really a good, better standards to follow. It also communicates with events between the JavaScript and the network. Expo Fetch, between the JavaScript and the native, sorry, with the new Expo Fetch module. And I have checked in Xcode, because I love putting breakpoints in Xcode. When we send the event from the native, we send binary data, no string decoded anymore. So this is roughly our head right now. We're really happy with this new API. And this was roughly my reaction when I understood what Expo Fetch was doing under the hood. Literally, I stopped doing my slides and opened a pull request on the Mistral repository to replace the polyfill we were using by Expo Fetch. And I'm very happy to say it's been 2 weeks since it's in production and since working perfectly well. Okay, we are approaching the end of the talk. I just want to quote 3 last elements around the streaming. The first of them is, even if we're now using the Expo Fetch standard that is so great, the completion request is still kind of its own in our repository because we can't use TanStack query on it. TanStack query is used everywhere in our code base except for the stream request because TanStack query does not support streaming, but Dominic Dorfmeister is working on it. And the new API is going to look great. You're going to just have 2 status success once you receive the status of the response, and the fetch status that will be updated when you receive the chunks one by one. So can't wait to use it. Can't wait to use a new API for streaming. Second stuff I want to mention, kind of the elephant in the room when you're speaking about streaming, it's server components. You actually don't need streaming to have server components. You can render your HTML, your JSX on the server and send everything in one time to your front. But obviously, it's better if you can send it chunk by chunk and unsuspense or boundary per boundary your React app. And obviously, the final element I want to mention is React Native server component and streaming, because we have all seen this amazing talk by Evan last year at React Conf and App.js. Not only he has demonstrated and given a glimpse to us to what does the chunk of text looks like, not only for text, but for React Native components, he has also demonstrated everything that it can bring to an AI app. So I think it's also the future for Lusha. We will stream text, but we will also stream components. Remember what I said, it's really important to give immediate feedback to the user. And AI is going to be more clever and more clever, able to do new things. Like, if I just take the new agents API that Mistral published last week, your agent is going to walk around and do things in literally a lot of different places. So if you can give visual feedbacks to the user or the process of reflection of the agents, it will just like make the experience more fluid and more trustful for the end user. The future is bright for React Native. The future is bright for streaming and AI. So thanks you for all, and use le chat of Mistral.
Thank you so much, Delphine. That was such an amazing talk. And also, thank you to Kudo, wherever you are. If you're watching, we appreciate you. It's always good to see how the community really kind of builds all of this technology together. And then everyone is stepping on the shoulders of giants. I just kind of want to get a feel for the room. How many people here have contributed in some way, shape, or form to an open source project or some sort of open source library? Well, let's give a round of applause for all of these contributors. Thank you so much. All right, let's take it one step further. How many people maintain? Is there anyone here? Well, I guess there are quite a few speakers. Anyone else who maintains some sort of open source project? Thank you so much. I see you. We appreciate you too. It's always good to have people like you helping us to all build bigger and better and contribute back. And it's so nice to see how people contribute and give back to the community in different ways. Maintainers who set up these projects and see this vision, contributors who see opportunities where they can continue to help these grow better. And there are teachers. And our next speaker is one of those teachers. They actually have a YouTube channel called Reactive, where they teach all about React. And today, they are going to be teaching us about some animation. So everyone can cook with React Native. I am really, really excited to see it. Can we all give a big round of applause to our good friend, Enzo? Thank you so much.
What's up, mobile devs? I hope you're doing well. It's amazing to be here at the App.js. Thank you so much, Expo and Software Mention, for having me. I'm super grateful to be here. So this will be a talk about React Native animations. This will be my first talk, by the way, so I'm super, super excited about it. But before diving very deep into the concept, into the subject, just a super quick introduction about myself. I'm Enzo. I'm a software engineer. I do work as a React Native consultant, and I absolutely love creating animations and interactions with React Native. I really love animations in general. I start all of my days with a Totoro mug filled with a ton of coffee, and this really helps a lot, by the way. But more than watching Ghibli movies and creating animations and interactions, I really love sharing the process behind building them. And because of that, 4 years ago, I created a YouTube channel called Reactive with a couple of eyes. It was a typo, but I really liked how it sounds, so I stick with it. And on this channel, I do create some tutorials on how you can create React Native animations from scratch. A couple of years ago, I started sharing also some demos on X, Twitter. To be honest here, I'm just trying to replicate the work made by some very, very talented designers, and I'm trying to use React Native, of course. So this talk is going to be about sharing some tips that I learned along the way while trying to build animations. Nothing too magical, nothing too fancy, just some tips that really helped me a lot along the way. And to do that, I'd like to go a few months back. It was December 2024. I was preparing my New Year resolutions. And during this time, I got some more free time. It was Christmas, and I rewatched Ratatouille. Amazing Pixar movie. It talks about the story of Remy, who is a mouse that dreams about becoming a great chef. And there is a scene in Ratatouille where Chef Cousteau is telling to everyone through the television that anyone can cook. And this scene really touched my heart somehow because, you know, I'm Italian, as you can easily spot from my accent. And in Italy, we have a strong culture around food, but unfortunately, I'm so bad at cooking. So I decided that for my New Year resolutions 2025, no matter what, I want to become great at cooking food. So the good news is that my girlfriend is amazing at cooking, she's super talented, but she didn't really provide any tutorial from scratch. So I had to learn again by observing and replicating what she was doing. And so far, I mainly learned a couple of things, made some very small subjective improvements, but overall, I'm really confident that these things are really going to be helpful in the long run. And the first thing that I learned is that you have to pick the best ingredients, which means that handmade pasta is going to be better than pre-made pasta whatsoever. And the second thing that I learned is that details are everything. Even a leaf of basil on your pasta and pesto will make a huge difference. So of course, that's not a cooking masterclass, maybe next time. But the point that I want to raise is that cooking great meals isn't so different than cooking great animations. And of course, I'm not Chef Gusteau, but I strongly believe, and I can safely tell you, that everybody can cook with React Native. But again, you have to pick the best ingredients, which of course means that you have to go with reanimated. We are at the App.js. I don't think that I have to convince you about that. According to the State of React Native 2024, 96% of React Native devs are aware of reanimated. 87% of them are using it. So I still don't like to take things for granted. So if you're not familiar with the reanimated, I mean, it's a package created by a team at Software Mention. I am super grateful. Otherwise, this talk would have been only about pasta. And it is the way to go because it's so performant. Everything is animated on the UI thread, and it is also very, very easy to use. So practically speaking, we can have a look at this very simple animation. This is a circle animating on the x-axis. And we can build this animation with reanimated by just using 3 different tools. We need a shared value. We need to animate the shared value with a timing or with a spring animation. And we can pass the shared value via an animated style to an animated view. And that's really it. I mean, the implementation is very simple, and it feels like the implementation is simple because the animation itself is very easy. But the truth is that you can really go very far with these concepts because animating always means updating a value within a range. But again, details are everything, especially when talking about animations. And so far, we are not really taking time talking about them. So we need to take time to define the proper configuration. And here, of course, we have timing animations, spring animations. Let's start from the timing animations because these are just easier. And all the timing animations are going to be based on a duration and an easing. And what I was doing until a few months ago was that I was just seeing these 2 parameters. I was faking myself as a designer or as a design engineer, if you want to. And I was customizing my fancy custom Bezier curve, but everything was always based on my own personal taste. But there is something that I learned recently that really changed how I was looking at the animation, which is that even if you want to place a leaf of basil on your pasta and pesto, you can't just throw it away. There are some rules that you need to follow. So there must be rules even to choose the proper easing. You can't just improvise, you need to follow some rules. So to fully understand these rules, let's just have a super quick overview over the 4 fundamental easings. We have the linear one, which has constant speed, no acceleration or deceleration. We have the ease in, which will start slow, then speeds up. We have the ease out, which will start fast and then slows down. And of course, we have the ease in and out, which is a combination of the ease in and ease out. It will start slow, accelerates, and finally decelerates. And here we can try to use our personal taste, hopefully for the last time. And we can try to take the previous animation and basically try to play with all the different easings to see which one looks better. So the linear one feels a bit robotic, a bit mechanical, I have to say. It doesn't really look natural. The ease in feels like we are jumping straight in front of a wall, doesn't feel natural as well. We have the ease out, which looks definitely better than the previous ones, but there is still something missing. And the ease in out just looks perfect because it will start slow, accelerates, and finally decelerates. And that's exactly how I expect an object to be moving. But that's not a coincidence. The whole point is that the ease in and out easings are pretty well suited when the element is already mounted on the UI and there is a state transition or a change in position. The other easings are still super relevant, but when used on different use cases, so for instance, the ease out are fantastic when you want to mount a component on the UI because they are going to start fast. You want that the user gets this quick feedback, and basically they are just going to get the attention right away because they are going to start very fast. About the ease in, they usually feel sluggish. Just avoid using them, use them unless you really know what you're doing. You can see the difference by using the ease in at the left and the ease out at the right. And then the linear animations, as we saw previously, they usually feel robotic and mechanical, but there is a very specific case where you want to go with linear animations, which is the case of perpetual motion. So spinners or perpetual carousel, it makes sense because otherwise you are going to get this flat tire behavior, which doesn't really look nice. So before choosing the easing, instead of relying on our personal taste, we need to try to answer to these questions. Are we animating a perpetual motion? If that's the case, very specific case of something perpetual, let's go with the linear animation. If that's not the case, is the UI element already mounted on the UI? If it is there, and we want to animate the position, we want to animate the state, let's go with the ease in and out. Otherwise, if it's not there, a toast modal menu, and we want to mount it, let's go with the ease out. And that's not something, I mean, to be very honest, that's not something that I learned while cooking. This is something that I learned by these 3 amazing articles, Great Animations by Emil Kowalski, The Basics of Easing by Paul Lewis, and The Handbook to Animation Easings by Drew Powers. These are just amazing. And when you understand these concepts, it feels like you have unlocked the secret behind animations. But the truth is that everything falls apart when we have a look at this one. And here at the top, we have a timing animation. And at the bottom, we have a spring animation. And the second one just feels more natural. And you know, I'd like to recall a quote from a friend of mine who was always repeating and repeating that if you really want to surprise someone, you have to deliver a sense of déjà vu. And that's exactly what spring animations are all about. They are going to be based on a mess, on a stiffness, and on a damping. They are going to be based on physics. They are going to feel more natural by definition. And of course, at this point, we can try to ask to ourselves the classical question, do we need to go with spring animations or with timing animations? And I strongly believe that when we want to animate the motion, we need to go with the spring animation, sorry. And you know, the difference is going to be very subtle sometimes, but there is a use case that really highlights that very well, which is the drag and drop pattern. And here we have this very simple animation. We have a magnet. We can move around the magnet with the finger. And you see that these, I mean, I'm using timing animations here, and there is something wrong. I mean, a couple of things are completely wrong. The first one is that the duration won't depend on the distance. The duration is going to be fixed. And the second issue is that we are not taking into account the velocity of the finger. So spring animations are going to fill this issue completely. You can see the difference. Because, of course, the duration won't depend on the distance. The duration will be based on the mass, stiffness, and duration. And of course, we can also very easily take into account the velocity on the x-axis and on the y-axis. So, I mean, we don't have to throw away what we have just learned previously. We can still try to use the motion rules, but we can just try to adjust them. So instead of using the ease out and ease in and out, we can use some spring approximation. And the concept of spring approximation feels a bit abstract, but it's so easy to visualize. So for instance, the second one here is a spring approximation of the top one. And here, the second one is a spring approximation of the ease out. This is amazing, to be honest. You don't have to be so rigorous while trying to approximate, but I really like to do that, and so I created a small website that you can find at motion.reactive.io. It is open source. It has been created with Expo. It works on web, iOS, Android, and it is powered by Reanimated and Skia. But again, we are talking about motion. I'm not saying that we need to erase the timing animations. Timing animations are still super relevant, especially if you want to animate the opacity or the background color. You are still going to need timing animations, of course, because especially with the background color, you want to animate the colors evenly, so it makes a lot of sense to use the easing linear. But this is just too much theory. Isn't there a quick secret ingredient I can use right away to improve my recipes? And this is a question that I raised a million of times in the past months. And I found out that the secret ingredient is mayonnaise. You can just use mayonnaise, and it will add this touch of flavor right away. It will... Thanks a lot. That's not opinionated, but I really like the fact that you enjoy mayonnaise as well. And I also believe that layout animations are the mayonnaise of React Native. You can really add layout animations right away. It's going to be super quick, and you are really going to get a lot of value by adding layout animations. So to add layout animations, you can start by a view. You can convert the view to an animated view by using animated from reanimated, of course. And then you can just apply the layout property by using linear transitions. And this will just work. This is amazing. But of course, we want to care about details. So let's just add the springify. Let's try to add the mass, the stiffness, and the damping. And that's really it. So you can see, I mean, at the right that we have a pretty huge difference. You can see also the best cuisine. I mean, Polish cuisine is amazing as well, I have to say. And you can also play with entering and exiting animations when talking about, I mean, layout animations. And these are really just 3 lines of code, and you're really going to get a crazy amount of value. But at the very beginning, I was talking about multiple ingredients. And I really feel that we are missing somehow the salt that will make our dishes taste better. We are really missing React Native Skia. So React Native Skia is a package created to bring the Skia graphic library to React Native. It is sponsored by Shopify and created by William Candillo and Christian Falk, 2 wizards, really. William is also in the audience. That's just amazing. And you know, there is a lot of traction behind Skia. 90% of React Native devs are interested in it according to the State of React Native 2024. But there is quite a huge gap between the usage and the interest. And in my opinion, this is caused by the fact that it's still not so obvious why do we need React Native Skia. This is a question that I got asked a lot of times, and this was honestly something that I really didn't understand right away. And the way I understood why do we need React Native Skia was by observing this diagram. This is not really a diagram, just a circle with the React Native logo in it. But you can really try to envision in this circle the whole React Native ecosystem. So you can see the React Native core, reanimated, React Native gesture handler, all the Expo packages, React Native screens, React navigation, and so on, really whatever. And near to it, you can see Skia. And we can identify 3 different areas: what can be done with React Native, what can be done by using both React Native and React Native Skia, and what can be done by using only React Native Skia. And of course, the third area is the value that Skia is bringing to the React Native community. So to fully understand this value, it's worth to explore the limitations of React Native, try to see what can be done by using React Native without using Skia until we reach a limitation. And a pretty interesting use case are gradients. You can, of course, build gradients with React Native. You can use Expo linear gradient, React Native linear gradient, React Native SVG. But what about animated gradients? At some point, you are really going to need to use Skia, I believe. And that's just the tip of the iceberg. What about animated blurs on Android? What about shadows? Probably shadows have been solved by the new architecture, but what about animated shaders? You have to go with Skia at this point. And we are really starting to reveal the value behind Skia. And there is so much more than that. Mask and clips, shaders, shadows, blur mask, path effects, GUI effect, headless Skia, a lot. This is amazing, but can also feel a bit overwhelming. And luckily, there is a tutorial section in the Skia documentation, super recommended. You are going to find some tutorials created by Daheyun, Daniel, and William, of course. Really a ton of value right there, highly recommended. And once you're going to be comfortable with these KPIs, you're really going to see Skia everywhere. This feels like an empty slide, but the truth is that if you really look closely on the edges, you can see some gray dots. And I mean, there is somehow a spiral behind the radial gradient, so let's just remove. And the whole presentation background was created by using headless Skia, and it made so much sense for me to use Skia for this specific case, because I'm obsessed with spiral. I wanted to create a spiral, and creating this image with a high resolution can be very, very hard with Figma. And I also had the chance to create 1 million of different spirals. I had so much fun before choosing the one that I really like the most. And this is also a video created by combining Skia with Dreammotion. This is just amazing, in my opinion, and feels magical. And at this point, it's safe to say that somehow Skia brings the magic to React Native. So you might be in the audience thinking, well, I don't really care about an animated spiral. I'm not going to need an animated gradient. I'm not going to need an animated blur on Android. My app doesn't need all this magic. So you might think that you still don't need to use Skia. But the whole point that I want to raise is that Skia doesn't just bring the magic to React Native. It does way more than that. And a great example is the React Native Fast Confetti package created by Alireza Ajar, which, by the way, is also in the audience. So unbelievable that at the App.js I can just mention people and they are going to be in the audience, really. And this is an amazing package built on top of Skia. And you might think that, confettis are pretty simple components. We can build confettis by using animated views and by trying to apply a transformation on top of it. So potentially we can also build a confetti animation without using Skia. But the whole issue is that we are going to render a ton of React Native reanimated views all at once. We are going to block completely our JS thread, and we really don't want to do that. So the great advantage is that Skia completely solves this problem because we are not going to render, we are going to draw paths over a Skia Canva, and drawing is going to be way faster than rendering. And in addition to that, there is also the Atlas API, which will make things even faster. And I'm not saying that you need to mount the Canva everywhere. You need to find, of course, the right balance, because mounting the Canva can be expensive from a memory standpoint. So you want to find the right balance between mounting a Canva drawing paths versus rendering components. But just keep in mind that this can happen a lot of times. All of these examples, for instance, potentially can be built with the regular React Native, but they are just not going to work without using the Atlas API. Or now, I saw yesterday the talk from Christoph, amazing, about WebGPU, Type GPU. This is going to be the future, and you can, just keep in mind that it is worth to considering this kind of technology if you want to render a ton of components on your UIs. And that's really it. Today I tried to share on this talk so far all the tips, the most important tips that I collected over the past years. But if I had to wrap it up over one sentence, I would just say that great animations are built on delightful surprises. And here I'd like to recall a quote from a friend of mine who was always repeating and repeating that if you really want to surprise someone, you have to deliver a sense of déjà vu. Thank you so much. It has been amazing to be at the App.js. Super grateful to be here.
Thank you so much, Enzo. So now, Enzo, I'm going to hold you to this. Anytime I'm cooking pasta, I'm just going to chuck mayonnaise on there. And if it doesn't work, I'm going to find you on Twitter and let you know. Well, thank you so much. That was an amazing talk. And I really loved as well how he talked about how adding animations and adding sort of that flair can really increase and make the user's experience much better, much more colorful. And it's also nice to have one of my favorite Pixar movies incorporated into a talk. Well, we're going to stick with the subject of UX and DX and learn how we can do that through navigation with TanStack. I'm really excited for our next speaker. There are some people that walk onto a stage and they just bring so much energy to every interaction you have, whether you're just meeting them sitting down at a bar, or you're at a speaker's dinner, or you're on a stage, backstage. They always bring energy to every room they walk in. And our next speaker, Devlin, is one of those people, always with a big smile on his face, always making me feel like I am like I'm special. And hopefully, as he comes on, he's gonna make us all smile and laugh as he teaches us today. So, I know it's been a day and a half of content, of talks, but we have so much more to go through. So can we all give a 10 out of 10 applause to Devlin?
This is it. This is it. Can I just press this? Oh, no. So yes. So I have a little joke here. When do developers go broke? And then this is not cringe because this is about my topic, TanStack query. If they run out of cash, right? Okay, so my topic is about TanStack query in Expo apps. And just a quick intro about me. So I work in Norway as a full stack developer. It's a consultancy. So in the past, I used Xamarin using .NET, native script using Vue.js, Ionic using Angular, and then recently Tauri version 2. So these are my access. X tools, not access, sorry. But I think I'm settling down now because I've found what I'm looking for, and it's Expo. So, enough said, let's get to the point. This is not a data fetching library or an HTTP client library. This is a managing tool for asynchronous data. A proper term can be a server-state data management. TanStack query, formerly React query, became very popular not long time ago. It used to be just for React, but now it has modules for Svelte, Solid.js, Vue.js, and Angular. Let's get started. In Redux, there's single source of truth. We save states from users as synchronous actions, and we also save state from the data we get from HTTP requests, right? The spinner always show when user navigates back and forth for pages that requests data from an API. And this is me 4 years ago, working from home because of COVID. I was playing around React Query, the old name of TanStack Query. Then after a few days of playing around React Query, I started to understand that this tooling, the purpose is for server-state data management, while Redux and MobX are ideal for client-state management. So server-state is simply the data you get from HTTP requests or async functions. In Redux, the state you get from your side effects, it could be an error message or the response data you will get. So client state is your application state that comes from synchronous functions. An example of this would be user settings, dark theme, light theme, user profile from an auth token, etc. A cache can do so many things. Not this cache, by the way. So this cache, right, which I think is underrated in web and mobile front end. While caches can be implemented as physical hardware components like CPU caches, from a software perspective, caching is fundamental architectural pattern used to improve system performance and efficiency. Let's take a look at several benefits of TanStack query caching mechanism. So we have automatic caching and retries, optimistic updates. Let's skip. Stale while revalidate. No more spinners. I'm going to explain this later. Background refetching. What else? Offline support. Prefetching. Query invalidation. Query deduplication. Custom garbage collection time and stale time. Infinite queries and pagination. Well, I'm going to focus on this one. This is like a perfect combo. TanStack query ensures you're fetching data, smartly, not overfetching, caching properly, loading incrementally, and then virtualize lists like flash list, flat list, ensures you're rendering smartly, not rendering thousands of components at once. So even if you have 10,000 items total, TanStack query might only fetch 20 items at a time as needed. Flash list might only render 10 to 15 visible items at any moment. And then result, you have this fast, smooth, memory-efficient, infinite scrolling. So in this demo, I will do no best practice in setting up TanStack query configurations, just features of the tool itself for readability of the demo's code. OK, so First is, OK, so we have the code here. OK. Yes, thank you, thank you, thank you. OK, I have the app here. Let's try this app. So prefetching first. What's happening here is I'm prefetching some of the links here. If I click this, you see that there's already data waiting here because I already prefetched it. This fetching here that you're seeing right now, fetching the background, normally you don't do that, right? I'm just showing you that behind the scene, it's refetching, making the data fresh, and you don't see any spinners here or loader. The data is already ready for the users right from the get-go. OK, and you can see here we're caching it. This is a TanStack query dev tool through RN dev tools. I'm going to show you the link later, but let's go back to the code. So first is setup. It's just simple. Here's the setup. You create an instance of query client. You pass it to a query client provider, like so. And then you can set some default, stuff here, like retry. It's already built in. I'm setting up for 2. And then I have this exponential back-off retry delay. So for a little bit of resiliency. Now let's move to the page. So this is a hook that you'll be using. You have this query key. Just like in database, you have this ID, right? So the database can specifically pinpoint which one is saved and which one to query. You have the function. This is your side effects, your service. I'm just putting here infinity for stale time, when it's going to refetch again. I put it here no, because this is just for me, just it will not change in any time soon. And I have here another one, prefetch query, and then I'm passing this actually to the link, the navigation link, like so. And I'm just stating here, just quickly, less than 15, just prefetch it, right? So that's what's happening here. Nothing special. It's so easy to create this prefetch, and now you have this improved user experience. And then, when you clicked it, this here, this use query hook, this is a detail page, by the way. The job of this is to refetch the data in the background. And if there's no data there yet, it will just fetch it for you, right? OK, done for the prefetch. Let's move to the next. Next demo is deduping. And my demo here is, you can see posts. You have 3 here. Maybe it's better in the web here. I think it's better here, deduping. And I'm just showing here the Zubir. It's a Polish national animal, by the way. Just to set there's like, I got the data properly. So as you can see here, 3 users, 1 post. And this post is actually being used also by 3 components, fetching. But since you don't have to do anything, the library itself will do the deduping for you, meaning if the toolings saw multiple requests, it's just going to treat it as 1 and then share the data, right? It's very efficient, because if you're not going to do this, you get this multiple requests, as is this one using TanStack query is just 1. Let me show the code. Because here, OK. So this one is use dedupe query, and then the other one is just a simple fetch using actuals, right? But here, we're querying it. And then that's very useful, right? You don't want to, you want to avoid multiple unnecessary requests if you can. And that's easy now because of this tooling. OK, nothing special here. Just that small code that does it for you. Next would be polling. So I have polling here. Let's move to polling. Maybe let's change this to 3 seconds. OK. So TanStack query also has this built-in polling for you. So I'm just going to put my to-do here, vacuum the floor. So I'm making this to make sure that I'm not going to forget this stuff here. Otherwise, I'm dead in the apartment. So these are my jobs. We're just going to wait. I think it's here. Let's do it again. Vacuum. It's pending. I think I didn't save it earlier, but here it is right now. Yes. OK, so imagine it's just automatically adding there. But it's there, right? Yeah. Or maybe we can do it in the other one. It should work. Maybe this is a sign that I don't have to do vacuum, right? Maybe I can just wash the clothes. Yes. Yes, yes, so I don't have to vacuum. OK, so next feature here. There's so many, guys. I'm just showing you the top. OK, so next would be pagination here. So we can save the data. This is very efficient also when navigating using TanStack query. Code would be look like this. Oh, sorry. You can also see how I'm mutating it through here. And then for the pagination, I have this keep previous data, so we'll just like efficiently reuse it smartly. Stale time, after a minute, refetch. And then you'll see this bunch of Boolean. I'm using it for the UI, so I can navigate, right? Render empty state. So basically, yeah, you're using it for the UI itself. OK, that's what you can do with TanStack query if you have a pagination. And let's go to the infinite query here, which is really good. So this is bi-directional, by the way. You can just scroll here down to the bottom efficiently, and then scroll up again if you want to pick it up. Everything here, everything that you're trying to do is recorded in the dev tool, the duping, the prefetch. So this is very helpful if this is open all the time. So how do we do that? By using this get previous page param, get next page param, subscribe, refetch. So max page also, it's very important, limiting 3 pages for memory efficiency. If you look at the docs of TanStack query, it's straightforward. It's web. It's easier because you have this. The DOM is helping you. The browser API is helping you to have these events. But in for example, in flat list, you have to use the you scroll to index failed on end reach, so you have to do this also too, because the part here that it's kind of hard to perfect is that it won't jump to different views. So yeah, you just need to do some extra stuff here. And then reuse this fetch next page to the UI so you can supply that for the UI for the users to use. So infinite query, very, very useful. Again, the TanStack query is handling the refetching here, the data, so it's in the memory. And then, so it's smartly sending HTTP requests right on the right time. And then the flash list, which has a built-in virtualization, so that's the one that's doing the smart re-rendering efficiently. So I think I'm run out of time. So you also have this optimistic update. But since we're running out of time, we're going to move to the slides because I want to show some things here. So in real world, I have this tooling here. It's Hey API. In my scenario, this is just recently. I have hundreds of endpoints already made. And then each endpoint has multiple HTTP verbs that I'm using. So this Hey API dev has a plugin for TanStack query, Zod for validations, services, HTTP client library like Axios. And then it saves me, if you wouldn't believe, 8,000 lines of codes because I counted it. So it saved me 8,000 lines of code because it wrote the boilerplate for me, the hooks, everything. I didn't write any hooks, like manually. The generator did it for me. All the hooks, the types, the interfaces, the services using Axios, the validations using Zod, 8,000 lines of codes. And it saves my customer a ton of money, right? Because it's a weeks of work. So key takeaways, TanStack query is not a data fetching library. Client state, for example, for client state, Redux, MobX, Jota, Sustand, etc. are good, but inefficient in storing asynchronous data. Server state, responsible for managing asynchronous operations between your server and client. Cache is very powerful. Use infinite query for highly performant infinite scrolling. And then resources, everything is here. You can take a picture, go straight to the well-written docs. I put here also Redux toolkit query. So RTK query has similar concepts. Both handles data fetching, caching, and synchronization. Both uses hooks-based API for React components. Also supports automatic refetching, cache invalidation, and loading state. And yeah, here it is, even the code itself here in my demo. Dziękuję. Peace out.
Thank you so much, Devlin. Really good. Awesome. All right, folks, we are about to have a break. Remember, you can stick around. We're going to have a live studio sessions with the folks from 11 Labs. So stick around over here in front. And if you are online, you get an extra treat. So after the live studio from 11 Labs, we are actually going to have a talk that's available virtually for those of you watching the stream, where you can listen to the 11 Labs presentation from a couple days ago. All right, sit back, grab your coffee, and I'll see you all, folks, in a moment.
Hello everyone, I hope you're having a great day, great conference, great talks. And this is another break, and here with us is Thor Schaff, working at 11 Labs. And well, the first question I have to Thor is, what do you do at 11 Labs? I've heard that you've worked on the developer experience, so please share some more what you do there in your company.
Yeah, thanks so much for having me. Hello, everyone. I'm Thor. Yes, I work on developer experience. So broadly, that encompasses kind of a bunch of different things. So starting, at the SDKs, the client libraries, we do JavaScript and Python SDKs at the moment. We're working on the React Native and the mobile SDKs as well. So really making sure developers have a great experience, building their products, no matter kind of how they are building the products. But then also, kind of the content side of things. So that's documentation, tutorials, integration guides, video content, and then also the community building side of things. So, conferences like this awesome conference here, events, meetups, but then also, building demo apps. So as part of like tutorials, we built some demo apps, and I actually brought a little app. If you've been at the meetup, you might have seen it already, but maybe, so this is integrating our conversational AI agent. So maybe we can have just kind of a little greeting here.
Hi there, whoa, so cool that I'm running on iOS. What can I help you with?
Hey, I'm here in Krakow in Poland at the App.js conference. Can you maybe do a greeting to all the people, but in Polish, please?
Cześć wszystkim na konferencji App.js w Krakowie. Jak się macie? Czy mogę w czymś pomóc?
All right, that's great, but I actually don't speak any Polish. What other languages can you speak?
I can communicate in English, German, and Polish. If you need help in any of these languages, feel free to ask. Is there anything else I can assist you with?
Ja, vielleicht können wir auch ein bisschen Deutsch sprechen. Ich komme ursprünglich aus Deutschland.
Das ist großartig. Wie kann ich Ihnen heute weiterhelfen?
All right.
So yeah, we're not needed anymore. Apparently, Thor can do the interview with himself, as you can see, and a great demo app. Yeah. So what was that? Can you tell us more about the app?
Yeah, so this was one of the Expo React Native demo apps that I've built. I've created this tutorial for people to kind of build cross-platform conversational AI agents. So this works across web, iOS, Android, and it's using the Expo DOM components here in this scenario. And it is a really cool way, actually, with the Expo DOM components, how you can, basically from a web context, so in the DOM component, it's using our React SDK, which is using WebSockets, kind of, web technology in there. But then it can actually tap into kind of native SDKs, like Expo Brightness, to like dim the screen for you, for example. So it can actually reach out from the web context, using DOM components and kind of the top level props to then actually tap into the native SDK, kind of functionality. And so that is kind of a tutorial, basically to help folks build this into kind of their own applications. Yeah.
Great. That was such a wonderful demo app. But do you know any production use cases that are already used with your technology?
Yeah, there's a lot of different use cases. Actually, one of my favorite ones that came out recently, so we worked with Epic Games to put a conversational Darth Vader into the Fortnite game. So I personally am not a big gamer. I focus on ocean canoeing, but if people, play Fortnite, they can chat to Darth Vader. So Epic Games has exclusively kind of licensed this Darth Vader voice clone that we've made for them. And they can then in real time talk to Darth Vader within the Fortnite game, which is pretty cool.
Oh yeah, that proves that it's the real low latency, right?
Yes, yeah. So the conversational AI platform is specifically designed kind of, with low latency in mind. So you can bring your own LLM, but we sort of natively integrate kind of all the major large language models as kind of the brain for your conversational agent. And then we can optimize kind of all the streaming, throughout. So basically, as soon as the LLM comes back with kind of the first byte streaming the text, we can then input stream that into our Flash multilingual model here. And then, the agent can converse in actually at the moment 30 plus different languages. But then we're actually working on the next version of our multilingual model. So that's version 3, which is coming out very, very soon, which will actually be available for, I believe, 99 different languages. And so we're just consistently working on improving, the quality, not just, in English. Like nowadays it's easy enough to, kind of produce a model that kind of speaks English pretty well. But yeah, we're really dedicated. So if you look back at, Matti and Piotr's mission with 11 Labs to make all the content available in any language and in any voice. And that is really kind of where we're spending our time, both on the research side of things and, then deploying that to the broader audience. Yeah.
Yeah, the any voice part is also interesting because actually you can talk to yourself via 11 Labs, right? Because there is your voice available in one of your models, right?
Yes, correct. So that is kind of where 11 Labs originally came from, sort of the voice cloning technology, and we actually built this kind of with the community in mind. So we actually have this large library of voices. And so if you create a professional voice clone, you can actually publish that to our voice library. And then you can earn royalties anytime someone uses, your voice. And so if want to use my voice, for your product announcements, for your conversational AI agents, actually my voice clone speaks better German now than I do, which is funny. I haven't lived in Germany in a while, but this is really cool. So because basically you clone your voice, and then the multilingual models that are pre-trained in all these different voices, they can overlay, kind of the characteristics of your voice clone and then speak all these different languages, which is really cool. And so, yeah, if you go to the voice library and you search for German engineer, you can find me in there, and you can use the voice. And actually, we just, so this feature is built with Stripe Connect, so the marketplace payments feature. And we just recently hit the $5 million US payouts mark that we paid out for, voice artists that published their voices on the library, which is really cool.
Wow. That's large numbers right here. Like 5,000 human voices is a big library. But how much data do I have to provide to create a clone of my own voice if I want to talk to myself?
Yeah, there is different levels to it in terms of, so there is kind of what we call the instant voice cloning. So that is something you can actually get done with just 30 seconds of your voice. And that, basically gets you pretty close already to sort of sounding like you. But then if you want to get really, really close in terms of, all the characteristics of your voice, including your accent, your sort of pacing, your pitch, your range, there's a lot of characteristics that are encoded within your voice. And so we then have this professional voice cloning, where you need at least 30 minutes, ideally, 1 to 2 hours of high quality recording of your own voice, including kind of your accent characteristics and all that. And then what we do is we fine tune the model on, your specific voice, which then really, keeps the accent characteristics and all that intact. And so there's various different levels, kind of depending on how close you want it to be.
So do you develop some other tools related to AI that you would like to share with us?
Yeah. So broadly, 11 Labs. We started out with kind of the voice models specifically, but now broadly we're focusing on AI audio. And so that includes, automatic speech recognition. So earlier this year, we launched the Scribe model, which is kind of one, the market-leading, benchmark-leading models in terms of transcription accuracy across 99 different languages. And so there's actually both a Telegram app as well as a Line app if you're in Japan. So it was funny, I went recently to Japan to do a meetup there, and I proudly showed them my Telegram bot, and they were like, yeah, we don't use Telegram in Japan, we use Line. So Line is kind of the messaging app in Japan, and so I was like, oh, okay, now I need to also make this available for Line. So actually what I did is I took my Telegram bot transcription tutorial and I put that into ChatGPT and was like, okay, give me this tutorial, but for Line and Cloudflare workers, right? And it basically one-shot at the tutorial, and then I just copy and pasted the code. And so the most difficult part actually was registering my Line developer account, because they don't have that interface in English. So I went through it in Mandarin. So they have it in like Japanese and Mandarin. And I was basically there with my phone, like translating the form and typing it in. But like the actual building, the bot part was like the easy part. Like the filling out the form was the difficult part. And so you can actually use this for free, and you can forward, audio messages, videos. I actually met someone at the conference earlier who just took a video of like a little bit of the conference talk and sent it to the Telegram bot, and then he got like the perfect transcription for it. So that is kind of the other side, so the speech to text side of things, text to speech. Then we also do sound effects. You might have seen it at the meetup. We had early last month, the April Fools. We had the text to bark, which people really enjoyed. They were like, oh, nice, I can now build apps for dogs, right? And communicate with dogs. We're not quite there yet, but all the barking that you heard kind of in this April Fools was generated by our sound effects model. And so this is another one where, for videos, for game developers, this is really useful. We actually built a soundboard. So if you Google 11 Labs sound effects soundboard, it's basically like a drum machine, but you can like store your own sound effects into the soundboard and then play it like through the keyboard, and that was a pretty cool feature as well. And so yeah, we're the research. So we built our own models, we train our own models. Then deployment, we deploy these models, and then my team focuses on, okay, now that we have these models deployed and usable through APIs, how can we inspire people to build cool applications with that?
So actually, I have a question, because I wonder if you personally, because you travel a lot, right? You live in Singapore, you visit Taiwan and other countries. Have you already had a chance to use your apps, your API to talk to people that don't speak, for example, English?
Yeah, so I do use it actually like sometimes to dub my videos into like German, into Mandarin, just kind of to make it available for other audiences. So that is kind of one part where I use this. In terms of like live dubbing, so that, we're not quite there yet. But yeah, some people are kind of exploring that internally within the company. The big challenge with kind of the live translation is just the translation piece. Because this as well, right? Like different languages have the context at different parts of the sentence. So like in German, like you might actually not know what the context is until like the sentence is finished. And so you always have kind of some delay in terms of actually encapsulating the context in that. So I think we're not quite there yet, but like, I think we're pretty close to like live dubbing. It's pretty wild what's happened in the last year. So give it another couple months, right? And who knows? Yeah.
Do you have any cool demos in mind that you are already creating right now, or?
Yeah, so there's a lot. So there's a couple of cool things I want to do with like gadgets. So like I've bought a Raspberry Pi and I've carried it around in my backpack for the last couple of weeks, and there were a lot of events kind of going on in the last couple of weeks, and so I haven't gotten around to like finishing the demo. But you know, actually, like one idea is, and I was in San Francisco recently for Stripe sessions, and there were, you know, like Peter Levels and kind of a bunch of the sort of AI indie hacker crowd was there, and we were talking about how like Siri is actually not that great, right? And so they were like, I want my own Siri, but like just put in like my Claude, you know, API key, and so I was like thinking, okay, maybe I can like just use my Raspberry Pi to build like my own Siri, you know, powered by like 11 Labs and, you know, Claude, for example, or, you know, what have you. And so, yeah, that's kind of one thing I'm working on. And then also, yeah, just conversational AI. I think there's a lot of cool demos that are meant to be built. So yes, I think it's just a matter of time.
Yeah, well, we think that the future is pretty bright, especially when it comes to AI. So, well, if you'd like to learn something more about 11 Labs, what's being cooked there, has had a talk at React Native Community Krakow last Tuesday, as far as I remember, and you'll have chance to see it right after this live studio. So I really recommend you to have a look, to listen, and well, to talk to Tor at the stand, because he's at the conference with us, so you can talk to him in any language apparently, and see if he understands. Yeah, so thanks so much for the conversation.
Thank you, Dzięki. Still working on my Polish.
Great. Dankeschön. Thank you.
Bitteschön.
'Discover AnimateReactNative.com, your go-to platform for premium, customizable, and ready-to-use React Native animations. There are over 120 different animations that are going to save you time, enhance your app, and, in my opinion, is the perfect collection if you'd like to learn more about React Native animations. Get 60% off by using App.js Conf. Visit AnimateReactNative.com.
Eleven Labs conversational AI is evolving. We've been optimizing some brand new features to create the most sophisticated voice agents in the world. First up, we've developed a state-of-the-art turn-taking model to help agents perfectly understand when to interrupt.
Thank you. And what's your order number, please?
Oh, let me just double check. 947835.
Perfect. Your delivery is on its way.
And secondly, we've integrated language detection for seamless multilingual discussions.
Hi, welcome to our design studio.
すみません。日本語で話してもいいですか？
もちろんです。日本語に切り替えましょう。
And we've built the world's first integrated RAG for voice agents to retrieve from your knowledge base at minimum latency with maximum privacy.
Your next patient is Mr. Frank Reynolds with ataxia.
Oh, it's been a while since I've worked with ataxia. Could you remind me of the guidelines, please?
Sure, I analyzed all the best practices and found this.
And lastly, why limit your creativity when you can switch between multiple characters in a single agent?
Okay, guys, let's head east towards downtown.
I'm not sure about that, boss. Hey, don't be scared, man. Let's just go.
This is just the start of a new era of communication and understanding. All with full HIPAA compliance, third-party integration, enterprise-grade security, optional EU data residency, and industry-leading reliability across all agents. The potential of conversational AI has never been greater. The time to build is now.
Good code is good, we don't touch that. But for everything else, there's Sentry. Whether you're a mobile, backend, front-end, or any end developer, we'll show you the environment, device, OS, even the commit that introduced an error, down to the broken line of code. Yet the woes of a developer go far beyond when code is broken, it's also when code is slow. Detect endpoints, slow spans, and operations consuming the most time across your stack and keep everyone feeling not bad.
Cześć, Kraków. All right. I hope that was correct. I asked someone. For the non-Polish people, that means hello, Krakow. Yeah, hello everyone. Unfortunately, that's where my Polish ends. Even though I'm German, so pretty close by. I've never learned Polish, unfortunately. But now I have my voice clone, and my voice clone actually speaks Polish pretty well. So we can hear that later. Yes. So this is me. I work on developer experience at 11 Labs. I kind of split my time between Singapore and Taiwan. I've been in Singapore for the last 6 years now. I kind of originally came out there with Stripe back in the day, and then for the last 4 years, I've been building Superbase, which actually started out in Singapore during COVID. I don't know if people knew that. And then 3.5 months ago, I joined 11 Labs. Have people heard of 11 Labs? Yes? Okay, it's great. It's like a home match, right? Mati and Piotr are from Poland originally. And, you know, this is kind of where the 11 Labs story started. I am one of 2 GitHub stars in Singapore, which gives you an idea just how small the country is. And then I do run kind of a passion project called Hacker House Taiwan, where I bring people, kind of, you know, software engineers from all around the world together to, you know, work from Taiwan for like a week and kind of experience, you know, the local developer community there and the food. I mainly do it because the food is amazing. Yeah, that's me. And if you want to influence that number, you're very welcome to. We're very close to 10K here, so once we hit that, we'll start the talk. I did that once before, and I refreshed, and the number went down. Okay, didn't go down, so that's good. All right. Now, 11 Labs, you know, a lot of you have heard about it already. Now, you know, we kind of started out generating speech. That was sort of, you know, where it started. But then, you know, there isn't just human language here. There's also a lot of dogs, right? And so this is the most recent model we launched. Did people see this? Text to bark? No? Okay, great. Good thing I'm talking about it. So, you know, this is probably the easiest way for you to add 900 million new users to your apps. I looked this up. This is the amount of dogs that are estimated to be there in the world. So now, you know, if you want to communicate with your dog, this is perfect for you. So you can choose kind of the dachshund. There we go. Apparently, a bunch of German fans here. As a German, I'm a fan of the dachshund as well. The golden retriever, also good boy. Yes, who's the best puppy in the world? Yeah, he's a bit, you know, lower. Chihuahua, tiny but mighty. Now, so, okay, yeah, all good? All right, so we launched this model early last month. And the timing was a bit unfortunate because we launched it on the 1st of April. And people thought it was an April Fool's. Which was unfortunate timing. But as you can see, it's very much real. No, so it actually was an April Fool's. However, you know, so if you play this to your dog, you know, be aware that they might be very offended. So the actual context, the semantic doesn't translate. But what you're hearing here is generated by 11 Labs. And so we do have, you know, a model that's actually text to sound effects. And so that's what you're hearing here. So using a text prompt, you can generate sound effects like, you know, for example here, a dog barking in the park. So this is kind of the basis of this April Fool's. And then what we do is the model generates kind of 4 different sound effects. And then you can see sort of, you know, what is the one that suits you best. That one was a bit mute. And so as you can see, kind of, 11 Labs, yes, we're coming sort of from the speech side of things, voice cloning. You can also use text prompts to generate voice. But, generally we're building kind of the platform for AI audio. So there's a lot of different things in there. The last actual real model that we launched was this one, speech to text. So kind of the ASR model, automatic speech recognition, across 99 languages, kind of, high accuracy, including speaker diarization and, word level timestamps. So given kind of speech.
Quick check-in. Maple Street is a mess. Time to fix it.
Totally.
You basically get, the model can identify what language is being spoken. So that's kind of the automatic speech recognition part. It can identify different speakers. So that's kind of the speaker diarization. And then you can see as we're playing kind of the audio here, you see the words highlighted. So that's kind of the word level timestamps. And so this works across, different languages. And then I personally work on kind of the, developer platform, the developer experience. So obviously you can use this through the API as well. And so that's where I've built a little Telegram bot, which is pretty cool. So this Telegram bot, if you want to try this out, you can you can scan this QR code. And so basically this just uses Superbase Edge functions, to set up kind of a webhook for the Telegram bot. Do people use Telegram? Okay, that's good. I recently did this in Japan and no one in Japan uses Telegram. So then I had to build it for Line, which is kind of what they use in Japan. But so what you can do is you can forward, voice messages, video messages, to this bot, and you get kind of the transcription back, no matter what language that is. And apparently I'm getting a lot of messages here. Now, the great thing with this is, for example, you're sitting in a meeting with your boss and your grandmother sends you a voice message, right? And you're like, I can't listen to it now. You can just forward it to the transcription bot and you'll see, what she's talking about and if there's any sort of, emergency. So what we can do is, for example, I live in Singapore. So if you've been to Singapore, you might have heard something like this.
What the hell, this person bastard, You asked for.
All right, we might have some trouble here with the Wi-Fi. No, I think we're good. Oh no, service workers. Okay, we're updating. Let's see. All right, we might have some technical difficulties here, but basically once you have your video, you can forward it to your transcription bot, and then the transcription bot will go to work. And so you see, we received it, basically forwarded it to the API. And so now hopefully we get a message back. Come on, don't leave me hanging. All right, so it seems like Telegram just decided to have some issues while we're doing. Okay, so on the phone it actually updated. Let's see. There we go. Okay, go to hell, this person. I asked for a plastic bag. You must put the thing inside the plastic bag for me. So these are the kind of problems we're having in Singapore. Now, obviously, this also works for Polish. So, for example, I found, do people know taco way? There you go. Apparently, this, Polish rapper.
W latach 90. nie miałaś tożsamości. Zachód pędził do przodu. Zachód nie miał litości. Trzeba się było wspomóc.
And so you can see, I just forwarded, I just uploaded this video here. And I mean, obviously I don't read Polish, but I think it's kind of about like the 90s and, things. Yeah, I looked up the translation earlier. So very good. very localized here. But yeah, as you can see, I didn't specify that this was kind of Polish language, right? So it automatically kind of recognized that, which is really, really cool. So, you know, if you kind of want to see how you can build this transcription, you know, Telegram bot, you can find that in the documentation. Actually, Simon Grimm just released this React Native tutorial as well that is using the same model. So that's using the Scribe API to build kind of a, you know, captions editor. Which is really, really cool. So if you're interested to know kind of how you can use this with React Native, check out Simon's post there. Okay, so now we have, you know, the speech to text, which is kind of one component of building our conversational AI agents. So if we look at sort of how, you know, our agents work and how they sort of get conversational, we have this, you know, piece that we kind of looked at just now, the speech to text. So we're transcribing the speech, you know, across many different languages to text. We can then plug in any large language model out there. So in the platform, we support kind of all the, you know, Gemini, GPT-4o, kind of all the most recent models. And we also allow you to, you know, if you're fine-tuning your own models and deploying them, you can also input a custom LLM. So the large language model kind of acts as sort of the brain and the personality for your agent. And it will then generate kind of the response, you know, based on sort of your system prompt and the personality that you've given that agent. You can also, you know, have kind of the function calling, the tool calling in there. There's monitoring built into the platform as well. And then the LLM will stream back kind of a text response, and then we'll use our multilingual text-to-speech models to generate, you know, the output. And basically, we've optimized this kind of for low latency to really make that kind of snappy conversational. So that is sort of the conversational AI platform that we can use here together with Expo, which is really cool. So the other part, you know, obviously the speech, so we have the speech to text, and then we'll also need the text to speech part. And so this is where 11 Labs voice library comes in really, really handy. So we have more than 5,000 different voices available in the voice library. And so you can see here, we want to explore different voices. And so if, you know, after this talk, you're like, oh, I really love this voice, you know, that I was hearing here, you know, fear not, there's a lot more of it. So you can just go to the voice library, you can type in German engineer, and you will find yours truly. True success is doing what you are born to do and doing it well. There we go. Does that sound like me? I hope so. So that is my voice clone. The cool thing is that, you know, I just cut in some of my YouTube videos and basically trained the model on my voice. But anytime you use that voice, I get royalty payouts. So on this platform, you can clone your voice, you can publish it to the voice library for others to use. And then anytime they use your voice, you get royalty payouts. And so that's mainly why, you know, I tell you this. So, you know, next time you're using 11 Labs, and I'll send you some coupon codes that you can use. Just find the German engineer, put some food on my table. There we go. So, you know, this is kind of the other part, but, you know, obviously you can also, you know, filter here in the library for the different voices. So you can say, filter, we can choose a language. So for example, you know, we're here in Poland, so Polish. Looks like there's a couple different accents that we can put in as well. So we can apply the filters, and then we can find, you know, some Polish languages here, that Polish voices that are available. So maybe we can look, this one, Daniel.
To nie jest zwykły dzień. To początek czegoś nowego. Czegoś, co zmieni sposób.
Does that sound Polish? Okay, that's good. It sounds Polish to me, but then again, I wouldn't really know. But so now we can put this all together into our conversational AI agent. And so here in the agent side of things, so I created this Expo React Native DOM components agent because we want to build this kind of cross-platform on the web, on the native mobile. And you can see here, I set the default language to English, but then I can also configure additional languages. And so we're in Poland, so I select Polish. We can then have kind of our first message here. And the cool thing is, so here we can, inject kind of a variable into our message. And so that is the platform. So we want, the agent to say, hi there, whoa, so cool that I'm running on web, iOS, Android, what have you. How can I help you? And then you can see kind of, the system prompt that is sort of instructing the large language model, how to respond kind of in the, to the questions. Here we're using GPT-4o. We can also switch, Gemini, Claude, our custom LLM, as I mentioned earlier. And then here is what comes in really handy. So the tools. So there's a couple system tools. So for example, we can have a language detection system tool to allow the agent to automatically detect and switch between different languages. We can also have kind of client tools. So as you can see here, later we'll have, some client tools where we can get the battery level, we can flash a screen, we can change the brightness. So fingers crossed that the demo works later. It gave me a bit of stress early on. Okay, I'll close this one. Someone found my Telegram username and maybe sending me some messages. Okay, cool. So now that we all have this set up, so the part here that is cool with the Expo DOM components, so if you're not familiar, you can kind of specify use DOM and then use this Expo DOM component, which in the background will kind of render a React Native web view, but just, more easily. And so we can, within that React Native web view, because it is a web view, we can actually use the Navigator media devices get user media, which is a web API, to access the microphone on the phone as well as on the web platform. And then here we have our DOM component. And so what we can do is we can pass functions as high-level props to the DOM component, which then allows the DOM component, which is actually running in a web context, to get access to native functionality, right? So things like changing the brightness, here we're passing that in as a tool. So here we can look at our tools. So our tool is actually using, these Expo native APIs. And by passing them in kind of as, these high-level props to our DOM component, we can actually switch kind of between the web context and sort of reach out into the native context, which is really cool here. And so now, if our demo gods allow, we will try this out. Okay. Actually, let's try it on the web first. Ease in a little bit. All right.
Hi there. Whoa, so cool that I'm running on web. What can I help you with?
Can you tell me what is my device's battery level?
Your device's battery level is at 97%. Is there anything else you would like to know or need help with?
So as you can see here, we also injected the platform, right, as a variable in our initial message. So you can see here in our app where we put this in, you see that we just hand in the platform variable as a top-level top-level prop, platform.os, and that way it can actually guess, the platform. Okay, now let's try this on, let's see, fingers crossed. Okay, so you can see here now we allow access to the microphone.
Hi there, whoa, so cool that I'm running on iOS. What can I help you with?
Can you tell me my device's battery level, please?
Your device's battery level is currently at 100%. Is there anything else you'd like to know or need help with?
Yeah, could you dim my phone screen to the lowest brightness, please?
I've set your phone screen to the lowest brightness. Is there anything else I can assist you with?
Yeah, could you maybe flash my screen?
I flashed your screen for you. Is there anything else you would like help with?
Yeah, could you set my screen brightness back to 100% and then actually reply back in Polish, please?
Ustawiłem jasność ekranu na maksymalną wartość. Czy mogę pomóc w czymś jeszcze?
Awesome. Well, you deserve that applause. I'm very, very sorry that I messed up. The QuickTime player messed, well, up. The flashing of the screen you actually can't see in the QuickTime player anyway. But what you can see is that it replies back, so it gives us the transcript. And so here, I hope this is proper Polish. Judging by the applause, it actually did work. So yeah, and I think that is pretty much it. I'm very, very happy that this demo worked. If you want to learn how to build this, there is a tutorial as well with a video. There's a blog post as well about this on the Expo blog. So yeah, would love for you to try this out. I'll have the demo as well at our demo booth if you're joining for App.js Conf. And yeah, that's all from me. Dzięki.
Hello, hello, hello. Welcome back, everybody. How we doing? This is amazing energy. I love each and every one of you who just clapped, and those who didn't, well, you can learn from that. And if you do want my approval and love, you know how to get it now. So don't be shy. I hope you don't mind. I'm finishing my coffee break over here. Thanks, Amazon, for the coffee. If you haven't had the upstairs coffee yet, I have nothing bad to say about the downstairs coffee. Downstairs coffee is fine, but the upstairs coffee is extraordinary. So go enjoy that. I'm just going to speak for 30 seconds just to wait for people to stream in for the streaming talk, so to speak. And yeah, I think that's pretty much all I had to say. So we're going to have, in a minute, we're going to have Miłosz Filimowski joining us, telling us about Fish Jam, which is a way of adding WebRTC streaming into your React Native app. And this is personally a very interesting talk for me because I have previously failed to ship WebRTC in a production application. So I will hopefully learn something that would have saved my ass 5 years ago. But, well, it's too late now. Anyhow, without further ado, give it up for Miłosz Filimowski.
Hi, everyone. I'm Miłosz, and I'll be talking about live streaming. But before we begin, let me run a quick poll, just for research purposes. Please raise your hands if you've heard about WebRTC before. Wow, that's quite a lot of you. Now, please raise your hand if you know what SFU, or Selective Forwarding Unit, is. Oh, you're going to learn that today. And the last poll. Please raise your hand if you think you've used any software that uses WebRTC on the hood in the past week. Wow, you're quite well educated. But to anyone who didn't raise their hand, I'm going to run this poll again at the end of this talk, and I hope all of you will raise your hands. So why do I think most of you should have raised your hands, at least to the last question? Because I'm sure most of you are users of the apps on the screen. And what do these softwares have in common? They never work when you need them. But apart from this, they have another thing in common. You've probably guessed, it's WebRTC. So what is it exactly? It's a set of standards and APIs that allow you for real-time communication. At least that's what Wikipedia says. However, since the title of this talk claims zero WebRTC knowledge, let me start with a quick story. After I joined FishJam, I tried explaining WebRTC to a friend of mine, Marcin. We've known each other since high school, and he, just like probably most of you, is also a mobile developer. So after I showed him the first draft of this presentation, he started asking questions. And nobody expects the Spanish Inquisition. And more importantly, Marcin is the most inquisitive person I know. So the main takeaway I remember from his interrogation was, OK, but you are talking about video conferences. Isn't your talk about live streaming? And that was a great point. Because turns out WebRTC is perfect when you need very low latency. For example, with YouTube or Twitch, which use HLS under the hood, the average latency is around 30 seconds. You can try to go a bit faster with low latency HLS, but it's still around 5 seconds at best. So let's say you are watching a football game, and your national team is playing today. You are watching the stream on your computer, and just as the players are lining up for the penalty kick, you can hear your neighbor cheering a few seconds before you. Not cool, right? Or maybe you are taking part in a live action. You place your bets and hope to win that rare piece of art. And you are always 5 seconds behind your opponent, who is there in person. That would be difficult to win. With WebRTC, we can go even as low as 100 milliseconds, which is more than 10 times faster than light reaching us from the moon. Yeah, which is 1.3 seconds, by the way. So how is that all possible? The key is the direct peer-to-peer communication, which allows us to achieve the latency. But the world, unfortunately, is not a perfect place. Everything comes at a price. So let's see what you need to establish that connection. Imagine you want to send a postcard to a friend. Before you do it, you need some basic information, such as who is it for, where they live, what kind of card format can fit their mailbox. In WebRTC, this part is called signaling. OK, once we know who and where we are sending the postcard to, we need to figure out how to get it there. Because each address might have a different type of entrance. It can be a front gate, a back alley, or a tunnel through your grandma's house. In WebRTC, these are called ICE candidates. In that step, we are basically saying, try delivering the card to any of these entrances, see which one works. OK, now that we know who and how to reach, we can try delivering the card. But at the door, you notice your friend lives in a dormitory, and you only have a building number, which means they live behind a net. We don't know which room to go to. So you show up at the front desk and ask where you can find them. And I could go on with this analogy for turn servers, when we need to relay our card through the front desk, or explain what SDP offer is and what it contains. But it was too much for Marcin, and probably is for you as well. So why am I telling you all this? To prove a point that WebRTC, while great, can be complex and difficult to implement. And that's why we created FishJam. Thank you. But a cloud service, just for handling a peer-to-peer connection, sounds like an overkill, right? So let's go back one last time to my threading analogy. I promise. At the beginning, I only mentioned we would be sending a single postcard. But what if you have more than one friend, like 10? That would be horrible, right? Fortunately, people have solved that issue in the past. You can just drop all of your 10 or even 10,000 cards at the post office, and all of your cards will be delivered for you. This is what we call an SFU, or Selective Forwarding Unit. FishJam is figuring out who, where, and how to reach, then takes care of all the heavy lifting. But is it really that easy to implement? Let's see how to add FishJam to a React Native app. First, let's import and use the use livestream hook. You can use our dedicated livestream view to display the stream. Of course, you can style it to whatever you like. Run connect. We've also prepared a sandbox backend environment to allow you to start as quickly as possible, so you can test how it works without doing anything else up front to see your live stream in your mobile app. And when you are done playing, you can customize the flow however you like. Just remember, not to hard code the live stream URL like I did in the App.js app, or the AGI will bust you live on stage. OK, the demo part. At the beginning, we wanted to demonstrate the low latency by asking you to open the App.js app and see the low latency for yourselves. But unfortunately, the venue's Wi-Fi won't handle so much traffic, as you probably noticed already. So I have a short pre-recorded demo for you instead. So in here, we are streaming on the device on the right. We have 3 receivers, 2 mobile, and a desktop. This is, of course, streamed over the internet, not on localhost. The server is somewhere in Germany or whatever. And hopefully, you can see the minimal latency. Woohoo! So fast. Thank you. But you don't have to take my word for it. If you'd like to test the latency for yourself, you can check it out in the App.js app, where we stream the conference. It's the red button in the bottom right corner. And like I said, just please don't use the venue's Wi-Fi, as it won't handle so much traffic at the same time. So to recap, we talked about how WebRTC is already everywhere, from Google Meets to Zoom, Discord, and Microsoft Teams. You now know that it's great for low latency, but comes at a cost of complexity. You should also, at least kind of, know what SFU is, or selective forwarding unit, and how FishJam can help you deliver streams at scale. And like I promised, let's try to do the poll we started with. Please raise your hand if you've heard about WebRTC. Thank you. Please raise your hand if you kind of know what SFU, or selective forwarding unit, is. Thank you. And please raise both of your hands if you think you've used any software that uses WebRTC under the hood in the past week. Thank you very much, and happy streaming.
All right. I wish I was born later, but I was not. But you get to use FishJam when I didn't have available, so life ain't fair, I guess. Anyway, if you did find this talk interesting, if you're already working with WebRTC, or you just found this so curious that you wanted to learn more, Software Management also running the RTC On conference, so please do check that out. It's a whole conference dedicated into live streaming and video streaming and all other WebRTC technologies. So please do check it out. Now, we're going to shift gears, and we're going to talk something I think that we all have in common, which is that we need to build secure apps. How do we feel about building secure apps? Are we excited about building secure apps? Yeah, you're lying. You are lying. None of you are excited about building secure apps, but yet it's a thing that we all are tasked to do, and we are professionals, and we do the things whether or not we want to do it. And our next speaker is an expert in this topic, is building tools to make it easier for all of us to do so. So without further ado, let's give it up for Jacob Arvidsson.
Hello. How's everyone doing? Great, yeah. Cool. My name is Jacob, and I work at a company called Chase, or Chase International, and I'm a React Native engineer. We launched our bank about 3.5 years ago in the UK, and one of the things we think a lot about at work is, of course, mobile application security. So during this talk, we're going to talk a bit about what is app security. We're going to also look at how to build a secure app in React Native, and maybe why Expo and Greenfield apps are not the best choice to use when thinking about security, and why native apps and maybe Brownfield apps are a bit better. And then at the end, we're going to kind of ignore what I've said in the second part, and then we're going to do all of this using Expo. First, I just want to talk a bit about kind of why we would do Expo versus native. So Expo, of course, is super easy to maintain and scale when it comes to your project. With Expo, you're writing code once, and you can deploy it to all your platforms. It also has something called continuous native generation, which means that you're not even maintaining the projects, your native projects. These are automatically generated every time you do a build. On the other side of this diagram, we have native apps. So obviously, native apps is more complex and more difficult to maintain, because you literally have to build them each for each platform. And somewhere in the middle, you have Brownfield apps. So Brownfield apps are basically native apps that, at some point of the app lifecycle, initializes some React Native journeys. Some people think that's like the best of the both worlds. For me, who spend most of my days working on Brownfield apps, I think it has a lot of the good things from React Native, but kind of with the maintenance of a native app. So when you're looking at this graph here, it's quite easy to think, OK, we're going to go with an Expo app. But when it comes to app security, it's actually a bit reversed. So in JavaScript-based applications, security is actually a lot weaker. And with native ones, we have a lot more security features. So let's look a bit more at that. I'm going to focus on a few different points. The first one is code exposure. So in React Native, we're writing our apps in JavaScript. And JavaScript is easier to reverse engineer. So this means that our JavaScript code is easier for attackers to kind of inspect and tamper with. We're also packaging our JavaScript code inside of the app, which means that we're also more susceptible to things like code injection and tampering and debugging. While on native, our code gets compiled down into binary code. So that's our APK files, our IPA files. And for this reason, well, native code or binary code is much, much more difficult to reverse engineer. And so it's much better for intellectual property protection and logics obfuscation. Another thing is our runtime environment. So obviously, when we're writing things in JavaScript, this is it runs on the JavaScript virtual machine. So we're adding a layer of abstraction where additional vulnerabilities can be introduced. We're also opening up ourselves to more things like runtime injections because we've added this additional layer. And on native, we're operating directly on the native runtime. So obviously, we don't have those risks that are introduced by our additional layers of abstractions. Thirdly, we have our platform-specific security features. So obviously, with React Native, we don't have access to all of the platform-specific security features that we do on native, or at least not by default. So we often have to use third-party libraries or write our own native modules. And even if we're using third-party libraries, we might not have that granular control over those security features. On native OS-level security features. With JavaScript, we're also quite heavily reliant on third-party packages. And these packages can be outdated or poorly maintained. So when new vulnerabilities are introduced, it might take a while before they are actually fixed. And we're also more susceptible to supply chain attacks, unless we can control and audit our OpenSearch or third-party libraries. On native, to be honest, they're also using quite a lot of third-party libraries, but often not as many. And they more times also rely on platform-specific SDKs, which usually have better maintenance and quicker security updates. And then lastly, on React Native, we can do obfuscation, and we can do like app protection, but it requires additional tools, like the Metro Bundler obfuscator and other JS obfuscators. And unfortunately, they're also weaker in protection. So even though we can obfuscate, it's still possible to reverse engineer them. Native apps have stronger obfuscation tools. So Android apps can be pro-guarded, iOS app can be bitcode compiled, and you can even use additional tools on top of that. So when it comes to companies that prioritizes security features, because of the stricter runtime controls and the harder to reverse binaries and the direct access to security features, the choice is often to go to native apps or to do some kind of where you write your secure code on the native side. So today we're gonna try and make a secure app in React Native. And I just made up some security requirements here. So we're going to have authentication of the app. So only authenticated users can use this app. And then those users can fetch things over network, and then they can store this data in the app. So when it comes to authentication, we want the authentication to happen before the app loads. And we want this to be on a native screen because of the risk of reverse engineering. We also might do things like, security industry standard protocols, use biometrics, or maybe device binding. We then have our storage. So with the storage, that should only be open for the people or for the user who has authenticated. We should encrypt our data, of course, and we should use hardware-backed security features to do this. And then lastly, with the networking, we should encrypt our networking, of course. We should do things like TLS certificate pinning, and then obviously all of our network requests needs to be authenticated, so we need to have that a token passed to the backend. If you draw this app as a diagram, it would look something like this. So the app launches. We have some kind of native screen that blocks the app from loading. And then once that is done, we have our app experiences. And then the app can kind of use the security features through our native modules. And I think already if you're looking at this diagram, you can see that it already starts looking like a Brownfield app, because we have all of this native UI before the app starts. But then another thing is that all of these native modules need to be aware of each other. So usually when we're writing native modules, they're done in separation. They're very modularized. But when it comes to this, obviously our storage needs to be aware if the user is authenticated. And our networking needs to get the token from the secure storage. So we need to have some kind of common area here. And we can't pass this back and forward to the JavaScript side, because then again, we're opening up ourselves to reverse engineering. So we'll have something like a secure core. And this is also a problem in Greenfield apps, because, and I'm going to show you with an example. I hope you can see it. But basically, we have two of these as Expo modules. So the first is our authentication module. And the authentication module does something like starting an activity for the native UI. And then it has, you can see in the beginning, the secure core. It has an instance of the secure core, so that the authentication form can authenticate with the secure core. And then we can send the state of that back to React Native, basically, if you've been authenticated or not. And then we have a storage module, and it also has an instance of our secure core. So when we're getting things, we're getting it from this instance of the core. Now, this is basically how this would look like if we're running this app. So we're getting some data from secure core. It doesn't work because you're not authenticated. So you authenticate, but you still can't get anything, because both of these modules have different instances of secure core. And so this is usually when we turn to Brownfield apps, because then you have this better way of customizing your app logic, because you're actually using the whole app, right? You're writing the whole app on the native side. But we want to do this with Expo. So this is where Expo modules and config plugins come into play. I'm actually going to show this instead of talking about it. So people can see my code? Yes. So this is the project. So at Chase, we use micro frontends. So this is a typical monorepo structure. You can see I have my apps here. My secure app is the one we're writing right now. And then we have our packages, which is our 3 Expo modules, and 1 Kotlin module, and 1 Swift module for the secure core features. I'm actually going to show you this in Android Studio now. I'm going to do everything in Kotlin today, because we don't have time to do both Swift and Kotlin. And also, I couldn't be bothered writing all the Swift code for this talk, but I will upload it later on, so I will share a link to all the code later. So yeah, this is how Android Studio looks like. I don't know if a lot of people work in Kotlin or Android Studio, but this is how it looks like. And basically here we have our app. And again, with Expo, this is the part that kind of gets generated every time you do a build. Here we have our Expo modules. So these have been auto-linked, and they show up in Android Studio because of Gradle syncing. So if I'm showing you the authentication module, it's the one that's already open, you can see here that I start by accessing our secure core. But I'm no longer creating an instance of the secure core. I'm injecting an instance of the secure core using something called Coin. So Coin is a dependency framework, or dependency injection framework for Kotlin. And it basically means that I can inject an instance of the secure core here. And then you can see that I am also firing off a new activity. So if we're trying this in the app, again, we can try and access secure core. it doesn't work because I'm not authenticated. So when I hit the authentication, it opens a completely native UI. And then if we're looking at the secure core module, or the storage module, here, you can see we're, again, using an instance that is injected into the module. So when I'm setting the secure store value, it now works. And even though these are completely two different modules, they're sharing one instance of our secure core. But how does that work? Because I'm injecting an instance, but where does this instance come from? So it comes from the app. So when I'm creating my app, I actually need to create and set up coin with the instance that I want to use. So in the main application, you can see here in the onCreate method, I'm starting coin, and I'm providing all of my coin modules. And the coin modules right now is just one single instance of a secure core. And same with the native UI. All of the native UI exists in my Expo module, but somehow the application needs to be aware of this so it can actually show it. And so I've added that in the Android manifest as well. But all of this will be generated again when I build the app. So everything I've created in the app file or in the app directory will be removed and be replaced by the template from Expo. So how does that work? This is where we use Expo plugins. So I'm going back to JavaScript land now, so back to VS Code. If you're looking at one of my Expo modules here, I have the Android code here. And this is the same that we saw in Android Studio. But I also have my plugins. So config plugins is basically the way Expo applies native logic after the pre-build. So here we have a coin plugin that I wrote. Well, actually, ChatGPT wrote it. It's really good at writing Expo plugins. And you can see all the code I needed to initialize coin and start my coin module. And so what it does is, after it's generated my new build, it will then apply these changes onto the main activity. And same with the activity that I was showing, the login form. So this one registers this one in the Android manifest. So even though I'm continuously generating this, all the changes that I need for my app to set up all the shared instances and everything else can still be applied. Before I finish this demo, I also want to show you one more thing, and that's the actual JavaScript app. So in the app, this app that I was showing on the side here, you can see that I have this authentication button. And the authentication button has an onPress, which then calls the authenticate method. And this authenticate method is just the authenticate method from the Expo module. And as you can see, I'm not passing anything. In fact, if someone reverse engineers this JavaScript bundle, the only thing they will know is that when someone presses the authenticate button, we're calling an authenticate method. All the logic between even the UI that I was displaying, how it unlocks the secure store, is still on the native side, and we can protect it there with all the ways we protect it on native. So, to summarize, today, because of Expo modules and Expo plugins, we can basically do everything we can do in Brownfield and native apps. Now, just one note on this. A lot of things that we have to do at a bank is because we have highest priority on security. But not every app needs this. And it's up to you to determine what kind of threat model your app has and what risk you can accept. For us, it would be very, very dangerous if people got access to our customers' data. But another app might have, using public data that they're displaying in their app. And using something like a secure store then might be overkill. It might also have drawbacks like performance, for example. So it's up to you to kind of evaluate what level of security you need for your app. The second thing is use third-party libraries. If you don't have these very, very strict requirements, there's still things you can do to kind of secure your app. So if we're talking about storage, you can use things like Expo Secure Store or React Native MMKV. If you're doing biometrics, you can use React Native Biometrics, I think, or Expo Local Authentication. There's a lot of these libraries, and if you don't want to spend a lot of time but still just add a little bit of security, you can do that using third-party libraries. And lastly, it's about, I think it's a PR open for React Native right now. It's called Static Hermes. And Static Hermes will actually change a lot of these things. Static Hermes is the next generation of the Hermes engine, and it does a lot of the things here that I've been talking about, but for our JavaScript side. So it's basically bringing a lot of the JavaScript and React Native world closer to how we do it on native. It's not going to be a one-to-one thing, so certain companies will still need to take additional steps, but it's definitely bringing us in the right direction. There's a lot more things to say about security, and I have added a lot of them to my GitHub repo. I also have some links to this talk, to all the code, and also to my social media if anyone wants to talk more about this. You can also catch me around here after this. And I think that's it for me. I hope I've kind of taught everyone a bit about the kind of things that we have to think about when you're working at a company that has the highest requirement on security. And yeah, thank you for listening, and enjoy the rest of your conference.
Thank you very much, Jacob. Let's have one more round of applause for Jacob Arvidsson. Thank you. Thank you. We are now going to stay in the same area. So we're going to go from app security to other favorite thing of all developers, which is implementing authentication. And I wanted to share a little personal story at this point while we wait for Laura to set up. So I specialize in something called tragically short-lived startups. In the last 6 years, I've worked for 3 startups, none of them that exists anymore. So that's startups. And one thing that you do as a 0 to 1 kind of engineer is that you always have to implement authentication, in the first phase of the app. And thanks to Laura's work and the work that they do at Clerk, I actually haven't hated my life doing that part of it. I've only hated the rest of the life of the company. But Clerk really make the authentication easy. And I mentioned the other day that I'm now starting my own company, and I'm sure that this one will be different. This one will not be tragically short-lived like the other ones. But one thing that I think we will be doing is the same as we do everywhere else, which will be using Clerk for authentication. And Laura has been working with developer tools for the last few years, now most recently at Clerk. And she'll help us figure out how to implement authentication in React Native applications. Anyway, is anybody noticing any different? Hats, thank you. And before I had a badge, but now I don't have a badge. I'm just hoping that you notice this incredible attention to detail that goes into keeping you entertained. The costume changes, all of that. So, anyway, so you're welcome. And now, without further ado, let's give it up for Laura Beatris.
Hello, everyone. When it comes to user authentication, the experience really differs per platform. And when I talk about experience, not only from a UX perspective, but from a developer experience as well. And that's what I want to talk about today. How can we leverage our current ecosystem in React Native to build the future of auth? This presentation is going to be divided in 2 parts. First, we are going to talk about the general concept about user authentication. And then we are going to dive into actual abstractions with React Native. But let's start with some basic definitions so that everyone's on the same page here. What is authentication? Authentication is essentially the act of verifying a user credentials and asserting it against an identity. It's based on something that the user either knows, has, or is. And this is what we call auth factors. Authentication factors is a layering strategy that strengthens security and decreases the chance of your account getting leaked in the end of the day, for example, if you use password as the first factor. But in order to talk about the future, shall we go a little bit into the past and visualize where we have started with user auth and where we are heading towards. In the beginning of the 2000s, we have started with the basic logins. Just basic password, email, and username. I don't know who here remembers the worst experience ever. For example, if you had to share your Facebook account data with some other website, you still had to use and to put your password there and share this with some totally random encrypted database. And so, along the years, organizations have put together specifications and protocols to solve this problem with single sign-on. That was the reason of what we know nowadays as OAuth and other protocols as SAML and OpenID Connect. So that, for example, if you are an employee in a company that has dozens of applications to deal on a daily basis, you also don't have to memorize so many passwords. Well, this was the beginning of the experience starting to get better. As hardware progressed along the years, we started to have biometrics. So the users can prove who they are with fingerprints. And then most recently, just a couple of years ago, the concept of passkeys have been introduced. Well, it's pretty obvious by then that the long-term usage by passwords has led to so many data leaks incidents. And this is due to passwords being a shared secret. And what do I mean by shared secret? You are not the only one who owns it or who actually knows about it. Your auth provider also does. And who actually can guarantee what are the patterns and techniques that your password is being saved in an actual database? That's the sensitivity about it. I don't believe we should get completely rid of it, but today I want to show your newest friend. Let's talk about passkeys. Passkeys are a big step towards a passwordless future. We'll explore how it works, why they are more secure than traditional passwords, and how they are shaping the future of digital authentication. Here's a diagram in which it showcases interaction between an authentication server and the user's devices. It leverages the idea of public key cryptography. So let's go each by each step. First of all, the user device requests a challenge from the server. The challenge here, it's essentially a totally random nonce string. Once the server returns the challenge to the client, it goes to the device authenticator. The authenticator here, as I mentioned, is really the device hardware per se. So you could be using your iPhone, your Mac, doesn't really matter. The key point here is that the authenticator is going to prompt the user if they are really trying to sign in. And it's going to trigger biometrics. Biometrics are going to help the user to prove who they really are in order to unlock the device private key. And with that private key, the device is going to encrypt the challenge in order to send it back to the server, which is the 5th step over there. The server then, it's going to validate the signature with the user's device public key, and if everything goes fine, it creates a valid session. Pretty straightforward, isn't it? Well, this concept and this idea of public key cryptography has been around for a while. It's not a new thing with passkeys and WebAuth and at all. It has been around since the 1970s, and it has covered a variety of use cases in the industry. One of them, you may well know, it's secure encrypted messaging communication. So let's take a look at an example. We have 2 users here, and they are communicating with each other in a chat app. So I have, let's call it Anna, and let's call it Bruno. So when they join this chat application, they share public keys with each other. Let's say that Ana wants to send a message to Bruno. Her message, it's going to be encrypted with Bruno public key. And once the message reaches Bruno device is going to use his private key to decrypt the message before displaying it on the screen, of course. So let's say a totally random and creepy user tries to intercept it somehow. It's impossible, because they will never have access to the private keys. And I'm just demonstrating this because the high-level overview of what passkeys provides in a security perspective, it's pretty similar. Passkeys are powerful things. At the end of the day, they provide not only stronger security because of what we just saw, but they are streamlined. And what is being streamlined? I'm sure that by this point you might have already used passkeys in some application. And for iPhone and the Apple ecosystem specifically, you get prompted to sync your passkeys along the iCloud chain. And the same thing happens with other ecosystems. So that means that if you switch devices, you can still reuse those. No shared secrets anymore. And the best thing of it all is that you have built-in MFA. So built-in multi-factor authentication has essentially the idea that your device is the first factor. And the coolest thing about it is because it triggers biometrics to actually unlock the private key that's the second factor. Okay, so we know the concept, how we can implement it. So far, at Clerk, we have developed a package for handling passkeys with Expo, leveraging our front-end API, and Expo native modules. It's a matter of importing a single React hook. And with the use signing return, you can call a method called authenticate with passkey. You can also choose which flow mode you're going to use. If you want to leverage the latest iOS 16 autofill mode, you can also do so. And it's going to essentially select and trigger the prompt for your users so they can start interacting with your app. Here's a quick example, super simple, calling this API for iOS. And then here's my session successfully created. Now, at Clerk, our main belief is that developers building apps shouldn't have to be concerned and take too much of their time caring about auth features or anything around the user object per se. Instead, they should be focusing on building your viable features. And depending on the kind of business that you're dealing with, the thing is that auth requirements, they scale along the way. So let's say that you decide to ship an enterprise plan, compliance comes in, and you need to implement certain protocols like SAML. Or let's say that you just want to change your auth flow and put it in a more secure way, you want to introduce OTP. All of those things, they should be reactive as a service, like Lego blocks. Also, you want to make sure that auth doesn't provide friction up front. Because if you're better lose your users, it's much better to be because of your features and not auth itself as the first impression of your app. So it's been some time that we have introduced components, auth components for Expo Web. It's just a matter of rendering a signing component. You get all of the reactivity of auth as a service. You have your OAuth buttons. If you want to have other protocols like SAML or even support email and password, it's going to display the identifiers inputs as expected. Reactive, as I mentioned, because along your business requirements change, you can change this directly via the dashboard. You can see the passkeys there, as we just talked about. But we don't want to keep this within Expo web modules only. We want to go further. And so the goal is, let's expand off components to all platforms. This is something that I have been working as a side project. It's coming up pretty soon to the Clerk Expo package. It's leveraging, again, the native modules capability from Expo, and also the recent development of Clerk native packages, Clerk iOS and Clerk Android. So, off components for all platforms, so that we can meet reactivity and composability. Now, I believe that the previous UI that you saw, it cannot be exposed to mobile platforms. And there are two reasons for that. First, I think it's too encapsulated and big to cover all of the types of screens. It wouldn't fit Apple Watch devices. And also, in mobile experiences, UI customization is a must. And in fact, I think the most complex experiences with UI that I ever saw in my life was in mobile. So that's why I want to emphasize composability. Coming up, Clerk elements for Expo. Essentially, last year we have introduced Clerk elements for the web, the idea of headless components with accessibility for off, in which the developer shouldn't have to build their own markup interacting with React hooks, but they could build as Lego blocks. That's the same idea or a similar DX goal that we have for Expo. If you want to build a signing page, let's just start with it. You start by declaring a step. You can put your identifier field over there. The action to continue. And let's say you want off. You can create a connection button to sign in with Google. If you want to make it even strength for security, you can add a verification step with email code OTP. And every single slot here gets translated to the native code behind the scenes with Clerk iOS and Clerk Android. There is one important thing when it comes to authentication experiences, which is the seamlessly integration within your app. Avoiding as much as possible context switching so that users can authenticate as fast as possible. Let's take a look into two different examples. So this is a signing with Apple button, super simple, and you can see that it triggers a web view. Let's be honest, web views are not cool. Especially for React Native, there are so many problems with deeply linking it back, etc. Tokens, stuff, it's complicated. So what if we can actually use native, oh, sorry, I skipped one part. This is what we already support. It's the web viewer experience. Sometimes you really need it if you want to integrate with SAML, there's no way around it. So we have this hook in which it starts up the SSO flow connecting with the auth service. And you can pass the redirect URL in which is going to deep link back, and you can choose this strategy, which in this case, it was running off Apple. All right, now it's the native part. If we want to make it seamlessly integrated, we can use native Apple signing, for example. So let's get rid of this. And let's start with this one. It's much faster. There's no context switch, there's no opening a web view. And that's what we are going to expose as a simple component, leveraging Expo native modules behind the scenes with our native iOS SDK. All right, we make it seamlessly now. Let's make it fast. We need to make it fast from a session initialization perspective. Two things that are hugely important here. I don't even know if this was an English word, but anyway. First of all, encrypted local token storage, and second, mobile offline support. In Expo apps, the recommended way to store sensitive data such as tokens, it's by using the Expo Secure Store package, which encrypts the data before storing it. So we leverage this as well with a token cache that can be injected in the React provider. And not only that, we also have released it a couple of months ago, an experimental resource cache, so that you can have reliability in cases of bandwidth widths that are so common, and to bootstrap offline resources around auth. So let's go back to our equation really quick. What is a good authentication that we want to aim for the future from a both developer experience and user experience perspective? Well, it needs to be fast, it needs to be seamlessly integrated, and it needs to be secure. In the next couple of weeks, you can expect Expo elements coming up around the Expo package. I'll probably be opening up PR pretty soon. And that's all I wanted to talk about today. Thank you so much for watching.
Thank you very much, Laura. One more round of applause for Laura Beatris. Thank you, thank you, thank you, thank you. Now let's get our next speaker preparing here on stage, and I'll have to come up with something to say. Our next speaker, Tomasz, I've been a huge fan of his work for a very long time. He's here to talk about Bolt, you know, the AI generation platform that can also generate mobile apps. How many of you have heard of Bolt before? And have you used it? Yes. Well, the thing is, I've been a big fan of Tomac's work on Bolt even before Bolt was a thing, because I don't know if you knew this, but Bolt comes from this company called StackBlitz, which develops this technology called web containers, which allows you to run full node runtimes in the browser. And I don't know if there's any browser fans in the house. I know this is this is a mobile company, but I'm a big browser fan. And running web containers has been like a massive enabler for a lot of products that I've been building. And I'm so happy to see Bolt finally now getting traction and getting a good use of this work that they've been doing for years on StackBlitz. So without further ado, let's give a massive round of applause to Tomasz Sułkowski.
All right, welcome everyone. I'm really happy to be here and share my perspective on some of the crazy stuff that has been happening in space between the coding and AI. Do we have a slide? Yeah, but first, why software composing? Well, to be quite honest, it sounds significantly more sophisticated than vibe coding. But seriously, I'm also a musician at heart, and it resonates also with how I think about this topic. So I think it really represents the value of the tools that I'll be showing for you today. I'm Tomek, I'm a founding engineer at StackBlitz, and I work on product UX at Bolt.new. You can also find me in most of the usual online spots as Sulca. So today I want to share my experiences and perspectives on the whole vibe coding thing and why I find it so useful, no matter if you're a technical or non-technical person. So first, let me tell you a little bit about the history and the tool that I spent pretty much most of the last decade building. And this will get really nerdy really fast, but only for a moment. So if you've been around the JavaScript ecosystem long enough, at some point you've probably come across these either simpler or more complex advanced online sandboxes. Some of the popular ones are JSBean, CodePen, or StackBlitz. Usually how they work is that you either have some custom in-browser bundler that gives you a simpler but a single stack release setup, or they connect to a remote virtual machine where you can run more stuff, but for the price of having to pay for that compute, that CPU, that memory, and all that stuff. In StackBlitz, we've built something else that is quite unique, really. We've basically created our own mini operating system called Web Containers that has a file system, a virtualized network layer, and other things like that. And it all runs client-side. The full runtime is really in the browser. So, for instance, if you go to node.new, you can see how it quickly boots up. And let's see, you can run commands. You can execute actual Node.js scripts and even install dependencies. Finally, because this is a full runtime environment, you can even run development server. Again, all client-side in your browser. So this is quite mind-boggling from a technical point of view, because you can basically run backend in the front end. But it's also really cool from the reliability perspective, because we can scale up to hundreds of thousands and even millions of developers using the platform without really a dent in our infrastructure. We mostly store the text files of your sources. Okay, but now, while all these innovations were happening for developers, another technical revolution was brewing, and some time ago, the topic of LLMs and AI broke through to the general population in the form of ChatGPT. Because it's all a website and you don't have to install and configure anything, it gained a lot of popularity very quickly, very similarly to StackBlitz in the JavaScript world, actually. And it allowed people to prompt and get back text and later also images and in other tools also videos. And one of these artifacts can also be code. But the code itself is not really that valuable. It's all about what it does when it runs, right? So it needs a runtime. And it just so happens that we have one. So this is how bold.new was born. And with this, we leave the nerdland and come back to the, let's call it, popular technology. So let me show you how this works. I'll start with a very simple prompt. And this is actually how it gets funny already, because Bolt tries to interpret every single thing you send it as best as it can. So if you leave the prompt vague enough, it will get creative. At first, it comes up with a plan. Then it sets up the dependencies and starts creating files. I've obviously sped up the process because it can take up to 2, 3, sometimes 4 minutes. And I really don't have enough anecdotes for that. But yeah, anyways, because we've asked for a mobile app, it has actually created an Expo project. We can preview it still in the browser, but it's way more fun and realistic if you use Expo Go for this. So as soon as we scan the QR code, it will create a bundle and show us the app. Thank you. So as I said before, it tries to squeeze as much information as possible from that initial prompt. So the result is not your usual hello world. If you've never tried it before, I fully understand if you don't believe that this is the actual result. But so after this talk, please go ahead and try it on your own. We have free tokens available for the first users, so you can just try it, and that's the result, more or less. Like, the results may vary, but it's kind of crazy. And in fact, these results are so valuable to folks around the world that recently we've just hit 5 million users on the platform. And by the way, this is where the runtime architecture comes into place and really shines, because we never had any scaling issues. Every environment basically runs on the user's browser, so still no problems there. Okay, but I want to share with you 2 cases that I think will help frame how this is applicable to the real life. So this is the StackBlitz team, minus 3 people. We're not that big of a team. But because we're fully remote, we don't meet a lot in real life. But we regularly do company offsites to spend some time outside of Zoom. We just met this month, actually. There were 30 of us, and to be honest, in some sense, it reminded me of a school trip, maybe because of the around 30 people group. And for instance, we had a lot of activities where we had to be on time on a bus, and there was one responsible adult who was making sure that we're all accounted for. So our friend Mallory always had a paper sheet with the full list and had to mentally tick off everyone who is present and who is missing. And of course, that made me think there should be an app for that. So without too much planning ahead, honestly, I jumped into Bolt. So the prompt can look something like this. I described the situation. We're going to an offsite. I want to build a mobile app that will help me make sure all the people from the team are accounted for. We'll need a list of people, name on the avatar, and a checkbox, so to know where the person is present. And I also want to have a summary of how many people are we missing. These are my only requirements for now. They just seem the most obvious. So Bolt is doing its job. And as this time the prompt was more specific than previously, the initial version of the app, as you will see in a moment, is very much exactly what I asked for. So let's test it on mobile. And yeah, basically it works. But I already see some places for improvement. First of all, the way it's implemented, you have to click on that little dot on the right, which is an unnecessary small target to hit. So let's fix it. So I want the full person item list to be clickable. As you can see, I'm not even that precise with the vocabulary here, but it should be okay. This time it's actually real time, haven't sped it up. And yes, this works. Now you can see this here, that the whole area is clickable. But now I have another idea of how to make this work even better. So the idea is that when someone is checked in, they should go to the end of the list, because that will make the UI clearer. And as you can see, this works, but it's quite jarring, to be honest. I think some of you already have an idea of what we're doing next. So let's animate that change, so the user has a better idea of what's going on. As you can see with the question mark, this time I was a bit unsure whether this will work for some reason, but let's see. And the animation looks way better on the actual device, so let's test it there. And yeah, nice. Looks like it works as advertised. Thank you. Yeah, it wasn't that eloquent prompting on my part, as you've seen. It's all bold. Okay, I spelled you the details, but since then I realized that there is no way to add new people. So now each person with the app should be able to write their own name and contact information to generate a QR code for the organizer to scan. Things like that, so they can also call them very easily. More improvements, and so on. So you can see we're running this cycle of prompt, play around, get an idea for an improvement, and prompt again, play around, have another idea, and so on. And this is really why it's called vibe coding. You don't need to have a fully specified app or feature in your head, but in fact, if you think about it in your professional environment, we also often, the specs are not ideal, and only when the implementation shows up on the screen, it's when the shareholders realize, oh, we should actually add something here, we're missing something there, we should change this or that. So here we're just iterating way faster. And what is really cool, besides how fast you can build it, that this can be quote-unquote just prototype, but look how much more interactive and lifelike it's than a typical, even clickable, but traditional prototype. In Bolt, you can also very easily connect a database, making this basically a prototype with infinite value states, as realistic as it can be. We also have several other integrations, making it possible to build actual production app with it. In fact, a quick plug, literally today in less than 6 hours, we're starting a biggest hackathon ever. We're working with Guinness Book of World Records and everything for people with ideas, but not necessarily a programming background, although developers are invited as well. You can find all the details at hackathon.dev. And last I heard, we had already 50,000 participants signed in, so this is a crazy week. Anyways, back to our professional setting. Here's a little tip. If you make that more elaborate prototype that I've just shown, maybe more elaborate than that, when you're satisfied with it, you can ask Bolt to write you a spec that you will bring to your team together with that lifelike, super convincing demo to break down into tasks. Because Bolt knows already everything about what you prompted, including like the changes, the adjustments, and you can make it as detailed as it has to be. Okay, let's take a quick breather. And case number 2. This will be a quick one, but hits close to home. So in Bolt, when a runtime error happens, because we control the whole environment, Bolt recognizes this and shows you a dialog with an attempt fix button. So if user's app breaks somewhere, it will show. Now, sometimes the error is quite tricky, or occasionally even not an actual error, but a more complex issue that it would be best if user actually understood what's happening behind the scenes. So we have a really good support docs, but as the saying goes, nobody's inclined to read the manual. And the users will rather try clicking the attempt fix button like 10 times and waste tokens than go and just visit the documentation. So I figured if that happens more than, let's say, 2 or 3 times, we should bring the necessary information to the user. So now the help button would appear and fetch the relevant docs dynamically, again using AI. And while we're at it, we should also have this behavior available on demand, even if there's no runtime error. So here's the kicker. This part is not an actual feature yet. It's a prototype that I've built for my team in Bolt to kick off some discussions and scoping. So this might be confusing, but this is Bolt running a part of Bolt interface, really. So if I were to summarize what vibe coding, aka software composing, is about, or where the practical value is, it's an amazing opportunity for people who can't code to build almost anything they want, not being confined to things like the typical CMS and such. And they can build also helpful utilities, personal utilities, something that up until now was only possible for developers. Some of the more entrepreneurial ones are building actual business on top of it. And in our professional setup, above all, it's an efficiency booster. I use it for internal tools, but primarily for scoping and for communication. So prototypes, proof of concepts, and so on. And these are the things that everyone on your team can now build. And of course, that brings me to the mandatory question, will AI replace developers anytime soon? Let me answer this way. Even in Bolt, we're still looking for new, good JavaScript developers. We have like 10 positions open right now, so no. So that's all I have for today. Big thanks to App.js Conf team for organizing this awesome event, and to the Expo team also for helping us build this Bolt Expo integration that works really magical. So see you around, and let's grab some coffee.
Amazing, amazing, amazing. One more round of applause for Tomek. Now, can anybody tell what's different this time? Yeah, you probably can't see it. It's a sorrowful gaze in my eye, because this is just the last talk that I'm hosting here today at App.js. I want to say thank you, everyone. It's been a pleasure to be your steward. And it might be too late for me, but you still have some chances. So you have last chance to grab Amazon Coffee, last chance to sign up for the raffles at the Sentry and Code Magic booths. We'll see you back here with Nathaniel at 4:30.
Hello, everyone, during the last meeting with us at Live Studio App.js just before the after party. And right now, we are hosting the Alex Cho, the engineer, the product engineer and party engineer at Partyful. Hi, Alex.
Hi, yeah, thanks for having me.
Yeah. Can you tell us a little about the Partyful app?
Yeah, so Partyful, we're out of New York. We're basically an events platform. So people come to Partyful, they create an event, they invite their friends. People typically use Partyful right now for birthday parties, housewarmings, watch parties, picnics, etc. But it's a fun product. People can be really creative, make their designs, and really put their personality out there, and hopefully invite their friends, and everyone has fun.
So what's your favorite feature of Partyful?
Oh man, okay. Favorite feature, there's so many. I think my team is gonna laugh. I love birthdays. I'm like the biggest birthday believer. So I mentioned a big use case is birthdays. I'm very passionate about it because I'm 30 now. I'm not going to that many parties, but the one party that I will have every year is my birthday. And I truly believe everyone should at least host one party a year, because everyone that I've checked with has a birthday. And so I think we don't really have too many features around it. We just ask you for your birthday, and we'll send you a notification a month before to be like, hey, plan your birthday. And I don't know, I think that's really what Partyful is trying to do, is encourage you to be like, hey, there's a reason, everyone has a reason to celebrate themselves, and also celebrate the people around you. And yeah, that's why I like it.
All right, so it's gonna encourage us to party with you. And do you have any features that help us better experience our birthday, for example?
Better experience a birthday. Well, okay, maybe not specifically a birthday, but if you're looking for inspiration, we have this feature called Party Genie. And basically what it is if you're looking for inspiration that you want to host, there's a button on the homepage that's get inspiration. And we will show you these templates of different wacky ideas. So one of my favorites that we like to talk about at Partyful is a water tasting party. And so basically we just give you ideas to be like, hey, why don't you try to host this and send this to your friends? And if people are interested, you should actually do it. And for a while, people thought this was AI. And unfortunately, investors don't listen, but it's not AI. It's actually one of our coworkers just has the best ideas of all these wacky parties. And so, yeah, that's also one of my favorite features, and a great way to get inspiration.
So actually, he's the party engineer because he inspires people.
Honestly, yes. Chief party officer. Yeah, definitely.
So what were the biggest parties that were organized with Partyful?
The biggest one, it's tough. There's a lot. I think a lot of the biggest parties are actually memes. So they're not there's 5,000, 6,000 people events. I think the one I mentioned in the presentation, Timothée Chalamet, that was a pretty viral one. And so I can't remember how many guests there were, but that is an example of a huge viral event. Yeah, that's the one that comes to mind.
So a big question is that I think many people would like to have the answer to. Did Timothée Chalamet win the lookalike competition of Timothée Chalamet?
So he did not, somehow, but actually he showed up after the fact. So they had the competition, and then the winner was crowned, and then Timothée Chalamet showed up, and there's a famous photo online of the winner and Timothée Chalamet taking a picture together. Yeah.
And well, what are the next plans of Partiful? What would you like to develop next? What are your ideas? How to convince people to use Partiful as their default app for the parties?
Yeah, we have a lot of ideas. I think the one that I'll give you a sneak preview of is something that I'm working on with a few of my teammates. So right now, Partiful, it's a very, social. You're with your friends. It's kind of your private network. The problem is you don't always have a friend's birthday party to go to or a friend's housewarming. And we want to start getting into like helping you find things to do with your friends. And so we want to maybe surface, classes or surface, club parties or concerts or, it could be many things. We're still thinking about what kinds of things we want to surface, but essentially helping you discover things to do where you are, and critically like with your friends.
All right. Me, as a new user of Partiful, potentially, I wanted to throw a party, right? And I can send everyone an invite, and everyone can open it. Not everyone got to have an app, right?
Yes.
We can use it on the web, on the Android devices, on iOS as well, but...
Yeah. Yes, so Partiful started as a web product. As I said before, like, if you were app only, like, you're not going to get many people to RSVP unless they already had the app. And so we started with web because we needed to prove the concept. And once we built the mobile app, like, we still needed to support web, and we still very much like believe in the future that we need to continue to support web, because we're always going to be reaching, hopefully we're always going to be reaching new users. And yeah, they need to try it out on web first, on AppClip, and then once they're convinced, then use the app. But I think like web is definitely an important surface area for us, like to grow and like be like, hey, like this is kind of a fun thing that you should invest in more. Yeah.
And from the engineer perspective, we were mentioning the app clip, and that was the main topic of your presentation that I really recommend to watch if you didn't. What were other challenges apart from the bundle size that you had to fight against?
Yeah, so you asked like what were the challenges?
Yeah, apart from the bundle size that is limited, restricted on app clip.
Specifically for the app clip. Yeah, I think I would say that when I was preparing for this presentation, I looked at the documentation again. I think it's improved mightily since the first time. Either it's improved or my understanding of it has improved. But I think it just took, there's a lot of upfront costs to understand things like how the invocation works. There's something called associated domains where you have to link the app and the server side. And that's a concept that was unfamiliar to me at first and took some time to understand. And then I had one slide about like how to test it, test it and release it gradually. Because I recall like the week before we released, we had everything, we had it building, we had it under the bundle size, but then we were like, will it actually work or is it gonna crash? And we didn't want to turn it on to 100% because that just meant like all iMessage invites were going to crash. And so we had to like spend time to look into like how can we test with just one event, and then okay, let's enable it for only employee events, and then like 1%, and then so on and so forth. And so yeah, I mentioned in the presentation how we were able to do that. But yeah, I think the release part and understanding the last mile of the project was pretty difficult for us at first.
So seems like pretty experimental feature at the moment and not very widely used. How about Android? Are you thinking about using the instant app? Is that called like that?
Yeah,
or?
Instant app. So not right now. We focused on the app clip first because most of our users were iOS users, and also the React Native app clip was a library that really boosted our ability to get to an app clip. We haven't yet found something as stable for instant app. We would love to, if anyone knows it, we would love to hear about it. And yeah, I think we would like to see more usage on our Android side before we invest in an instant app. But I'd be curious if someone could point me in the right direction.
Right. So right now you are building a user base for Android and then go deep into it.
Exactly. Yeah.
Right. Since Perttu started as a web company, web project, did you convert a lot of code from web into the React Native, or you just start from the scratch?
Yeah. So at first, it was very much starting from scratch. You know, we have component libraries that are different on web and mobile, and that is kind of the status quo and the plan for now. We don't plan to use React Native on web at the moment. The things that we do share, that we actively have tried to share, are things like, you know, our API contracts, business logic, our helper functions. We moved to like a shared package within our mono repo, and that way, you know, for the most part, web and mobile should behave the same. And then like the nuance of, you know, specific UI elements, we want to keep specific to mobile and then web. Yeah.
Okay then. So well, thank you very much.
Yeah.
And please download the app. Should I say download the app clip or use the app clip to join the after party tonight that is starting after the talks, and enjoy also creating new events with Partyful. So thank you very much for the conversation.
Yeah, thank you guys so much, and thank you for having me here in Krakow. Like, it's been awesome. Software Mention, you guys have been really, really welcoming, and I hope that, you know, Partyful can continue to be a part of this in future years.
Yeah, thank you.
Yeah, thanks, guys.
Thank you very much.
Discover AnimateReactNative.com, your go-to platform for premium, customizable, and ready-to-use React Native animations. There are over 120 different animations that are going to save you time, enhance your, and, in my opinion, is the perfect collection if you'd like to learn more about React Native animations. Get 60% off by using App.js Conf. Visit AnimateReactNative.com.
ElevenLabs conversational AI is evolving. We've been optimizing some brand new features to create the most sophisticated voice agents in the world. First up, we've developed a state-of-the-art turn-taking model to help agents perfectly understand when to interrupt.
Thank you. And what's your order number, please?
Oh, let me just double check. 947835.
Perfect. Your delivery is on its way.
And secondly, we've integrated language detection for seamless multilingual discussions.
Hi, welcome to our design studio.
すみません。日本語で話してもいいですか？
もちろんです。日本語に切り替えましょう。
And we've built the world's first integrated RAG for voice agents to retrieve from your knowledge base at minimum latency with maximum privacy.
Your next patient is Mr. Frank Reynolds with ataxia.
Oh, it's been a while since I've worked with ataxia. Could you remind me of the guidelines, please?
Sure. I analyzed all the best practices and found this.
And lastly, why limit your creativity when you can switch between multiple characters in a single agent?
Okay, guys, let's head east towards downtown.
I'm not sure about that, boss. Hey, don't be scared, man. Let's just go.
This is just the start of a new era of communication and understanding, all with full HIPAA compliance, third-party, enterprise-grade security, optional EU data residency, and industry-leading reliability across all agents. The potential of conversational AI has never been greater. The time to build is now.
Good code is good, we don't touch that. But for everything else, there's Sentry. Whether you're a mobile, back-end, front-end, or any end developer, we'll show you the environment, device, OS, even the commit that introduced an error, down to the broken line of code. Yet the woes of a developer go far beyond when code is broken, it's also when code is slow. Detect endpoints, slow spans, and operations consuming the most time across your stack and keep everyone feeling not bad.
welcome back, everyone. And I'd like to say a big welcome as well to our live audience who are checking back in with us. It has been a long day, lots of amazing talks, but we've still got 2 more. So get settled as we get ready. Now, I would like you to really, really make some noise for our next speaker, because it's their first time speaking. And I am so proud every time I see a new speaker on the stage. So, can we give a massive round of applause to Kiryl?
Hi everyone, nice to see you all here. I hope you are still excited about historical dive talks, because we already had a few of them. Can you raise a hand if you ever struggled with keyboard handling in a React Native? I see a lot of people. Okay, my name is Kiryl. I'm a software engineer at Mendiola, and today I'm excited to take you on a journey through the keyboard management evolution in React Native. You can think of it as a space-time adventure. We will explore how keyboard handling has changed over time in a React Native, with a few cosmic metaphors to thrown in to keep things fun. So buckle up, we are ready for liftoff. The React Native framework was released in 2015, and early adopters quickly began experimenting with the new framework. However, they soon ran into a major pain point. There was no proper way to handle the on-screen keyboard. In version 0.11, the React Native team introduced a new component called Keyboard Avoiding Queue, designed to address that issue. And later on, the Android support has landed. But what exactly Keyboard Avoiding Queue is doing? The answer is quite straightforward. By default, iOS doesn't handle the keyboard, and instead it delegates all the responsibility to application developers. Looking at this markup, many React Native developers will say, just add keyboard avoiding queue and everything will start work as expected. And they are totally right. When we wrap our layout inside keyboard avoiding view, our inner content is getting resized and pushed above the keyboard, so everything works as expected. But let's have a look how it works on Android. And in reality, on Android, the keyboard avoiding queue is not needed in most cases. The Android resizes view automatically, and the way how it's getting resized is controlled by window soft input mode setting, and Android typically doesn't animate these transitions. The layout just jumps into the place. And with info that we just learned, a reasonable question comes to mind. Did we master keyboard handling? The short answer is no, not yet. We are only at the beginning of our exploration, and let's take a look at cases where keyboard avoiding queue falls short and continue our journey. Many React Native developers immediately notice that keyboard avoiding queue doesn't handle large forms really well. And indeed, if you set focus to inputs that are very close to header, when keyboard is getting shown, the content can be pushed and your input can be obscured by header. It happens because keyboard avoiding queue doesn't know anything about focused input layout. It simply resizes the container, and because of such thing, it happens. Fortunately, in November 2015, a new package by community was released, which is called React Native Keyboard Aware Scroll View, which was designed to solve that problem. And to a large extent, it did. For sure, this package had some downsides, like animations are a little bit desynchronized, it didn't track inner layout events, so if you have multi-line text input and if your multi-line is growing, it wouldn't scroll into visible area. But this package was written entirely in JavaScript, and contributors from all around the world have contributed to that package to make it really stable. But how does it work on Android? On Android, again, this component is not needed because Android resizes view automatically. But we all know that React Native stands for native, right? And in fact, keyboard handling is not a React Native problem. It's a common, long-standing issue in iOS ecosystem. But since React Native relies on native libraries, the question is, do we have a solution for this on a native language? And the answer is yes. Many iOS developers are using IQ Keyboard Manager, and we have a corresponding wrapper, React Native Keyboard Manager. This package offers excellent, perfectly synchronized animations. It delivers the experience that iOS users expect to see. It can be easily integrated as a global module, and on top of everything, it's also bundled with additional UI features like a keyboard toolbar that can help you to simplify keyboard interactions by providing additional button navigations between text input, as well as done button for closing the keyboard, and overall it feels like a great input accessory addition. So at this point of time, it looks like we finally found the gold standard. We can use React Native Keyboard Manager with all its advanced features on iOS, and we can rely on default Android handling. And indeed, this combination was popular for years. But in fact, Apple do not stop here, and they continued to improve keyboard experience by introducing even more advanced capabilities. And one of such capability was an interactive keyboard dismissal. This technique is commonly used in many chat-like applications, and basically it allows you to dismiss keyboards as you scroll the scroll view, literally by gesture. To support this, React Native team introduced a new component, which is called Input Accessory View, which not only plays nicely with interactive keyboard dismissal, but also let your inner views to be sticky to the keyboard. Before we go to further slides, let's take a quick pause and see what we've discovered so far. So, by default, window is not resized on iOS. Instead, we get events when keyboard starts its movement and when it's finished. So we can apply animations and move nicely elements around the keyboard. iOS also has rich ecosystem. We have tools like IQ Keyboard Manager, and these tools are bundled with additional features like keyboard toolbar, and on top of everything we have interactive dismissal. But what Android offers in terms of parity? Well, actually, Android handles everything for you, so you do not have to bother. But is full automation always a good thing, especially when it comes to customization? Let's take a look at a quick example, at a simple layout. So here we have header, pretty large form, click to action button, and bottom tab bar. Effectively, when keyboard appears on the screen, we expect that our bottom tab bar will be rendered beneath the keyboard, and our button will be sticky to the keyboard and will be shown above the keyboard. And such layout is totally achievable on iOS because we have a control of each aspect of keyboard animation. But on Android, typically layout would look like this. It happens because window is simply resized and the content just pushed above the keyboard. And here is the big question. Can we fix it somehow? The answer is yes. React Native ecosystem kept evolving, and the next big milestone was the creation of a React Native Avoid Soft Input. This library aims to deliver a true cross-platform experience by enabling animated keyboard transition and disabling automatic window resizes on iOS, on Android, sorry. And this library made a major step forward in terms of controlled keyboard handling. It brought us closer to a smooth and consistent experience on both iOS and Android. However, on Android, animations are still desynchronized. So let's continue our journey even further and see if we have a solution to this problem. Let's quickly step into parallel Android metaverse to see what has been changing there. In 2020, Android team released Android 11 and a new API called Window Instance Animation. And this API marked a real breakthrough in controlled keyboard handling. For the first time, developers could smoothly animate UI elements with sync keyboard movement. And it was exactly this API that inspired creation of a React Native keyboard controller. Before building this library, I had few key design principles in my head. And yes, I'm the creator of keyboard controller. Nice to meet you all. First and foremost, it had to work consistently on both platforms, delivering the same experience and behavior. Second, just as important, it should offer a unified API without a need to write a conditional code for each platform. And last but not least, it had to offer the same feature set parity on both operation systems. The first missing piece in React Native was the lack of keyboard will show and keyboard will hide events. And keyboard controller fills this gap by introducing a module which is called keyboard events. However, due to platform differences, we can easily utilize it on iOS, but on Android, if we will try to use it, we still will have desynchronized animation. It happens because on iOS, we have a single manufacturer, and animation curve is the same on all devices and on all operation systems. On Android, situation is a little bit different. We have different manufacturers, we have different OS versions, where each OS can customize the keyboard animation curve. To solve this problem, I introduced two new hooks. The first one is use keyboard animation, which basically returns you two values, height and progress, which are both animated values and are driven by native driver, which delivers exceptional performance. And finally, we can have a totally synchronized animation on Android. Thank you. However, built-in animated from a React Native had its own limitations. For example, you cannot animate width or padding or other layout properties. So I added a counterpart hook, which is called use reanimated keyboard animation, which basically does the same as use keyboard animation, but instead returns you shared values instead of animated values from a React Native. And this hook expands the range of use cases where you can use it. However, sometimes you need to have a fine-grained control of each frame during keyboard animation. And this is exactly where use keyboard handler comes into the play. Basically, this hook gives you 4 callbacks, which are invoked when keyboard is moving. How it works? It works pretty simple. Before the keyboard shows, we will receive onStart event, which will contain destination values. Then, as animation continues, the onMove handler will be constantly getting called, reporting current keyboard position on the screen. And in the end, when animation is completed, the onEnd handler is getting called. So you can write your imperative code directly inside worklets and perform animations on UI thread without any desynchronization and have an absolute control of each aspect of keyboard movement. And you can see that we also have on interactive handler, and we already knew that we can dismiss keyboard interactively on iOS. But what about Android? Is it even possible to have something similar on Android? The answer is yes. Window Instance Animation API not only gives you the ability to read current keyboard frame, but it also gives you an ability to control keyboard position. Internally, interactive keyboard dismissal works totally different on Android and on iOS. And to unify the API, I introduced a new component called keyboard gesture area, which basically tells you where is the region of your gestures on the screen, which can control keyboard position. Typically, you wrap scroll view inside that component, and after that, you need to select an interpolator, how exactly keyboard position will be controlled by your gesture. And in reality, all of these hooks and keyboard gesture view, they work perfectly. But in most real-world scenarios, you just need to avoid the keyboard. And you, as a developer, typically you wouldn't like to write a lot of repetitive code. In general, if you find yourself repeating code again and again, it's a sign that something is off. And this is where React declarative approach shines. By leveraging these hooks internally, we can create high-level components which will help us to build flexible tools for keyboard avoiding. And first such thing is keyboard avoiding queue, already well known. Basically, this component works identically to what we have on a React Native side, with one key difference. Its implementation is totally rebuilt using keyboard controller API, and because of this, it works identically on both iOS and Android, offering you perfectly synchronized animations. And it's totally drop-in replacement for default keyboard avoiding queue, but a part of keeping the same interface. This component also extends behavior props with additional, such as translate with padding. On the other side, sometimes we don't need to resize our layout, and we just want our views to float around the keyboard. And in this case, keyboard sticky view really shines. That layout that was challenging before on Android, now you can see that it works as expected with perfectly synchronized animations without UI glitches and other unpleasant things. It works similar to input accessory view, but you are also allowed to specify conditional padding for closed state and for open state, which is really nice because input accessory view has some limitations. I also rebuilt keyboard aware scroll view with some additional improvements. The default implementation, as we saw in the beginning, had animation desynchronization and other issues, and the package from a keyboard controller solves this problem. The animations are perfectly synchronized and delivers the same performance as IQ Keyboard Manager, but on top of everything, we also track additional events of focused input. So if your input is getting growing, the keyboard aware scroll view takes care of it and will automatically scroll it into a visible position. And we also noticed in the beginning of presentation keyboard toolbar, and we also can rebuild it. We can utilize keyboard sticky view to make our toolbar be always above the keyboard. And we can utilize a pretty simple API called setFocus2, which basically gives you an ability to move focus from a currently focused input into a given direction, or restore focus if keyboard was already closed. And if we get back for a second to comparison, now we can see that Android and iOS achieves the same parity. Window is not automatically resized on Android. We also have animated transitions thanks to use keyboard animation hook. Rich ecosystem, well, Android doesn't have it, but it doesn't have to, because we can re-implement components such as toolbar ourselves, and we also have interactive keyboard dismissal. Did we cover everything? Well, not yet. Let's consider cases which are even challenging on native development. The first such thing is over keyboard view. Basically, it acts as a model with one simple difference. By default, it doesn't close the keyboard when it's shown, and it shows all its children over the keyboard. It has a variety of use cases. If you're building gallery-like applications, or if you have attachments in your chat-like applications, you can use it. You can use it if you want to show context menus like Telegram does. It looks just perfect. You can use it as overlay for your keyboard to show additional actions similar to what WhatsApp is doing. Or you even can use it as a container for your bottom sheet, which also looks quite good and delivers cool transitions. And in fact, we've considered all components that are designed to kind of avoid keyboard in one or the other way. But in reality, keyboard controller is not about avoiding keyboard. It's about controlling it and even extending it and its functionality. And I'm happy to reveal some upcoming features in keyboard controller that pushing boundaries of what's possible in a React Native. So the first component is called keyboard extender. Basically, it allows you to embed your custom views inside the keyboard and display them right above the keyboard. If you are building a payment UI, you can display a predefined amount of your currencies, and it will make your flow for users intuitive and more faster. Due to platform limitations, it cannot embed certain views like text input, and to overcome this problem, I'm introducing another component which is called keyboard background view. This is a very simple component with one purpose. It should perfectly match keyboard UI. And it can be used in kind of shared element transitions where one element morphs into another state. You can think of it as a canvas for your input accessory views. On a slide, you can see how we can rebuild Safari URL search animations using this component. But you can also build advanced interactions around the keyboard using this component. For example, you can create a component that emerges from the keyboard with meatball animation, and with just a bit of creativity, components like keyboard background view and keyboard sticky view let you go far beyond simple avoidance. You can build rich interactive UI that actually extends the keyboard. And instead of just avoiding the keyboard, you can design experiences that work with it, or even feel like they are part of that. Thank you. And we are landing. Let's make a brief summary of what we've learned so far. We've navigated through a decade of React Native keyboard handling evolution. Just like humanity turning early spacecraft into sleek shuttles, the React Native community turned awkward keyboard workarounds into elegant solutions. With today's tools, handling keyboard doesn't have to be a problem or developer's nightmare anymore. We can confidently say that we have a right tech to solve keyboard handling issues. Second point, do not be shy away from building advanced user experience around your keyboard. In the past, developers may afraid fancy animations fearing keyboard issues, but now armed with tools like keyboard background view, keyboard extender, and other, you can build rich keyboard interactions. Using interactive keyboard dismissal, keyboard toolbar, keyboard avoiding queue, and other components can help you build fluid keyboard interactions, and your users will thank you for a smooth ride. And you, as a developer, can move on to solving bigger problems, because keyboard is no longer a black hole of despair, but instant a well-known part of your application galaxy. Happy coding, and may the keyboard force be with you. Thank you for your attention.
All right, thank you very much. The rumors of my demise have been greatly exaggerated. I already retired once, but I couldn't help coming back to see all of your lovely faces and to introduce my compatriots. The only other Finnish person. Are there any other Finnish people in the room? Oh, yeah, okay. Well, we'll see you at the after party for sure. I don't know how you Polish people feel when you meet another Polish person abroad, but Finnish people, you know, we're a little suspicious. You know, it's like, wait, you're really from there too? But then it's very easy to verify because our language is weird and et cetera, and that's why I'm really here. I did try to drill his name into Nathaniel's head back there, and it just was not going anywhere. So I reckon it's easier for me to just come and do the job and let Nathaniel rest. So in a moment, we'll be introducing our final speaker of the day. He'll be here telling us about how to monetize your application, which is something that I personally am very passionate about, money. And so, without further ado, I would like for us to all give a big welcome to Perttu Lähteenlahti.
Oh, nice. All right, yeah. Last talk of the day, and I'm the only thing standing between you and beers. And there's still quite a lot of you. So you must either be really into in-app purchases, or you all came here to listen to my sexy accent. In which case, I'm the treat. But in other case, you're in for a treat if you're really into the in-app purchases and monetizing your app. And I have the humble goal today to just teach you how to make more money with your app. So introducing myself a little bit, Perttu Lähteenlahti is my name. I'm from Finland. That's a very Finnish name, although it sounds like I'm having a stroke. It's completely normal. And yeah, I work as a senior developer advocate at RevenueCat, where we make developers make more money. And before all that, I used to build mobile apps with React Native and Flutter, and I technically still continue that at RevenueCat. Here you can see actually a few of them, I've built streaming apps with React Native, I've built health apps with React Native, and cancer treatment analysis apps with React Native. So I know a lot about React Native in those contexts, but also about in-app purchases. And you can find me on socials with that thing, or just go to my website. It's easier that way, instead of navigating with my difficult name. So yeah, so what this talk today is going about is of course been about monetization. So first of all, it's very important to talk why you should care about monetization. That will give us the basis. And because you're developers, I'm going to give you a few points why you specifically should care about it. And once we've done that, we're going to look at how to actually monetize. We're going to talk about something like in-app purchases. And once we have that business basis established, we're going to show, or I'm going to show, you're not going to show anything, how to do that with code and a little bit of setup, and actually how easy it can be. But to get to the subject, so why talk about money? And I'm going to give you two reasons. First is that in order to build your apps, you need to eat. And to eat, you need money. And you can get money by selling your app. So unlike this developer here, this very unhappy customer thinks, Apple and Google will not pay you to put your app in the App Store. You actually have to do something about that. And actually, it's not even as simple as that, because they're actually going to make you pay for it. So you have to pay to have an app there, which you probably already knew. But they're also going to take a cut of all the sales that you do using in-app purchases. So you kind of have to think about it if you're going to monetize your app at some point. But there's a second reason, which I think is the more exciting one. And it's the fact that React Native apps make the most amount of money. They actually make more money than Flutter apps, and they make even more money than native apps. And to give you a little bit of background for this, So we at RevenueCat did a survey on all the 7,000 subscription apps we have on our platform. And these were the results. So you can see there's native apps. They're making an all right amount of money, like on median, like 50 cents and so on. But React Native is like overperforming all of those. And that was like, even for me as a React Native developer, quite a surprising thing. And there are, of course, multiple ways to think about why this happens. Could be that React Native apps, just like you get them faster to the market, and you can actually figure out what users need faster than with the other types of apps. But I like to think about it is that you just take this picture, and the next time someone comes to you and is like, React Native is not native enough, you can just shut them up by saying, say that to my wallet. So yeah. But there are other insights that we could also pull from this. So React Native also leads in conversion rates. So apps that you download that are built with React Native, users are more likely to subscribe on React Native apps than any other platform. The same thing is like, okay, if you have a 1-year retention, so user has been using your app for 1 year, they're slightly more likely to churn out using React Native than native apps. We still overperform Flutter. And that's probably because native apps usually tend to take more use of native features like app clips and whatnot. So there's your second reason to do like really native stuff with your React Native app. And then, but however, despite that, React Native still has the highest like long-term revenue per user, outperforming both Flutter and native apps, and then the other category. So we can state that React Native is great for building apps that users actually want to pay for. So then, of course, we get to the question, how do we monetize our apps? And we have a few different strategies for that. The first one is the traditional way of doing this. The buy to download, or as I would say, buy a porky in a sack. So you're not really knowing what you're actually getting, but you just shell out money, and then you get to download the app. And this is how, when app stores first came out, you would pay for apps. You would pay for them. You might have a demo version of the app there as a free, but usually you didn't even have that. You would just have to shelf the money and base it on someone else telling you that that's a good thing. Then you can, of course, take that app and slap it full of ads, which is also in like one strategy. Usually you come across this on Android. And personally, I think it's not really good, because most of those ads that you tend to see there are for either mobile games or cheap Chinese stuff, to be honest, which like kind of turns it into Temu-led development. And then there's, of course, the last option, so in-app purchases. And this is a topic we're going to talk a little bit more about, like what these actually are. So the fundamental concept of in-app purchases is that you move the purchasing process from actually downloading the app to further down the funnel. So it could be that user has already like tried it out, they've used it a few times, they've tested out the features, and then you ask them that, hey, you like this, you should pay. And you actually don't necessarily let them, like you have Duolingo, for example, you can't let them use the app to its full extent without subscribing. You get the ad version. And this works usually way better than any of the other ones for monetizing your app. Because then you're no longer buying something that you don't know what it actually has and how it actually solves your problem. And in-app purchase is just an umbrella term, so there's actually multiple different in-app purchases. There's the consumables for one-time repeating purchases, there's the non-consumables for permanent access, and then subscriptions for recurring revenue. And let's look at these more in the detail, like when you should use each of these. So first, the consumables. These work in a way that you pay per use, and you have to consume them afterwards. So they're very common, for example, as virtual currencies, or, for example, game elements when you have a game where you have to buy potions or whatnot. And once they're consumed, user gets something in the app, and next time they open it, for example, it's gone. They can't use it anymore. It's very good for mobile games, because if you have a good dopamine hook, you usually get people, or at least children, to really go down on this route. I wouldn't personally say there's like a good moral way of doing in-app purchases, but it is one way, and games tend to do that. Then you have the non-consumables. These unlike the name says, they don't get consumed. So once you buy them, they stay with the user until they stop using the app. Or even if they don't remove it and install it again, they are technically eligible for using those. So you can use that for permanent access, lifetime subscriptions or whatnot, or just one-time upgrades like, okay, unlocking a theme or something like that. And in Apple ecosystem, these things are also shareable, such as the subscriptions that we're going to talk next. So when one of your family members buys it, you get it in others. And I think Google has something similar as well. And then there's, of course, the subscriptions. And, well, nowadays, almost everything has a subscription format. And I think there's few reasons. One of the main ones is that it's very easy to think of. So you have the value your app provides is directly correlated the times users stay subscribed. So if you have a monthly subscription and they enjoy it for years, then they can do your paying. That's how you end up paying for Netflix. But it's also it's an easier commitment for user. Instead of shelving out a lot of money, they shelve it on a weekly basis, monthly basis, and they can stop at any time. But there's, of course, then a reason for you as a developer to do that, and that's because you also have recurring costs. You usually have a server, you have different kinds of analytics services or whatnot that you need to pay for. So then just putting single price on your app is not necessarily a good way to approach this, as it could lead to that eventually those costs don't get covered by the one-time fixed pricing. All right. And there are, of course, challenges to also getting people subscribed, because users are surprisingly subscription avoidant. It is not uncommon to come across this kind of message that solved my problem, was a great app. 1 star because you have to pay for it. Especially if you have a subscription, then they usually get even more angry. And there's another thing is that in the studies about how many subscription services people have, it doesn't usually go on average beyond 1 or 3. So you're technically competing against Netflix and whatnot when you launch your own subscription app. And you kind of have to take that into consideration when you think of the pricing and also the value you provide. Well, then who makes money with in-app purchases? So this is very simple. This is the only slide I'm going to have about the commission thing, because when VVDC starts in 2 weeks, there's a non-zero chance that this no longer applies. But in any case, if you're a small business, you get to give 85% of the money that you make through in-app purchases until you make 1 million. If you're not that, then you get to make 70%. And in Apple and Google, depending on the platform which you sell or both, they take 15 to 30%. So quite simple stuff. And now you won't be considering that, okay, can I somehow circumvent the in-app purchases? And the answer is unclear. Not really. If you're selling physical goods, no problem. You don't have to have in-app purchase. You can use Apple Pay or whatnot. That's really easy. But if you have digital goods, Apple and Google are both very observant. They might even go to the app that you've already gotten through the review and check that, oh, you've enabled purchasing subscriptions later on after the app was approved, and they might actually block you at that point. And there's one way you can get around this is so-called reader app status, which is only on Apple platforms as far as I know, but it's super hard to get. So that's how, for example, Spotify gets around it. You have to subscribe on their website, and you can only log in. You cannot purchase it on the app. And before the law changed in the US, just 2 weeks ago, you could not even link to the website. You could only say that if you want to make changes to anything, go to the website. Now you can actually have a button that takes you to a Stripe flow to do that. And let's see how Apple, that's only for Apple. Let's see how Google, if they're also required to do that at some point. But yeah, that's the fundamental business logic of in-app purchases. So then we are how to do in-app purchases in React Native. And before I get to that, raise your left hand if you've heard of Revenue Cat. Yeah, most have. But I still decided to put other subscription options here as well. So in order not to toot my own horn too much, so there's a good amount of options. Of these can be usually categorized into 2 categories. The so-called hosted services and the roll your own. And the hosted services usually mean that there's a business around there backing that SDK. So you have to sign up for them. You get all kinds of nice tools and whatnot. But you also have to pay a certain amount, for example, as a monthly price or certain percentage of your tracked revenue to the service. And in order that they then make better tools using that money. So that's pretty clear. But you can also alternatively roll your own. So React Native IAP of the packages on the previous slide is the only one that technically allows you to do that. Because there's no company behind it. However, if you end up doing that, you also have to then run your own server and for example, take care of validating receipts. If you have a multi-platform app, checking that user using an Android can also use it if they purchase it on iOS, and all kinds of those things. But if you're doing really simple subscriptions, like not subscriptions, but in-app purchases, like consumables or non-consumables, you could easily get started with React Native IAP. Or you could build your own using StoreGit and Google Play Billing and just building a native extension. So there are options for it. And next slide, this is the only slide that I'm going to be like selling RevenueCat as a. And this is actually a funny thing. I made this slide before I even worked at RevenueCat. So I don't know if it's like fully oriented towards selling. But I think RevenueCat has a pretty solid documentation. It's free to get started with until 2.5K in revenue, tracked revenue per month. And after that, it takes 1%. So the option is pretty good. And it's, of course, a hosted option. So when you pay for it, you get all kinds of nice things, like dynamic paywalls, A/B tests, and win campaigns and whatnot. And I think you personally should go with the hosted option in most cases, because then that allows you not to be a subscription engineer, but instead you can actually focus on things that matter for the user of building apps that have value. So let's get started with building our first subscription. And before we get to that, there's a few key terms that you need to know in order to use RevenueCat, but also to do subscriptions correctly. So you first have the products. These map to the subscriptions you have in the App Store. In RevenueCat, they're called products. You can have multiple of them. They can be mapped to different stores, like Play Store and App Store. And then you have entitlements, which is technically a collection of products that entitle the user to do these things. If you think of like real-life examples, in Netflix, when you have like the family package and then you have the individual package, one of them having higher resolution, those are entitlements. So you can always upgrade from one entitlement to another in order to unlock more features. In the app that I'm going to show, there's a single entitlement. It's the Pro level. And then there's going to be a paywall, which is basically a UI element that just shows you the different options that you have for purchasing, and it disappears once you've done the purchase. So how to add subscriptions? First, you need to, of course, upload your app to the App Store or Google Play Store. And once you go there, you need to configure your products and then connect RevenueCat with the API keys in order to manage them between the devices. And managing App Store Connect, for example, is pretty simple. You go there, you add the subscriptions like this, and that's it. You need to provide a little bit of background information, but technically the setup is pretty simple. Once you've done that, you need to connect it with RevenueCat, and then copy the products to RevenueCat. And this is actually made pretty simple, so you only have to basically import them. You don't have to do that anymore manually. That used to be the old way. Now you can just like automatically get them when new products are added. And once you've done that, we need to add like single entitlement to our app, which this contains, as you can see, contains 2 products, gives access to all the stuff in the app. And then we're just going to use that entitlement in our paywall. So to look at a little bit how simple this is to do in terms of code. So say you're starting a project from scratch. You decide to run the Expo command to build that app. You only need to install React Native purchases from RevenueCat. Then you need to do, because React Native purchases doesn't work on Expo Go. It's just missing the native code for those parts to work. So you need to have a development build. So once you've done that, you can just run pod install or whatever and have a working version. And the only thing you need to have in terms of code to have user logging, checking if the user is set up correctly and whatnot, is to import the purchases and call the configure with your API key. And you have different API keys depending on if your app is on iOS or Android. So you have to use, for example, platform select to do that. And once that is done, you can put a paywall anywhere in your app. So in this case, I have the main app code. When you open the app, it will instantly show a model blocking the user from doing anything. And then I've imported RevenueCat UI from RevenueCat Purchases UI. And I'm going to show quickly soon why that is done, because this allows us to do a paywall without actually having to code anything for the paywall itself. So that is the only amount of code we need for the paywall to show up. And then we can actually go to the RevenueCat's dashboard and customize the paywall in whatever way we want. And there's a bunch of different options, pre-made templates that we've made for you that you can just use directly in that case without having to build it, code it yourself. And I don't know why you would even want to do, because you probably would like to do these so that they're dynamic. You don't want to show the same paywall for every user. But if you want, you can build custom paywalls. That is also allowed. You just then call certain methods. Like, for example, here. With the code that we just showed, we could get this kind of a paywall working without any other changes. We don't need more than that. If you click the buy, it hides itself. You can access the image in this case. And then you can just check if user is actually eligible. So you can see here the code after purchasing. For example, if you have built your own paywall, you just check that if the purchase info contains the correct entitlement to show those things in your app. So that's pretty simple. And I don't think it can get really simpler than that. All right, so to recap, we've now talked why to monetize. So why making money is important. And of course, then how to monetize by showing different. And then we looked at how to monetize with in-app purchases. So pretty simple stuff. I hope you've learned something from this. Or if this made no sense, come find me at the after party. I'm pretty sure after a few beers, these things make more sense to you or me or whatever. And if you just want to talk about your app, I'm also really interested in hearing about that. Thanks, that's all I have. And that's you can find an article version of this from that link, yeah.
Thank you. Thank you very much, Perttu. Now, please, could I ask everybody to stay seated just for 1 minute? We have a very, very important task to do, which is that we want to thank some of the people who have been working very hard to make this conference happen.
Good
hi.
to be back.
Oh, hey.
I thought I'd bring some fun.
Hey. Eye contact, man. You got it.
Nastrodanya.
What? What did you say?
Did I say it wrong?
You said Nastrodanya. That doesn't mean anything. It's Nastarovia.
Nastarovia.
All right, cheers.
Thank you. Well, folks, thank you so much for joining us. We are getting started a little bit early, but at the after party, you would also be able to join us in a drink or two. But first, we do want to say a bunch of thank yous, and I'm always really worried that I'm going to forget some names that I do want to call out in particular. So I'd like us to all give one more final round of applause to some special people who made this conference possible. And that is to Martina, Kaya, Magda, Alicia, Cassia, and Paulina. Can you join us on stage, and can we give them a round of applause? These are just a few of the many faces that make a day like this possible. A big thank you to all of them. A big thank you to all of our technical team. A thank you to all of our speakers.
I think Paulina has a mic. I think she wants to say something.
Yes.
I wanted to thank our MCs for covering all of our screw-ups.
Oh.
And it's not the whole team that worked on the conference, so thank you to everyone who's not on the stage but helped. Thank you. And you for coming.
Awesome. All right, so we're going to have a break before, not a break here, but you folks can go, get changed, get refreshed, grab something to eat, and we'll see you at the after party at 7 p.m.
7 p.m.
And we can have a drink.
Wait. One more thing. There's one more group of people we need to thank.
Yes.
It's the audience.
The audience, yes. Can you give yourselves a round of applause?
I know this
You're
is
at
very
home.
hard for your Slavic
a standing ovation for yourselves.
Round of applause.
That is awesome.
All right.
Thank you so much.
Thank you. It's a day of learning, and let's have fun.
I'll see you on the stage next year.
Yeah.